Hey grade 12s and welcome to this video. So in this video we're going to be working on the June 2022 NSC Mathematics Paper 1. Okay, so the first question we have question 1 and let's get into it. So in 1.1.1 we have been given a trinomial and we have to solve for x. So we're going to just open up two brackets equated to 0 and ask yourself what multiplied by what is equal to x squared. So that is x multiplied by x. And then what multiplied by what can give you negative 15, but in the middle when you add it, it needs to give you 2. So think about that like this. 3 times 5, that gives you 15. So it needs to be negative 15, meaning one of it needs to be negative. So to make sure that the middle stays positive, okay, the final answer is positive, give the negative to the smaller number. So if you have negative 3 and this is a positive 5, then you see that negative 3 plus 5 is positive 2. And that's how we have that positive 2 in the middle. So our factors are negative 3 and positive 5. So x is either equal to 3 or x is equal to 5. Okay, moving on to the next question. We have 1.1.2, which says we have 5x squared minus x minus 9 is equal to 0, and they ask you to leave your answer correct to two decimal places. So you know that when you see that, it's already a hint saying quadratic formula. So we're going to use the quadratic formula. So here is the quadratic formula. Okay, and remember it is in the formula sheet as well. So we can also just have now x is equal to negative, and let's just figure out what a, b, and c are. So a is equal to, as you can see, it's the x squared. Remember, it's in the form of ax squared plus bx plus c. So a is the 5. So a is 5, b is, well, whatever is in front of x, and there's actually an invisible 1. Okay, so negative 1 is b in front of x, and then of course the constant, the one without an x, is negative 9. So let's go ahead and just substitute that in. So I'm going to say negative, because of that, minus bracket negative 1 plus minus the square root of the negative 1 all squared minus 4 bracket a, which is 5, c, which is negative 9, all over 2 multiplied by a, which is 5. And I'm going to start off with a negative because it's a smaller solution. Okay, so the first answer I get is where x is equal to, round off to two decimal places, that's negative 1.25, rounded off to two decimals. Okay, so once in a while I will pull up this calculator because I don't want to just put in the answers and then just show it, just in case I make a mistake, because I'm human, I can still make mistakes. So I just want you to be able to still retrace in case I have made a mistake here so that you can just check. Or we're going to also have x is equal to, and I'm going to change that negative into a positive, so plus, and now we get 1.45 as well. So that rounds off to two decimal places. Okay, so those are two easy marks that you can get. Moving on to the next question. Okay, 1.1.3, we have x squared is less than or equal to 3x. Okay, so this is a weird looking inequality. A common mistake is to go ahead and divide both sides by x. Please never divide by x. The thing is, we don't know what x is. X could be anything. X could be 0. If you divide both sides by 0, if 0 is the denominator, this will become undefined. So don't divide both sides by x. What you can do is take this 3x over. So look at what we have. We're going to have x squared minus 3x is now less than or equal to 0, because that's what will be on the right hand side. Then now let's compare the x squared with the negative 3x and see what is common between these two, because we have to factorize it to simplify it. So we can take out a common factor of x and then open a bracket. So what multiplied by x will get you back to x squared? That will be x. Okay, or you could even just say x squared divided by x. Then I'm also going to say the second term, negative 3x divided by the x. Technically, I'm not dividing by the x. I'm just trying to find out what do I multiply to x to get back to this. It's just easier to say divided by. So negative 3x divided by x will just be left with a negative 3 is less than or equal to 0. Okay, so this is what we have. We have this and we have to solve for x. We're going to have two critical values. It's kind of like in the equations when you have x bracket x minus 3 is equal to 0. You see, we're saying something multiplied by something is equal to 0. It's either that this x is equal to 0 or that this x minus 3 is equal to 0. And then, of course, you'll take that over, and so x would be equal to 3, right? That's if it was an equation, but this is an inequality. But the thing is, we kind of do the same thing in order to find what we call our critical values. So we're not really solving for x, we're just finding the critical values. So in this case, I'll leave that empty and also leave that empty. And I'm just really saying here less than or equal to 0. And I'm not solving for x here. So now that it's like this, I have two critical values. I have either that we have x and 0 or I have x and 3. So these are our two critical values, 0 and 3. Now, this is still a quadratic inequality, okay? So if you put it as a graph, it's going to form a parabola because it's a quadratic inequality or quadratic expression on this side. And notice that this parabola, looking at the fact that, look at this, right? This is a. The value of a will be in front of x squared. As you can see, that is positive. There's an invisible 1 in front of this. So it means that this is a positive parabola, a parabola that is concave up. So basically, we have a parabola like this, and we're going to just have to find for which values of x will this expression be less than or equal to 0. Okay, so that's the parabola we're referring to. When we draw the parabola, you're just going to put down an x-axis. And when you put down your x-axis, we're going to put down our two critical values. The first one is 0. That's the smaller one, so it will go on the left. Then we have the 3. Now remember, this inequality says for which values of x will this be smaller than or equal to 0. That's what we need to solve for. So we're looking for the parts of this graph that have values that are less than 0. So imagine it like this. If you had a y-axis, so this part will have y values greater than 0. We're looking for y values that are less than or equal to 0. So we're going to have to take everything that has, every part of the graph really, that has y values down here. So that would not be any of these. It will not be this or that, because you see these parts of the graphs, look at their y values. They're all positive. So we're only going to take everything that is here below the x-axis. That's what we're going to use. And now if I try to find out what are the x values that belong to these points, these would be the x values. Okay, but before doing that, it's just something we need to also just put here. Remember that this inequality says that less than or equal to 0. Okay, so because of that, it's really just saying when we take this value and we put it in here, this as an x value, and we put it into this equation, does it give us something equal to 0? Now you can go ahead and do that. You can substitute 0 in here and you will see that it will give you something equal to 0. And so because of that, it means that x is equal to 0, because when we substitute 0 in place of x, we do get an answer of 0. Same thing with here. When you substitute 3 in place of x here, you will get a 0. So you can put a line under for that. And that's for the equal to part. Now let's work on the direction of the inequality. Based on what we have shaded, let's line this up to the x-axis so that we can see which x values they belong to. So if I line a point like this up to the x-axis and that, and keep going, okay, and let's say we just highlight all the way, line all of these points to the x-axis. Notice the 0 part. The 0 part, like if we're looking at this x-intercept over here is 0. But the x values that we're getting, they are what than 0? These are values that are greater than 0. Do you notice that they're moving on the right-hand side of 0? Okay, so that's how we're solving for this part over here. We're saying that x is either greater than or equal to 0. And we're going to do the same thing for the 3. We're looking at the 3 and we're looking at the x values that we have matched now to the x-axis. And what are they compared to 3? These are x values that are less than 3. Okay, so less than 3. So I'm saying that x is either less than or equal to 3. And you would also notice that the arrow, okay, the direction in which these x values are, will kind of also help you with your inequality. You see, less than, okay. And with a greater than 0, see, greater than. Okay, so there's one more thing you need to do now. Notice that these x values are actually pointing towards each other. And since they are pointing towards each other, it means that they're actually speaking about a related set of values. They're not values that are just completely in different directions. So we can actually write them together. And when we write them together, we can go ahead and do this. We say, therefore, you put x in the middle, you put the smaller number here and the bigger number here. And now you're going to compare with the 0 and the x. What is the inequality facing? Remember, we have a line under for both of them. But compare the x and the 0 over here. The inequality, the mouth, okay, when I say the mouth, I mean this open part over here. That refers to the mouth of the inequality. Where is the mouth facing? You see, the mouth is facing the x. So when I draw it here, I'm going to draw the mouth facing the x. And then with the 3, when we look at the x versus the 3, where is the inequality facing? Notice that the mouth is facing the 3. So we're going to draw it facing the 3. So what this inequality is saying is that x is greater than or equal to 0, but less than or equal to 3. And that's really what this is. You see its values that are in between 0 and 3. Okay, so that's how to solve that inequality. Next question. And if you want to learn how to factorize inequalities and trinomials, you can go on my channel. If you go to the videos, this video over here basically teaches you how to factorize trinomials and even ones with difference of 2 squares. So it's a 2-hour video because I also included activities in it. So you can check this video out so that it will help you with basically your question 1 trinomials kind of questions, inequalities, and even equations. Okay, so we have 1.2, and 1.2 says given a plus 64 over a is equal to 16, and the first question we have to solve for a. Okay, so this is one that pops up once in a while. When you have this situation and you need to solve for a, try to identify the problem. What is stopping you right now in this equation from solving for a? That would be this a on the denominator. This a is a problem. To get rid of that a on the denominator, the only thing to do is to multiply by a. But because this is an equation, what you do on the one side, you must do on the other side. So when we have our equation like this, we're just going to multiply both sides of the equation by a. And so this is what's going to happen. Over here, the a multiplies to that a and becomes a squared. Over here, the a multiplies to this. And remember, it's really just a multiplied by 64 over a. Okay, they will cancel diagonally because this is really over 1. And so that will cancel with that. And so you're left with a 64. So positive 64. Let me just keep that in black. And then that is equal to 16 multiplied by a, which is 16a. Okay, so from this, you see that this is going to actually become a trinomial because we have a squared, we have a 16a. So let's take the 16a over to the left-hand side. So we'll have a squared minus 16a plus 64 is equal to 0. And we have to factorize this. So let's go ahead and open up 2 brackets, make it equal to a. So what times what gives us a squared? Okay, so that it would be a multiplied by a. And then what times what would give us 64. But we'll have to have a negative 16 in the middle. Now the thing about this is, notice that everything is positive except for the middle term. When this happens, when only the middle is negative, notice that this and that will both be negative. In your brackets, these two will be negative. So let's think about numbers that can actually give us a negative 16 that are factors of 64. Okay, so if we say 64 divided by 4, we get 8. So really what I'm saying is that 4 times 8 gives you 64. So let's try other factors of 64. We could try 8 times 8. So 8 multiplied by 8 gives you 64. And if you said negative 8 minus 8, that would give you negative 16. So you see that the factors are negative 8 and negative 8. So minus 8 and minus 8. Okay, so as you can see, there's really just one solution for this. It's a minus 8. So a minus 8 is either equal to 0. Therefore, a is equal to positive 8. We have one solution. This is one root. It's just being repeated. And in terms of delta, we call these equal roots. Okay, so that was the first question. We've solved for a. Next question. Then the question following that is hence solve for x. And we have this exponential equation. So the fact they're saying hence, it already means that this has a lot to do with what we just solved for. So let's just keep that in mind. Okay, so if I have 2 to the power of x plus 2 to the power of 6 minus x is equal to 16. First thing you can do to make this much more simpler is to break up that. Okay, so that exponent, we can actually break it up. And when I say break it up, this is really what I mean. You see, if you said 2 to the power of x multiplied by 2 to the power of y, the rule of exponents basically tells you that if the bases are the same and you're multiplying, you need to add the exponents. So that will become 2 to the power of x plus y. So you see, when it's like this, you can separate it simply by saying this is going to be 2 to the power of x multiplied by 2 to the power of y. That's how this came about. So we're going to use that same rule. Okay, so it's really like the reverse of that. So we have just 2 to the power of x here, then plus, and when we separate this, it's going to be 2 to the power of 6 multiplied by, notice there's a negative x here, so multiplied by 2 to the power of negative x, okay, is equal to 16. Okay, so now focusing on this one, because that needs to be changed. That is going to, if you want it to become positive, this is a rule that you have to also remember. If you have 2 to the power of negative 1 and you want that exponent to be positive, currently this number is on the numerator. So it's really like 2 to the power of negative 1 as a fraction over 1. If you want that exponent to become positive, you need to move this entire number, the base and the exponent, to the denominator. And so when we do this, it becomes 2 to the power of positive 1. And then on the numerator, you have a 1, a placeholder of 1. Okay, so please do not see it as if they swapped places. They didn't really swap places. Okay, they don't swap. That 1 is still there just as a placeholder, as if it was the 1 that was in front of this 2 to the power of negative 1, that invisible 1. And there's a reason I'm saying it doesn't swap, because sometimes you may have something like this, and then people will say, okay, this becomes 2 over. No, it doesn't become 2 over 2 to the power of 1. They didn't swap. You see, this base does not have a problem. Its exponent is positive. It's an invisible positive 1. It wouldn't move to the numerator. All that would happen in this case is that this number would move to the denominator. So you would just have on the denominator first this 2 to the power of positive 1, then now multiply by this one becoming a 2 to the power of also now a positive 1. And on top you would have that placeholder of 1. Okay, that invisible 1 in front of this number. Okay, so that is a very big difference. I just said that so that you don't make that mistake. Okay, so when we want to make that x positive, what we're going to do is we still have 2 to the power of x plus, and you see that these two numbers are being multiplied by each other. So you can kind of see them as if they're just together. And they're currently just together on the numerator. So if we look at it like that, what actually happens is this one does not have a problem. It's 2 to the power of 6. It's okay. The exponent is positive. So it will stay 2 to the power of 6 on the numerator. The one that goes to the denominator is this one. See, because they're one term together, they're being multiplied. So over, that now becomes 2 to the power of a positive x. Then is equal to 16. Now you're going to notice something here. Notice that 2 to the power of x and 2 to the power of x are being repeated. When you have an expression being repeated, you can use the letter k to replace this repeated expression. So what I can say is let k be equal to 2 to the power of x, so that this will be easier to solve. So we'll solve it as k first, then we'll go ahead and solve it as x. So in place of 2 to the power of x, I'm going to replace that with k. So I have 2 to the power of x, that is k, plus 2 to the power of 6. We can go ahead and just find out what that gives. And that is equal to 64, similar numbers to the previous one, over, and we have 2 to the power of x, which can just become k, is equal to 16. So if you see what's going on here, and you look at this, it's exactly the same thing. You see a plus 64 over a, and then is equal to 16. Same situation. We just have the same problem now with k. So we need to get rid of the problem, which is this denominator of k, by multiplying both sides of this equation by k. So multiplied by k and multiplied by k. And this is what we're going to have. We're going to have a k squared And then, of course, when that multiplies, the k's cancel on the denominator, and we have a positive 64 is equal to 16k. Taking the 16k over again, so k squared minus 16k plus 64 is equal to 0. And now we don't have to think about the factors because you saw the previous one. Those factors were really just a minus 8, a minus 8. So this one is going to be k minus 8 and k minus 8. So it just means that k is equal to 8. And now we can go ahead and solve for x. So k, we replaced k with 2 to the power of x. So let's put it back. So k is now 2 to the power of x, which is now equal to 8. And this is an exponential equation. The whole goal of an exponential equation is to make the bases the same. It's really to make either the basis or the exponents the same. So here we can say 2 to the power of x, and let's write 8 as a base of 2. That would be 2 to the power of 3. And so you see the bases are the same. It therefore means that the exponents are equal. So x is equal to 3, and that is our solution. Okay, so that is it. Hence, we solved for x. Moving on to the next question. Then the next question, 1.3, we have, without using a calculator, calculate the value of this. Okay, so with this kind of question, you see that on the numerator, you have two terms inside this square root. And then on the denominator, you just have one term. Weirdly enough, we have a 17, which is a prime number. So, we can't really multiply this and actually get a number on the calculator. So the goal here is to get 2 on its own, to make that become one term on the numerator, and this on the denominator is already one term. So we can go ahead and do that by taking out a common factor on this numerator. So what's common between 2 to the power of this and that? It will obviously be the smaller number that is common. So this is what we can do. This will be equal to, we have again the square root of, and I'm going to take that out as a common factor, meaning in both of these terms we have 2 to the power of 1002 that can go into both of it. So if I open the bracket and say, what must I multiply to this 2 to the power of 1002 to get back to this first term here again? Well, it's the same thing, so I just have to multiply by 1. And then what do I have to multiply to this to get back to this in here? Okay, a way of looking at that is by saying this 2 to the power of 1006 divided by 2 to the power of 1002. And so because you're dividing two numbers with the same basis, all you need to do is subtract the exponents. Okay, it's positive, so I have a plus, and of course the base was 2, so the base is still 2. So what is 1006 minus 1002? Remember, it's really just like saying, what do I multiply to this to get back to that, okay? Or saying this divided by that. So as you can see, there's a 1000 and 1000, which you subtract. 6 minus 2 is 4. So that just becomes a 2 to the power of 4. Over the 17 multiplied by 2 to the power of 998. Okay, this is equal to, we have again the square root of, and then 2 to the power of 1002 multiplied by 1 plus 2 to the power of 4. 2 to the power of 4 is equal to 16. So it means we have 1 plus 16, which is 17. You see, over 17 bracket 2 to the power of 998. Then we can go ahead and cancel the 17s out because we're dividing. And then we can also divide these two numbers. We still have the square root, and then we have 2 to the power of 1002 divided by 2 to the power of 998. The bases are the same, so the exponents are going to be subtracted since we are dividing. So it's really 2 to the power of 1002 minus 998. Okay, so subtracting that, I'm just going to say it as 998. How much do I add to get to 1002? So that will be 2 more numbers to 1000, 2 more numbers to 1002. So that is 4. So when you subtract those, it gives you 4. So this is all we have here. 2 to the power of 4, okay, being square rooted. And so this is just equal to 2 to the power of 4 is 16. So it's really the square root of 16, which is equal to 4. And that's your final answer. Okay, moving on to the next question. Then we have 1.4 saying, solve for x and y simultaneously. And we have two equations. in simultaneous equations, you see here we are given a linear and then we are given this equation which kind of looks like the equation of a hyperbola. Okay, but all that matters in this is when you're given a linear and another one, you need to take the first equation as your linear. So we're going to call this one equation 1 and this one equation 2. So out of equation 1, we will create equation 3. Since we just have 2x minus y is equal to 2, you see that y is the only number here being put, well, the only variable being put alone. It doesn't have a coefficient in front of it. Well, it has 1. We can take that over. So this will be now we have 2x, and I'm going to go ahead and take the 2 over to this side. And we have minus 2 is equal to, that negative y goes over and becomes a positive y. So you see, this is our equation 3 now. And then from here onwards, it's really just becomes substituting. We're going to substitute equation 3 into equation 2, the one we did not even use yet. So wherever you see y, just replace that with all of this. Okay, so there's y. So we're going to just say 1 over x minus 3 multiplied by 2x minus 2, and then that is equal to 1. So just have to simplify this just using laws of algebra. We have 1 over x and we have minus, and I'm going to multiply this in. That's going to be a minus 6x, and multiply that in. Negative 3 times negative 2 is positive 6 is equal to 1. So I'll put things with x's on one side and the other ones without x's on the other side. So these two can just stay, and then I'm taking the 6 over. So we have 1 over x minus 6x is equal to 1, and then that becomes a negative 6. 1 minus 6 is negative 5. Okay, so looks like a similar problem as the ones in the first question. We have an x on the denominator. We can get rid of that by multiplying both sides of the equation by x. So I'm going to multiply that by x and multiply that by x. Okay, so this is now going to become, if I multiply that in, it's like saying x multiplied by 1 over x. The x's would cancel, and so you're left with just 1. So 1, and then multiply that in. X multiplied by negative 6x is minus 6x squared is equal to, and then we have, of course, the minus 5x. Okay, so you can see this is going to become a trinomial. And in this trinomial, you should make the thing that has, okay, the expression that has x squared, make that positive. So let's take that over instead. So what we're really going to have, I'll take everything over to the right-hand side. Now this, which was negative, becomes positive 6x squared. This is already on the right hand side, so minus 5x. And this 1 is coming over to the right hand side, so minus 1. And of course we have a 0 here. Okay, so we have to factorize now. So when factorizing this, it's not like the usual ones. This one, you kind of have to use another sort of method to factorize this. So what I use is a method called the cross method. So I'm going to look at the factors of the first term. What times what gives you 6x squared? Okay, but I kind of also just want to have a 5 in the middle. So what I'm going to take is 6x and x. When we multiply those, you get 6x squared. And then factors of 1, which of course would just be 1 and 1. Now we have to put this in a way that one of the ones is negative, so that when you multiply them, you get the negative 1. So to choose which one to put as negative, all you can do is this. Let's go ahead and cross multiply it first, and that's why it's called the cross method. So I'm going to say the 6x multiplied by the 1, which is equal to 6x, and then the x multiplied by 1, which is equal to x. Now comparing these two, which one should have a negative so that we can have negative 5 in the middle? Okay, so if 6x was negative and this was positive, then negative 6x plus x would give you negative 5x. So however we created this 6x, that should get the negative. We created a 6x by saying 6x times 1. So this one should take the negative and that one should take the positive. So it means our factors, and it works out and it can be factorized because you see we got the middle term. Okay, so it means that our factors are really just the 6x plus 1 and the x minus 1 is equal to 0. Okay, so these are our factors. We can simplify and solve for x. It means that 6x plus 1 is either equal to 0, or x minus 1 is equal to 0. Solve for x, 6x is equal to, take that over negative 1, divide both sides by 6, and x is equal to negative 1 over 6, or x is equal to taking the negative 1 over positive 1. Okay, so we got our solutions for x. Now these are equations though. X is equal to negative 1 over 6 and x is equal to 1. We stopped at equation 3, so I'm going to call these equation 4. And the last step is to solve for y. Okay, to solve for y, I'm going to substitute this equation 4 into equation 3 because equation 3 has y nicely as a subject. Okay, so when we do that, we're just going to have y is equal to 2x minus 2. And let's go ahead and substitute. Okay, so y is equal to 2 bracket in place of x negative 1 over 6 minus 2. Okay, y is equal to, if you multiply this, you can go ahead and do it on the calculator. So when you multiply this, this is going to give you simplified a negative 1 over 3, then minus 2. Okay, you can also put this on the calculator, but I'm just going to do it manually. So I need to put this as that is really just negative 7 over 3. Okay, so that's the first y value we get. Or y would be equal to 2 brackets, and the x value we have here is 1. 1 minus 2. Okay, and so that's really just 2 minus 2, which is equal to 0. So these are our two solutions. It's either that x is equal to negative 1 over 3 and y is this, or x is equal to 1 and y is 0. Okay, so those are solutions. And that is, of course, the last question for question 1. And you see that is 26 marks. Hi grade 12s and welcome to this video. In this video, we're going to be going through the Gauteng June 2022 Maths Paper 1. Okay, so question 1, we have x squared is equal to negative 4x. Okay, I know that when you see an equation like this, it can be tempting to just go ahead and divide both sides by x. Now, the reason you shouldn't do this is because we are solving for x right now. So we don't know what x is. X could be equal to 0, and if you divided both sides by 0, then your equation is going to be undefined. Because if you divide anything by 0, your answer is undefined. And so that's why you should avoid dividing both sides by 0. So what we can do is, or dividing both sides by x, what we can do is just look that we have x squared on this side. Since this is already positive, we can go ahead and take this over. So we have x squared plus 4x is equal to 0. Okay, we have two terms on this left hand side, and in both terms x is common, so we can take x out as a common factor, and then we're going to have, you can simply say x squared divided by x. That's going to give you x. That is what you need to multiply to x to get back to x squared. And then you can also say 4x divided by x, and then this positive 4 is equal to 0. Now, I want you to remember that this is exactly the same as having x plus 2 multiplied by maybe x plus 4 being equal to 0. And the same way we take these and we equate them both to 0 is exactly what we're going to do here. Now, why are we doing this over here? Remember, they're saying something multiplied by something is equal to 0. So, if you have something times something and gives you 0, it means that either one of them must have been 0 in order for you to get a 0, because anything multiplied by 0 would give you 0. The same way 0 multiplied by anything would have given you 0. So we're saying that either one of them is equal to 0 in order for you to multiply them and get a 0. That's why we're going to go ahead and say here x is either equal to 0 or x plus 4 is equal to 0, since they're being multiplied. And so here x is equal to 0 or x is equal to negative 4. Okay, and then 1.1.2, we have x squared plus x minus 1 is equal to 0. And they say correct to 2 decimal places. Okay, so the minute they're already telling you that, you have to use the quadratic formula. So we're going to go ahead and just say x is equal to, and put the quadratic formula. Okay, and now we're just going to substitute. So we have minus b, and so whatever b is here. It's a positive 1, an invisible 1 that is here. So negative 1 plus minus the square root of that our invisible 1 squared minus 4. A is also a 1, positive 1. And then c is a negative 1, so negative 1, all over 2 multiplied by our positive 1 of a. Okay, so when I'm putting this into the calculator, I'm just going to start with a negative first. Okay, so this is what we get, and I only start with a negative 1 because it's a smaller factor. It's a smaller answer. So we get a negative 1,618, but remember we need to round off to 2 decimals, so that will be negative 1,62. So x is either equal to negative 1,62 or x is equal to, just go ahead and change that into a plus, and we get a 0,618, so that is 0,62. So x is equal to 0,62. And there are our solutions. Okay, moving on to 1.1.3, we have the square root of x plus 4 minus 4 over the square root of x minus 2 is equal to 0, and we have to solve for x. Okay, so this is an equation involving surds. In this equation, the first thing you should try to catch on to is, what are we trying to do? We're trying to solve for x. Since we're trying to solve for x, find what is stopping you from solving for x right now. So in this equation, I know there are surds, yes, that is actually stopping us from solving for x, but there's something that is a bigger problem. It's not really this surd that is that much of a problem. It's this one, because it's on the denominator. So we need to get rid of this first. And how we get rid of this, because this is being divided by square root of x minus 2, we can just multiply both sides by the square root of x minus 2, so we can get this out of the denominator. Okay, so we're just going to multiply both sides by the square root of x plus minus 2, sorry, not plus, minus 2, and then also multiply that by the square root of x minus 2. Okay, so let's see what we get now. So this, we have two terms inside this bracket, and so this one term is going to FOIL into these two terms inside the bracket. So we have an x, square root of x minus 2 multiplied by square root of x plus 4. It's the same thing as having the square root of 2 multiplied by the square root of 4. When we have this, what we can do is, since they are both square roots, we can put them under the same square root, and we're saying 2 times 4. That's exactly what we're going to do in this case. So we're going to go ahead and just take this, and we're saying that it's the square root of these two terms being multiplied together. Remember, they're both binomials, they're two terms. So it's going to be an x minus 2 being multiplied by x plus 4. Okay, and then we have square root of x minus 2 being multiplied by negative 4 over square root of x minus 2. So since we have that, what is going to happen is that since we have a square root of x minus 2 on the denominator and the numerator of this number, they're going to cancel. Okay, and this is the reason they cancel. So if we didn't look at it like that, remember you have a fraction being multiplied by something that is not a fraction. So you first have to make this a fraction so you can put it over 1. Since it's over 1, we are saying numerator times numerator, which is going to be negative 4 square root x minus 2 over 1 times that square root x minus 2. And so now you can see the top and the bottom would cancel. And that's why these two cancel. So we're just left with the negative 4. So it's just minus 4. And then is equal to, we have a 0 multiplied by square root of x minus 2, but 0 times anything just stays 0. Okay, so this is what we have. We have a surd and we have a number. When you're solving for an equation that has a surd, you need to isolate the surd. So keep the surd on its own. So we're going to leave this here, x minus 2 and x plus 4, and we're going to take the 4 over the negative 4. So it becomes a positive 4. And then, now that we have this on this side, our next problem in solving this equation is our surd. So we need to get rid of the surd. So we can get rid of the surd by squaring both sides. And so the surd, the square root, and the square would cancel. And so you're just left with an x minus 2 being multiplied by x plus 4 is equal to 16. Okay, so we can go ahead and just FOIL this out. So we're going to have an x squared being multiplied by positive 4x, and then we have a negative 4x, and then we have a negative 8, and then we can just take 16 over and becomes a minus 16 is equal to 0. Okay, and then we're going to have x squared, then it is a positive 4x minus 2x, that just gives us positive 2x. Then negative 16 minus negative 8 minus 16, that is negative 24, is equal to 0. Okay, so now we just have to factorize this. So factorize this equated to 0, we have x times x. And let's think about factors of 24 that can give us a 2 in the middle. So you can simply do this by just taking 24 and dividing it by numbers that you know can go into it. Another thing I just used to do is I can just press shift and the factorize button, but I don't think it's on. Oh, it is here. Okay, shift and fact. So you can see here we have 2 to the power of 3 and a 3. So that's like 8 and 3. Okay, so if you think about 8 and 3, they're not really going to give you a 2. If you say 8 minus 3, that gives you 5. Okay, so that doesn't mean that this is not going to work. That means you can just try, instead of saying 8, remember this is 2 to the power of 3. It's like 2 to the power of 3 times 3. We could also just share that. That means it's 2 times 2 times 2 times 3. So I could try maybe 2 times 2 being 4, and 2 times 3 being 6. I could try the factors 4 and 6. And that actually looks more promising to give you a 2 in the middle. So if you try 4 times 6, it will give you a 24. Okay, also remember that we have a negative 24. The only way you can get a negative number when you multiply two things is if one of them was negative. So where we have the 6 and this 4, it means only one of it was negative. So think about it. We have a positive 2x in the middle. So it must have mean that we had a positive 6 minus 4 to give us a 2, a positive 2. So those would be our factors. Okay, so x is either equal to a negative 6 or x is equal to positive 4. Okay, so here it would seem like we're done, but we're not really done yet, because the thing is with surds, you have to square both sides in order to get rid of the surd. But when you're squaring both sides, there's a consequence for that. It means now before, okay, the answers that we had, yes, we may get one of the answers could be correct. But then the thing is that there's an extra answer here that may not be correct. So you need to check to see which one is not going to work. So you can actually check using the original equation. This was the original equation. And we're just going to go ahead and substitute negative 6 into this. So we're going to have to substitute these values into the original equation, and it should give us 0. So let's try negative 6. So if we tried negative 6 plus 4 and then negative 6. So go ahead and just put that all into the calculator. It should give you a 0. If it doesn't, it's not your answer. Okay, so we're just saying the square root of negative 6 plus 4, and then make sure you just press the side button to come out of the square root, minus, and then we have a fraction, then we have 4 over the square root of negative 6 again, minus 2, and I can already see that that's not going to work out well, because that is going to be a negative number. That's negative 8, square root of negative 8, which is going to make this undefined. Here as well, you can see that we have a negative 6 plus 4. So 4 minus 6, that's going to be negative 2. So this is already making the equation undefined, but this calculator is set on a different setting. So it's calling it I, meaning it actually is solving for it, but then this is not a real number. That's the thing. So in this case, as you can see, we have undefined. X will not be equal to negative 6. So you get an extra mark for saying that one is not your answer and the other one is. So if you try 4, so if we tried 4 and put a 4 here and a 4 here, this is what we would get. We would get 0. And so we can see that, okay, this one is really equal to 0. And so you can say, therefore, x is equal to 4 only. Okay, so that is 1.1.3. Usually they expect you to do this. You will see it in the marking allocations when it's like 5 marks. Usually that's what they want you to do at the end. Okay, next we have an inequality. Okay, so in 1.1.4, we have this inequality. And notice that this is negative. It has to be greater than 0. So we need to solve for x where this will be greater than 0. Okay, I'm not going to FOIL out because I'm going to use this as it is. What we can do is go ahead and just find our critical values. So our critical values, since they say this times that needs to give us something greater than 0, then I'm going to say that x plus 2 is either greater than 0 or negative 3x plus 1 is greater than 0. I'll just find the critical value. So here, our critical value is negative 2. Okay, and then here our critical value, if you just take the 1 over, we'll get a negative 1, divide both sides by negative 3, and we're going to get x and a 1 over 3. Okay, so our critical value is just 1 over 3 and negative 2. Okay, since we have these values, what we can do is draw a number line. We're going to draw a number line. Okay, that's a weird number line. Okay, and then we're going to put down our critical values, which was negative 2 and a 1 over 3. Okay, then you have to think about a number that is smaller than negative 2. And the number smaller than negative 2 would be negative 3. And then a number bigger than negative 2, that would be a negative 1. Same thing we have to do for 1 over 3, a number smaller than 1 over 3. Remember, 1 over 3 is quite close to 0. It's like a 0,333 recurring. So a number smaller than 1 over 3, we could take 0. And then a number bigger than 1 over 3, we can take 1. Okay, so we can go ahead and try these. So what you're going to do is you're going to substitute these into your equation and then find out if it really gives us a value greater than 0. So let's try negative 3. So I'm going to take the equation as it is. I'm going to put 2 brackets. So we're going to have negative 3 plus 2 being multiplied by negative 3. And then in place of x, we'll also put in a negative 3. And then plus 1. Okay, so as you can see, it gives you a negative 10. So it's not working for negative 3 because negative 10 is not greater than 0. It's less than 0. So it's not working for numbers that go this way, that are less than negative 2. So let's try negative 1. Okay, so in place of x, I'm going to put in negative 1. Place of x, negative 1. And we get a 4. Okay, so negative 1 is working because 4 is greater than 0. So it means that our numbers are going this way, numbers that are greater than negative 1. Also, another thing I want you to notice is that this inequality says greater than 0, not greater or equal to 0. So in this case where we don't have or equal to, our circle is not going to be closed, it's just an open circle. So it's moving this direction. And so these are numbers that are greater than negative 2. Okay, so we're saying that x is greater than negative 2. Another easy way to see that is look at your arrow. Your arrow is going to look exactly the same as your inequality sign. It points in the exact same direction. Okay, so we can also do this for 1 over 3. We're going to go ahead and substitute. You can try 1, but it's probably not going to work. 0 will probably work because they're probably pointing towards each other. So you can go ahead, since this is a quadratic equation. Okay, so we can try, if we tried 0. So in place of x, I'm going to put in a 0. And we get a 2. And 2 is greater than 0. So it means that numbers going towards this side are working. So we have a open circle on 1 over 3 because they didn't say or equal to 0. And then the numbers are moving this way, values less than 1 over 3. So follow the arrow, its x is less than 1 over 3. Okay, so now that we have that, okay, you can also try the 1. You will actually see that it probably will give you a negative number. So if you tried 1, See, we get a negative 6. So that is not greater than 0. Okay, so since we know this is our answer, these are our answers. Okay. But I want you to see what's going on with the inequalities, the table. Do you see that these numbers are pointing towards each other? It means that they are talking about the same set of numbers, the same group of numbers. And so we can actually write this together. So only ever do this when you see the inequalities point towards each other. So we can write it as, therefore, we are putting x in the middle, and then you just put the smaller number on here, which is negative 2, and then the bigger number here, 1 over 3. And then let's just look at how the inequality sign was facing. It was saying that x was greater than negative 2. So when you look at x versus negative 2, your inequality needs to face the x. So we draw the inequality facing the x. And then when you look at x versus the 1 over 3, the inequality needs to face the 1 over 3. So there we go. And so that is those are our solutions. So x is greater than negative 2, but less than 1 over 3. Okay, so in 1.2, we have a simultaneous equation, and we need to solve for x and y simultaneously. You have been given, this is clearly a linear equation because we do not have any squared or cubed or anything like that. So our linear equation, always call that as your equation 1. Then we have a quadratic equation here. We have y squared. Okay, it's actually not a quadratic equation of a parabola, but this is going to be our equation 2. Okay, so we have these two equations that we just need to solve for x and y. We can go ahead and we see that y is nicely sitting on its own. It doesn't have any coefficient like a 2 or 3 or anything. So we can make that the subject. So we're going to take y over, and so we have a y is equal to, then we just still have the 3 here, and then plus 2x. And so this is now our equation 3. Then we're going to go ahead and just substitute equation 3 into equation 2. And then in place of y, we're just going to put 3 plus 2x. Okay, so we have our equation 6x plus 4. And then we have y squared. So in place of that, we're just putting a 3 plus 2x all squared is equal to 3 plus, and we have 5x being multiplied by y again, so that is just 3 plus 2x. Okay, so let's go ahead and just simplify that. So we're going to have 6x plus, let me just make more space. Now we have, a squared here. Okay, so we need to expand that. So we're saying 4 multiplied by. Okay, so since we have a squared here, an easy way to multiply this out is simply just by saying we're going to take 3 and square it. So that will give you 9. And then you take 3 multiplied by 2x, and so that will give you a 6x. Then multiply that 6x by 2, and that will give you a positive 12x. Okay, and then lastly, you take the last term and square it, and that will be a plus 4x squared. Okay, so this is a simpler way to do this because it's going to double. Since we have a squared, you're going to end up adding the same number twice. Okay, so that's what we do is equal to, you can go ahead and do it the long way, but this is also another quicker way to save time during your exam. Okay, and then we have a 3. We have a 3, and then plus 5 multiplied by 3, that is a 15x, and then 5x multiplied by 2x, that is going to be positive 10x squared. Okay, so let's just multiply out what we need to multiply out. So 6x, and then we have a 4 times 9, that's like 18 plus 18, 36, so plus 36, and then we have a 4 times 12, which is like 24 plus 24, 48, so plus 48x, and then a 4 times 4, which is positive 16x squared, and then is equal to 3 plus, and then we just have a 15x plus 10x squared. Okay, before taking anything over it is best to just simplify your left and your right hand side. So whatever needs to be added, add that. So let's look through here. Let's look for any like terms. Okay, so we just have a 6x plus 48x. It's like taking a 2, that makes it 50, so 54x. Okay, and then we have a plus 16x squared plus 36 is equal to 3 plus 15x plus 10x squared. Okay, now we can take things over. Notice that we have a 16x squared and here we have a 10x. So it's best to just take everything over to the left hand side since the 16x is bigger than the 10x, just so that you can keep the x squared positive. So we're going to have 16x minus 10x, and that gives you a 6x squared. Okay, and then we have a 54 minus 15. Okay, I'm just going to calculate that. So we have a positive 39x, and then we have a 36 minus a 3, which is positive 33, is equal to 0. Okay. Looking at all of these numbers, they look like they can all be divided by 3. So I'm going to divide both sides by 3. And so here 6 divided by 3, that is 2. So 2x squared. 39 divided by 3, let's just check that. 39 divided by 3 is, okay, 13. So positive 13x. And then 33 divided by 3, that is 11. Okay, plus 11 is equal to 0. Okay, so this is what we have now, and we just have to factorize this. So the method I use is called the cross method, and this is how it works. Everything is positive right now, so it's not really going to be that difficult to work this one out. We have a 2x squared. So we're going to have to think about factors of 2x squared, or what multiplied by what would give you 2x squared. And that would really just be 2x multiplied by x. And then we have to think about the last term. So factors of the last term, what times what gives you 11? Well, that's just 11 times 1. But in this case, it would really depend on how you put it. So 11 times 1, okay? And remember, it's a positive 11. So the only way you can get a positive 11 is by saying positive 11 times positive 1, or negative 11 times negative 1. But how we know it's not negative is because the middle term is positive. So it's both positive. And so this is called the cross method because we're just going to cross multiply. So we're saying 2x multiplied by 1, which gives you a 2x. And then we're saying x multiplied by 11, which gives you a positive 11x. And that gives you a 13x. So as long as you get the middle term, then you know that these factors are correct. So we have a 2x plus 11 and an x plus 1 is equal to 0. Okay, so we have that now, and now we're just going to go ahead and solve for x. So 2x is either equal to 11, divide both sides by 2, and so x is equal to negative 11 over 2, or x is equal to, we're taking 1 over, so negative 1. Okay, so those are our solutions for x. We found x. Now that we solved for x, we need to solve for y. Okay, you can call this equation 4. And so the last step is to take equation 4 and substitute it into the equation of y, which is equation 3. So we're just substituting equation 4 into equation 3. Okay, so we're just saying y is equal to 3 plus 2x, 3 plus 2x. Y is equal to 3 plus 2, and then in place of x, I'm putting negative 11 over 2. Or we're saying that y is equal to 3 plus 2, and in place of x, we're putting negative 1. Okay, so just go ahead and punch that into the calculator. So we have negative 8, so negative 8, or if we substitute a negative 1 in place there, so negative 1, we get a 1. Okay, so y is equal to 1. So these are our solutions for x and y in our simultaneous equation. Okay, and now we are at the last question of question 1. Okay, so this question says, given that 9x squared minus 12 px is equal to negative 4p squared, for which values of p will the equation have equal roots? Okay, let's put down this equation first. So 9x squared minus 12px is equal to negative 4p squared. And so we need to find out for which values of p, okay, will it have equal roots? Okay, so normally this type of question, you're usually used to them putting in a quadratic equation and then just saying something like is equal to k. And then they'll say for which values of k will the roots be equal or something like that. But in this case, they're not really doing that. Okay, we're still going to go ahead and find what delta is going to be for this. Remember, they are asking for equal roots. For you to have equal roots, delta needs to be equal to 0. Okay, so that's what we know about this. And remember that delta is b squared minus 4ac, so that part of the quadratic equation. So b squared minus 4ac just needs to be equal to 0. Okay, so I'm going to just go ahead and put this in a standard form, or more standard form than what it is right now. So we're going to take 9x squared and then minus 12px, and then we're going to take that over, so positive 4p squared is equal to 0. Okay, so let's just establish what a, b, and c is going to be here. Remember, this is an equation that we are going to focus on x. We're going to focus on x because they're saying for which values of p will the equation be have equal roots. Okay, so let's just focus on what a, b, and c are. So here, whatever the coefficient of x squared is, that is a. So that is our 9, that's our a. And then whatever the coefficient of x is, that is b. So in that case, that will be a negative 12p. That is the coefficient of x, whatever is in front of x. And then c is the constant, so the only one that does not have x in it. And so that will be your 4p squared. Okay, so we can just go ahead and put that in. So b squared is going to be, since this is our b, the negative 12p, we are saying negative 12p all squared minus 4 multiplied by a, which is 9, and then multiplied by c, which is 4p squared, okay, is equal to 0. Okay, so let's just solve for this equation. So we have negative 12 squared, which is 144. And then p squared is just p squared. And then we have, okay, I see numbers. So let's just multiply these numbers. Negative 4 times 9 times 4. Okay, so if we just say negative 4 times 9 times 4, we get negative 144. Okay, so the numbers will give us negative 144. And then we had a p squared, see, times p squared, so p squared, and is equal to 0. Okay, we have the exact same term here. So 144p squared minus 144p squared is equal to 0. So 0 is equal to 0. That's what our equation is saying right now. Okay, so remember the question was for which value of p will this have equal roots? So to understand this, an equation is like a statement. It's like, for example, I could say x plus 2 is equal to 5. So x plus 2 is equal to 5. It's a statement that is true, but for a specific x value. So x plus 2 really is equal to 5. That's if x is equal to 3. Then the statement is true. Okay, so that's what an equation is. When an equation is equal on both sides, meaning, okay, so to get to there, let me just explain something else. Let's say I said, okay, let's try x being equal to 1 instead in this equation. So if you said 1 plus 2 is equal to 5, that would not be true. 3 is not equal to 5. And that's because there's only one specific answer for x in this equation. You only have that x is equal to 3 and then that's it. There's nothing else. Because then the left hand side and the right hand side would not be equal if you tried anything else but 3. In this equation, notice the left hand side and the right hand side are equal. When this happens, it means that your answer will work regardless of whatever number you try. As long as it is a real number, it's going to work. So with this equation, if I tried 144 and then in place of p, let's say I just tried 1 squared minus 144, 1 squared, I would still get a 0. If I tried 144 times 4 all squared minus 144 times 4 all squared, as you can see, I'm subtracting the same thing by the same thing. I'm still going to get a 0. It means that p is going to work for every single number as long as it's real. So our answer for this, let me just erase all of this. Our answer for this is that p is an element of real numbers. It's just going to work for every single number. So you can say the equation will have equal roots for all real values of p. As long as it's a real number, it's going to work. So in question 1, we are given in 1.1.1, we are given this equation and we need to solve for x. Okay, so with this question, something that you should always notice when they give you an equation, you should always check if one hand side is equal to 0. And as we can see here, the right hand side is equal to 0. So this is what we're going to do. Remember, what we have is that 2x being multiplied by x squared minus 1 is equal to 0. So if you have two things being multiplied by each other and they give you 0, it just means that either one of them must have been equal to 0. So it could be the case that 2x was actually, the final value was 0. So it's like 0 being multiplied by that. And that would of course give you 0 because anything times 0 stays 0. Or it could be the case that 2x was just 2x being multiplied by that being 0. And so you would have gotten a 0. And that's why we're going to go ahead and say that it's either that 2x is equal to 0 or that x squared minus 1 is equal to 0. So the one thing here is just make sure that one hand side was equal to 0. Okay, so in this case, solving for x, we'll just go on to dividing the both sides of the equation by 2, and so therefore x would be equal to 0. And here what we have is x squared minus 1. Now you can view this as difference of two squares, or you could also just do this. So let's leave the x squared on this side and we're going to take the negative 1 over. So we have x squared is now equal to positive 1. Then we need to solve for x. So we need to get rid of this squared. So we're going to square root both sides of the equation. But the thing that you need to remember with square rooting both sides of the equation is that you need to include a plus and a minus here. So x is going to be equal to positive or negative 1. And just to remember, the reason we add the plus and minus is because this is an equation and it had that x squared was equal to 1. So when we have x squared, the degree of the equation basically tells you how many possible solutions you have for this equation. So in this, we cannot just say 1 is the answer because yes, if you say 1 squared, you do get 1. But if you say negative 1 squared, you also get 1. So you have to include both. So these are our solutions. In this case, clearly we have three solutions. It's either x is equal to 0 or x is equal to 1 or x is equal to negative 1. And then moving on to the next question. Next question is 1.1.2 and we have this, we need to solve for x. And they already tell you correct to 2 decimal places. And you can see it's for 4 marks. So this is a case where you have to use the quadratic formula. Okay, so with this question, the key to really solving equations is to really focus on the goal of the equation. The goal of all these equations is to solve for x. So we need to get x to be on its own. We need to find a way to solve for x. So looking at the way this equation is right now, they do also give you the restriction that x is not equal to 0, of course, because this x is on the denominator, and if it was equal to 0, it would make this undefined. Okay, so how you have to solve for x here is, think about the fact that you want to solve for x. Right now, what is stopping you from solving for x? What looks like a problem right now? So this looks okay, that looks okay. The problem is this. because x is on the denominator, it's kind of stopping us from solving for x. So what you can do is ask yourself, how do you get rid of an x on the denominator? Or you could actually phrase this question as, how do I get rid of this if the 2 is being divided by the x? So the x is the problem, and the x is here because the 2 is being divided by the x. The only way you can get rid of this is to do the opposite of it. Instead, multiply by x, since we can see that the 2 is being divided by x. But because this is an equation, what you do on the one side, you have to do on the other side. So what we can say over here is, we can go ahead and say we are going to multiply this hand side by x, and we're also going to multiply that by x. And then this is what happens. We have one term here being multiplied by 3 terms, so it's going to FOIL in x times x. That's going to give you an x squared, and then we have the x times the negative 6, which is a negative 6x, and then of course we have the x times this, okay, 2 over x. And so this is what happens. You have your x being multiplied by the 2 over x. So that we just have two fractions, I'm going to put this x over 1, because every whole number or variable is actually being put over 1 if you want to put it as a fraction. So if you look at the way this is, look diagonally. Since we are multiplying, we are able to cancel x like that diagonally. So another way we could have done this is by saying the x multiplied by the 2, and that would have given you a 2x, and then the 1 multiplied by x, which would have given you an x. And so you see that x is common and it would cancel, and that's how you'll be left with 2. So you can go ahead and cancel it out like that and see that, okay, you just have a 2 here over 1, so it's just 2 as well. Okay, so that gives you a positive 2 is equal to 0. So now you see that we have a trinomial, and because they said correct to 2 decimal places, we have to use the quadratic formula. So here's the quadratic formula, and then we're just going to go ahead and substitute our a, our b, and our c. So our a is clearly 1 because that's an invisible 1 in front of the x squared. Our b is the negative 6, and our c is the positive 2. And then let's see what we get. So on the calculator we get this, but remember you just have to round off to 2 decimal places because that's the instruction that they give you on that instruction page. So we can go ahead and say that x is equal to, I'm going to take the decimal form, so 0,35, and as you can see the 4 is going to round down, so it just stays 35. So 0,35, and this is when I put the minus. I always start with the minus because it's a smaller value. And then, or if we change that to a plus, so then x would be equal to 5.645, but that would round off to 65. So 5,65. And that's our answer for that one. Okay, and then next we have 1.1.3. We have these two binomials being multiplied by each other, and it's greater or equal to 6. Okay, so with this question, remember that you can only start taking these brackets and equating it to the number here if the number over here is 0. Sorry about that. If the number over here is 0. But in this case, this number is 6. So you cannot do that. So what we have to do is multiply these out and then take the 6 over. So we're just going to say the x multiplied by x, which is going to give us x squared, and then the x multiplied by positive 4, which is positive 4x, then negative 1 times x, which is negative x, and negative 1 times 4, which is negative 4. And then we're taking this positive 6 over to the left hand side, and that's going to become a negative 6 is now greater or equal to, nothing is here now, so it's 0. Then let's just go ahead and simplify this. We have x squared, then the 4x minus x is going to give you a positive 3x, then negative 4 minus 6 is negative 10 is greater or equal to 0. Now here comes the part where you have to factorize, but the truth about this is that you don't really need to know how to factorize in order to still get your full marks here. And one of the reasons that will help you more is because you just have an x squared here. You don't have a 2x squared or 3x squared. You don't have a coefficient in front of x squared. So first I'll start with the method where you have to factorize. So if you wanted to factorize this, just open up 2 brackets and we're still saying greater or equal to 0, then since we have x squared, we're going to say x and x. And now here, since we have negative 10 as our last term, we're going to think of two numbers that when you multiply them, they will give you negative 10, but they will be able to also give you a positive 3 in the middle. So factors of 10, that can be 2 multiplied by 5, right? But then, or one of them has to be negative basically. But how can we write them so that when we add them together, they can give us a positive 3 in the middle? So you could have said 5 minus 2. So positive 5 and negative 2. So that's one way you could have factorized it. And so we're going to lay down our critical values. It would just be the x, and we're seeing this as if you had to take x plus 5 and make it equal to 0 just to find the critical value. You would have taken the 5 over and gotten a negative 5. So you don't have to include this step. Then we're saying, or we have x and we're going to take the negative 2 over and get a positive 2. Okay, so this would be a case that you did factorize. Even if you didn't know how to factorize trinomials, you could still get your full marks here. So this is what you could have done. You could have used the quadratic formula. So with a pencil, just don't show them, because if you show them, then it's kind of like you are already telling them I didn't factorize. So you can actually just put the quadratic formula on the calculator instead and put in your values for A, B, and C. So like this, for example. So I put in all the values in the quadratic formula and you see that I get an answer of negative 5. That's your answer over here when you're laying down your critical values. So that's what we get over here, right? So that's what we get over here. Now, how to just put it back as a factor? You just open up a bracket and say x, and if when you found the answer it gave you a negative 5, then as a factor it must have been a plus 5. Likewise with this one, if I change that to a plus, you're going to see I get a positive 2. So I know my critical value is x and positive 2, so it means that as a factor it must be x minus 2. So that's just something you could have done if you didn't want to factorize. But I do think it's quicker to factorize than to use the quadratic formula though. Okay, so now that we have our critical values, we have to now solve for these inequalities. So in grade 12, they don't really expect you to use the grade 11 method of solving for inequalities. The grade 11 method is where we draw that number line and then we put in our critical values down. But in the grade 12 method, they don't really, if you look at the marking allocations in grade 12 or the marking guidelines in grade 12, you will notice that they do not really give you that whole number line. It's because they don't really expect you to work it through like that. They expect you to work this through as if it is a graph, because it is. So this forms a parabola, and the parabola is saying x squared, the equation of it is x squared plus 3x minus 10. So first you have to ask yourself, what kind of parabola is this? Is it smiling or is it upside down? Okay, because x squared, the coefficient is 1, it's positive, so your parabola would look like this, right? So it is an concave up parabola. And we don't even need the y-axis, we just need the x-axis. So we have our x-axis over here. And now the x-intercepts that we have are literally these values here. So we have the negative 5, and over here we have the 2. Now remember that this inequality says greater or equal to 0. So you need to first of all check. When you substitute negative 5 back into this equation, does it give us a value equal to 0? And we can go ahead and check that. And you can see it does give you a value equal to 0. And this is something that you don't have to actually check. Because if it is a parabola and these are your factors, then this is a factor of this equation. Of course, if you substitute it, it will give you 0. Okay, so we know it gives us 0. So we can go ahead and put a line under it for equal to. Likewise with the 2, if you try it, it will also give you 0. So put a line under it for the equal to 0. Now we just have to find out which direction it goes. And this is the easy part. In this part, all you have to do is focus on what the inequality is saying. It's saying it needs to be greater than 0. We've already dealt with the equal to 0. But this parabola, we're looking for the places where the parabola is greater than 0. And this is where the graph comes in. So this greater than 0 is speaking about a y value. So the y values, we want to know on this graph, where are the y values of this graph greater than 0? The y values are on your y-axis. You never really draw a y-axis. I'm just doing it so that I can explain this part. So this is your y-axis. The y-axis is divided into two parts. A part that is smaller than 0 and a part that is greater than 0. And all we are doing is finding on the graph, where does the graph have y values that are greater than 0? So all we have to do is actually find the parts of the graph that are greater than 0. So let's look throughout this graph. So over here, look at this part of the graph. Does this part of the graph have y values that are greater than 0? So definitely not, because if you look at this like a point on here and you look for its y value, that's a y value that is smaller than 0. But if you went to the upward parts of the graph, I always start from the left. So here, you see this one, the y value is greater than 0. Here it also have a y value that is greater than 0, y value greater than 0. Now we have to answer them in terms of x. So we are saying, what are the x values that belong to these parts of the graph that have y values greater than 0? And if you map it down, so I'm going to map it down, I had this point, map it down to here. If I map that down to here and I map that down to there, I'm looking at what are these x values compared to -5, since -5 is your x-intercept. So these values, if -5 is over here and these values are here, these are values that are smaller than -5. They are moving towards that direction, towards the left. Okay, so that's how we answer the -5 part. These are y values that are smaller than -5. And then we're going to do the same for the 2. So if we look at the graph again, and we're looking for y values greater than 0. So here, all through here, you see these are y values smaller than 0. So we cannot take any of these parts of the graph. But the minute we reach here, you can see here, these y values, they have y values greater than 0. So since these have y values greater than 0, you have to tell them what the x values of these parts of the graphs are. So if I have this point over here with a y value greater than 0, what is the x value compared to 2? Again here, what is this x value compared to 2? And you can see now that these values are going this way. These are values that are greater than 2. So we can go ahead and answer them. X is greater than 2. Okay, now the last thing to just do is just check if your values are related. Is there a relation between your values? And in this case, no, there is no relation because the values are facing in completely opposite directions. This one is facing that way, that one is facing that way. They are not pointing towards each other. And so this is just your final answer. You do not need to write it as one inequality. So that's 1.1.3. Okay, and then moving on to 1.1.4, as you can see, we have a surd. Okay, so this is an equation with surds in it. Now, in this equation, you notice there's something different about this equation with surds. Notice that you have the square root of x minus 2, and on the denominator, you also have the square root of x minus 2. And when you see this, we have to use a method called the K method substitution. So when you see something being repeated in your equation, we're going to take that thing and make it equal to K. So we're going to say, let the square root of x minus 2 be equal to K. So wherever we see square root of x minus 2, we're going to replace it with K, just so that it will be easier to solve for this equation. So I see the square root of x minus 2, I replace it with K. So we're just going to have K. And then after that, we have a plus 3. So plus 3 is equal to 10 over square root of x minus 2. We replace it with K. So this is the equation we have. And first, before we solve for x, we need to solve for K. Now, solving for K in this equation, just like the one that we had, it wasn't here, it was in this one. So over here, right, where we have that variable that we want to solve for in the denominator. Since k is on the denominator, we're going to have to multiply both sides by k to get rid of that k on the denominator, because that is stopping us from solving for k. So it's an equation. What you do on the one side, you also do on the other side. So now we're going to have, when we multiply those, that's going to be k squared, and then multiplied by 3 would give you a positive 3k, is equal to, and so here, remember this is k over 1, and the k's would cancel diagonally because we're multiplied. Then we have 10 over here. Now we can go ahead and take the 10 over, so we have k squared plus 3k minus 10 is equal to 0, and this looks very familiar, so it seems to be the same factors as the one in 1.1.2. And so here we just have to factorize. So you can use the quadratic formula, or you could also just manually factorize it. So we're going to go ahead and open up two brackets, set it equal to 0. We have k and k. Then we need factors of negative 10 that can give us 3, and that will be positive 5 and negative 2. So therefore it means that k is either equal to negative 5 or k is equal to positive 2. Okay, and now we solve for k. Okay, but remember in this equation, we actually have to solve for x, not just k. So k was just to help us. The main goal is to solve for x. So remember in the beginning, we let k to be equal to this. So we're just going to replace this back here now, since that was k. So we're saying now that the square root of x minus 2 is equal to negative 5, or again, k is this, so the square root of x minus 2 is equal to 2. Okay. Now with this question, if you see that the square root of something is equal to a negative number, that already looks weird. That should never happen. If you square root anything, so if I square root 4, it gives me a positive 2, right? If you square root, even if this x was like a really big number, even if it was 100 minus 2, you're still going to get a positive number. So there's no way you can square root something and then you get a negative answer. But don't worry, you didn't even need to know this to be able to get the answer right. So from here already, I would have already cancelled this out. But I will actually just take it further just to show that even if you didn't cancel it out from here, you'd still be able to find the answer. So from here, x already has no solution. There's no way these two are equal. The square root of something can never be negative. But I can also just take it further and show you why it's not going to work. Let's say we were just still working this out. So in order to get rid of the square root, we would square both sides. And when you square both sides, this square root now cancels with the square because they are the inverse of each other. So we now have the x minus 2 is equal to, that will give you 25. And so x is equal to 25, and then that becomes a positive 2. So 25 plus 2 is 27. Okay, so here the answer we're getting is that x is equal to 27. Okay, or here, again, we also want to get rid of the square root, so we will square both sides, and we'll have that x minus 2 is equal to 4. Okay, x is equal to 4, and that comes over, becomes a plus 2, so x is equal to 6. This is how you would have found out that this one was not going to work. And this is something that you should always do when you have surds. Always check that your answer is correct. So we're going to try the x is equal to 27. And substitute that back into the original equation as it is. So if we are substituting, this is the original equation, x was supposed to be here. But since x is equal to 27 for here, let's try and see if it's true. So if you replace 27 here and 27 here, here this is saying 27 minus 2, but the square root of that, 27 minus 2 is 25. The square root of 25 is 5. So this is 5 plus 3, which is 8. Okay, and we're saying that it's equal to 10 over, again, 27 minus 2 is 25. Square root of 25 is 5. So that's 10 divided by 5, which is 2. You see, 8 is not equal to 2. And that's how we know that x is not equal to 27. So even if you didn't see that that was not possible over here, if you checked if both solutions were correct, then you would have found out that that's not true. You get an extra mark for checking which one is valid and which one is invalid. And then we can also just go ahead and check the 6. Okay, so here instead of the 27, now we have the x is equal to 6. So if you had 6 minus 2, that's 4. The square root of 4 is 2. 2 plus 3 is 5. And this is supposed to be equal to 10 over the square root of 6 minus 2. 6 minus 2 again is 4. Square root of 4 is 2. So that's 10 divided by 2, which is 5. So even if you had put this on the calculator, you see 5 is equal to 5. The equation balances out. The left is equal to the right. And so therefore, that means that x is equal to 6 only. Okay, so you have to actually show them that you're invalidating this one, and here you're saying that this one is your solution. You get an extra mark for that. Okay, moving on to the next question. Okay, so our next question is in 1.2. Solve for x and y, so simultaneous equations. So with simultaneous equations, they're quite simple. All you have to do is identify the linear equation and identify the other one. So here we have two equations. All you have to do is identify the one that is the linear one, and we're going to call that equation 1. So this is linear, so we're going to call this the equation 1. And this one is the second one, so we'll just call that equation 2. So we're going to take equation 1 and form a new equation, equation 3. So we have x minus 2y is equal to 1. And just look for which letter can easily be made a subject. It would be x in this case because it doesn't have a coefficient. So x is equal to, taking the negative 2y over, it becomes a positive 2y. And the 1 is still positive. So now this is your equation 3. Then you have to substitute this equation 3 into equation 2. So wherever you see x, you're going to replace it with 2y plus 1. So we have 2x squared. So we're going to have 2, open a bracket and say 2y plus 1 all squared. Then minus xy. Now in this one, it's best to just write it like this. Since the x is first, just write it as minus y, and then in brackets, put what your x is supposed to be. So minus y, and then in brackets, the x is now 2y plus 1, because that's our equation for x. So 2y plus 1. And then continue, we have minus 5y, that doesn't have an x. So minus 5y, then minus 3y squared, minus 2 is equal to 0. So here, just be careful as you're working with this. Try not to make any mistakes. So here we have 2. Now, in this bracket, the reason why it is best to use shortcuts and just use methods that are quicker to simplify is so that you can avoid making mistakes. So I'm going to show you how to simplify a trinomial, or really a binomial that's been squared. If you ever have something like this, x plus 2 all squared, all you have to do is first square the first one, which is going to now be x squared. And then, so instead of rewriting it as x plus 2 multiplied by x plus 2 and then foiling out, these kind of things can lead you to making mistakes in equations that look this big. So this is a quicker way of doing this. You can just say x squared, square the first one, square the last one, and put that at the end. So that was going to be a plus 4. Then to get the middle term, you just say the first term multiplied by the second term. That's 2x. Then take that and multiply it by 2, and that will be 4x. And that's how to simplify that in a quicker way, just so that you can avoid making any mistake. Okay, so we're going to do that with this now. So we have our first term, square the first term. If you square this, that's 2 squared, which is 4, and y squared, which is just y squared. Square the last term. 1 squared is just positive 1. And then to get the middle term, you say the first term, 2y, times the second term, 1. So that is 2y. Then take that 2y and multiply it by 2. And that is going to be a positive 4y. Okay, so that's how we get that. Then we have this over here. You can already start foiling out from here. So negative y multiplied by 2y, that's negative 2y squared, then negative y times 1, which is negative y. And then, of course, we have the minus 5y minus 3y squared minus 2 is equal to 0. Okay, so here we can start foiling out. That is going to give you 8y squared plus 8y and plus 2. And then over here, already start searching for like terms. So here I see a negative 2y squared and I see a minus 3y squared. So those will go together. Negative 2y squared minus 3y squared is negative 5y squared. So I'm done with those. In a pencil, what you can do is lightly scratch out the ones that you're done with so that you don't confuse yourself. And then we have the y's now. So negative y and minus 5y, and that will give you a negative 6y. So I'm also done with those. Then we just have the negative 2 is equal to 0. And then, of course, still look for more like terms. In this one, we have the 8y squared and minus 5y squared. So that is going to give you a 3y squared. Then we're looking at the y's. We have a positive 8y minus 6y, which is going to give you a positive 2y. And then lastly, as you can see, this is a positive 2 and a negative 2, and those would cancel. 2 minus 2 is 0. So that is gone and then is equal to 0. Okay. So this is where our equation is leading us to. We have y squared plus 2y is equal to 0. Notice that in both terms, we have the common factor of y. So we can take y out as a common factor, and then we're going to have 3y remaining. Remember, just say this divided by the y. So 1y will cancel, and you're left with 3y. Again, positive 2y divided by y, the y's cancel, you're left with positive 2 is equal to 0. Okay, now you have something multiplied by something is equal to 0. So it's either that y is equal to 0 or that 3y plus 2 is equal to 0. So here we have y is equal to 0. Here we're just going to simplify this. So 3y is equal to negative 2. And then divide both sides by 3. Then y is just equal to negative 2 over 3. So these are two solutions for y. And this will account as our equation 4, since we already had 3 equations so far. So first we substituted 3 into 2. Now we're going to substitute 4 into 3. So you see the pattern is quite easy. 3 into 2, 4 into 3. So we're going to substitute equation 4 into 3. So our equation 4 into 3. The equation 3 is this. X is equal to 2y plus 1. So since we have that x is equal to 2, and then in place of that we're going to put y plus 1. So the first equation for equation 4 is where y is equal to 0. So when y is equal to 0, let's find out what x is. So in place of y, we're going to put 0. So x is going to be equal to 2 times 0 is 0 plus 1 is just 1. So where y is equal to 0, x is equal to 1. Then we have or, again, x is equal to 2, and then we're putting in y this time as this negative 2 over 3. So in place, we're putting negative 2 over 3, and we're going to have x is equal to, so negative 2 over 3, we're just seeing this so we're just going to see this like this. This 2, since it needs to multiply to a fraction, let's also make it a fraction. So we can put it over 1. So when you're multiplying fractions, you multiply numerator with numerator, denominator with denominator. So on the top, we're going to have negative 4 over 3 and then plus 1. So you can put this on the calculator, but I would also just do this instead. I would change the plus 1 so that the denominator is 3. I'll change the plus 1 to a 3 over 3 instead. And so we can have negative 4 plus 3. So that's like saying positive 3 minus 4, which is negative 1. So that's negative 1 over the denominator stays the same. So that's our answer. X is equal to negative a third. So that is our answers for the simultaneous equation. Okay, moving on to the next question. So here 1.3, we are told given this 2 to the power of x plus 1 plus 2 to the power of x is equal to 3 to the power of y plus 2 minus 3 to the power of y, where x and y are integers, determine the value of x and y. Okay, so now that we have this down, first of all, since we have to solve for x and y, the goal here would be to try and simplify things. And when you're trying to simplify things, the first thing we'll be doing here is trying to see what is common throughout. So if you look at this first part, we have 2 to the power of x. I also see 2 to the power of x being repeated here as well. And here we have 3 to the power of y. And you see 3 to the power of y is also being repeated. So what we can do is separate these and make them have their own bases first. So I'm going to rewrite this as we have 2 to the power of x being multiplied by, that plus 1 came from 2 to the power of a positive 1. Remember, if the bases are the same and we are multiplying, you need to add the exponents. That's how we got from this to this. So I'm just separating them so that they can have their own bases. Then we have plus 2 to the power of x. It's just easier to do it this way so that you can easily see the common factor. Is equal to, I'll do the same thing here. So 3 to the power of y being multiplied by 3 to the power of 2. Then minus 3 to the power of y. Okay, so again, remember, these are the common factors. So we're just going to take them out as common factors. So here I'm taking out 2 to the power of x. So 2 to the power of x, open a bracket. In the first one, what do you have to multiply to this to get back to this? So of course you have to multiply it by this. It's the same thing as saying this divided by this. So we're left with the 2 to the power of 1, but we don't have to write that one. Then we have a plus 2 to the power of x. So if you said this positive 2 to the power of x divided by 2 to the power of x, that's just going to give you a positive 1, because it's like, what must I multiply to this to get back to that? It's the same thing, just multiply by 1. Is equal to, again, take 3 to the power of y out as a common factor. So 3 to the power of y, open up a bracket, and we're going to have, what do we have to multiply to this to get back here? 3 to the power of 2. And then we have the negative 3 to the power of y. So we're going to have this divided by this. And as you can see, they're the same thing. They would cancel, and you just be left with minus 1. Okay. Now things are actually looking much more better because we can see numbers now. This is a number here that can be simplified. This can also be simplified. So let's simplify those numbers first. We have first a 2 to the power of x being multiplied by, that becomes 3, is equal to 3 to the power of y. And then 3 to the power of 2 is 9. 9 minus 1 is 8. So multiply by 8. Okay, now that we have it in this form, our bases are being multiplied by each other. So look at the pattern that we have. We have over here, we have a 2, then we have a 3. Then here we have a 3, but here we have a 8. So is there a way that we can make 8 have a base of 2? So 8 can be written as a base of 2 because 8 is equal to 2 to the power of 3. So we can do that. Change 8 into 2 to the power of 3 so that they can have the same bases. Okay. So we're going to say 2 to the power of x multiplied by 3 is equal to 3 to the power of y multiplied by 2 to the power of 3. And now this pattern is going as the base is 2, here the base is also 2, and here the base is 3, and the base is also 3. Remember, these things are being multiplied by each other. So they're saying 2 to the power of x multiplied by 3 is equal to 3 to the power of y, or let me actually put it in the same order. I'll put the 2 first. 2 to the power of 3 multiplied by 3 to the power of y. This, for you to understand this is exactly the same thing as me saying, if 2 to the power of x multiplied by 3 is equal to 2 to the power of 6 multiplied by 3, then what is x? Now in this case, you'll be like, okay, but they all look exactly the same, so x must be 6. And that's exactly what you have to do here. Look at the fact that we have 2 to the power of an x, but over here we have 2 to the power of 3. So it means that because all our bases are the same. We have a base of 2 and 3 and they're being multiplied by each other. It means that x is equal to 3. And here we have 3 to the power of an invisible 1. And here 3 to the power of y. And they're being multiplied, you see. So it means that y is equal to the 1. The only way you would not be able to do this is if this had a plus. So 2 to the power of x plus 3 is equal to 2 to the power of 3 times 3 to the power of y. Then you can't say they're the same. But here they are the same because we are multiplying these two bases, and over here we have the same bases being multiplied. So the exponents are equal. Okay, moving on to the next question. Okay, so 1.4, the equations of x squared plus rx plus m is equal to 0 and x squared plus mx plus r is equal to 0 have real and equal roots. And they put in equal in capital letters, probably to emphasize this in the fact that you're going to have to use this. Solve for the values of r and m if r is greater than 0 and m is greater than 0. So also some restrictions on r and m. Okay, so let's go for this one. Okay, so in this question, because they're saying that these two equations where r and m are both missing in both, they have real and equal, big emphasis on the equal roots. Okay, and we have to solve for r and m if r is greater than 0 and m is greater than 0. Because they're emphasizing about the roots being equal, you have to look at what deals with the nature of roots, whether you have equal roots, whether you have unequal roots. The only thing that deals with the nature of roots is delta. And remember, delta is equal to b squared minus 4ac. So what delta tells you is the type of roots that you're going to get. They specifically want equal roots. So I can lay down the different categories of roots that you can get using delta. So if delta is greater than 0, you're going to get roots that are unequal. They will be real, okay? They will be real, but they'll be unequal. And if delta is less than 0, your roots will just be non-real, okay? And if delta is equal to 0, you're going to have roots that are both real and equal. And yes, delta is actually that part in the quadratic formula, this part. Okay, so this part over here, I need to tell you the type of roots that you're going to get. The reason it tells you the type of the roots is because of the square root. When you square root a number, it kind of tells you the nature of the number that you have. Okay, so this part over here. So we're going to go ahead and use this. They want where delta is equal to 0 because they specifically asked for real and equal roots. So that's what we're going to do. And remember, they said that for both equations, that both of these equations have real and equal roots. So we're going to just go ahead and work with this one where delta is equal to 0. So remember that delta, and I'm actually going to split this into two parts. So one part for this equation, the other part for the other equation. So let's go ahead and use delta on these two equations. So in the first one, remember delta is just b squared minus 4ac, right? And we're making delta, b squared minus 4ac, equal to 0. Okay, so in this equation, in the red one, our b is going to be, remember the b is just whatever the coefficient of x is. So here's x, the coefficient of x would be positive r. So our b squared, so this is b, our a would be the coefficient of x squared, which in this case would be our invisible positive 1. And our c is just the only term without x in it. So we have positive m. So this is a, this is c. So let's go ahead and substitute these into here. So we're going to have our r, and that is going to be squared. And then minus 4, and our a is just 1. So minus 4 bracket 1 bracket our c, which is m, is equal to 0 because our delta needs to be equal to 0. Okay, so let's see what we get when we simplify this. This is going to be r squared. Negative 4 times 1 is just negative 4 then times m is negative 4m is equal to 0. Okay, at this point, I usually just stop and then work on the other one and just see how the equations are going to look, which one is better to make something a subject in, and so on. So I'm going to jump over to the blue one, and I'm also going to use delta on this. I will not repeat this because I already know what delta is. So let's go ahead and we know that our A here is going to be our invisible 1. Our B is the M. And our C in this case is R, the only thing without X. So putting delta into this, we're saying the M squared, so M all squared, then we have minus 4, and then A is 1. And of course, C is just the R. And delta needs to be equal to 0. So here we just have M squared minus 4R is equal to 0. Okay, so in both equations, we have a square, but we're basically just trying to solve for R and M in both equations. So what we can do here is make one of it a subject. You can choose here, you can choose to make M the subject, so take 4M over, or you could make R the subject here and take that over. But let's just say we use this one. So we have R squared is equal to, and I'm taking this negative 4M over. Now I have positive 4M. And then to make M the subject, we're going to have to divide both sides by 4. And then we have M is equal to, so that's M, is equal to R squared over 4. Okay, so now that this has been done here, you don't really have to make this one a subject. What we can do is just call this our equation 1, and then that can be our equation 2. So in order to solve for something, we can just go ahead and substitute equation 1 into equation 2. So substituting equation 1 into equation 2. So wherever you see M, replace it with R squared over 4. So here we have M squared. So I'm going to replace that with the R squared over 4. And so that is squared all squared minus 4R is equal to 0. Okay, so let's focus on this part now. So we have R squared being squared. That's going to become R to the power of 4 over 4 being squared. So we're squaring the numerator and denominator, which will become 4 squared is just 16. So we have minus 4R is equal to 0. So here you see that we have to solve for R. Now, personally, I don't like the 16 being here on the denominator. So I'm going to get it out of the denominator by multiplying both sides of the equation by 16. And so now we have that 16 and this 16 would cancel. And so we have R to the power of 4. And then 16 multiplied by negative 4R, that's going to give you a negative 64R is equal to 0. Okay, so still solving for R. Notice that in the first and the second term, R is common in both. So we can take R out as a common factor and open a bracket, and now we have R to the power of 3 left here. Because if you divide those, you're going to get R to the power 3. Then negative 64R divided by R, the R's will cancel. You're left with negative 64 is equal to 0. Okay, and now we can go ahead and just equate them both to 0 because they're being multiplied. So I'm saying that either R is equal to 0 or R to the power of 3 minus 64 is equal to 0. So here, R is equal to 0. Here we have to solve for R. So in this is difference of 2 cubes, not difference of 2 squares. And this is something that I know is actually done in grade 9, and it's easy to forget in grade 12. But this is why you need to revise on every single method of factorizing: difference of 2 squares, difference of 2 cubes, sum of 2 cubes. So this is how we would factorize this. So there's actually 2 ways of factorizing this, but the other way is not going to find your other solutions. So since this is difference of 2 cubes, you could have done this. Open up a small bracket and then a bigger bracket, set it equal to 0. Then you say the cube root of R cubed, which is R, and the cube root of negative 64, which is going to be your negative 4. And then to get the other bracket, you're just going to say this R, square it. That's going to be R squared. and then your negative 4, also square that. That's going to be positive 16. Okay, then you're going to say r multiplied by negative 4, which is negative 4r. Then change the sign to a positive. So that's positive 4r. Okay, so this is another way. So in this case, we're either saying that r minus 4 is equal to 0, or this r squared plus 4r plus 16 is equal to 0. So here r is either equal to 4 or this. Now in this, as you can see, this cannot be factorized because it's all positive first of all, and this is 16. There's no way you can get two factors of 16 that can give you a 4 in the middle. 16 is too big. So this is one of those ones that's going to have to use the quadratic formula. But you actually don't need to do this. The reason why is, if you look at the restrictions they gave you, they said that r needs to be greater than 0. So think about your answers here. The answers that you're going to get here, because everything here is positive, when you have your factors down, I know you cannot actually put them as physical factors because you have to use the quadratic formula to factorize. But even if they could have been put as physical factors, because everything is positive, you must have had a positive and a positive. These type of factors, no matter what they are, when you are simplifying or solving for x, you're going to have to say r plus whatever you had is equal to 0. Then take that thing over and it would have become negative. So r would have been equal to a negative number. So either way, these ones will not even be considered. So I wouldn't even take them from here. From here already, I'm already going to leave those because they said. So I'll just say, but r is greater than 0. And so from here, I'm only going to accept answers greater than 0. Meaning I cannot accept this answer equal to 0. I cannot accept this answer because they will give me negative values. I can only accept this one. So there's actually a quicker way to solve for this r cubed minus 64. So if you took r cubed minus 64 was equal to 0, and you took the negative 64 over, you would have r cubed is equal to 64. If you cube root both sides, you will have r is equal to 4. So this will only give you the real solutions. It will not give you this one. The thing about this one is, even if you use the quadratic formula on this, it would have told you error, because this part would give you your non-real solutions. So you don't actually have to get into that. They only ask for where r was greater than 0. So we can just take this one. So since we have this now, we had our equation 1 and 2. This will be our equation 3. So we found r. So since we have now our equation 3, we can go ahead and substitute it so that we can find m. So which equation had m as a subject? You see, equation 1 had m as a subject. So we can substitute 3 into 1. So putting 3 into 1, m is now equal to, r is 4. So 4 squared over 4. And so m is equal to 4 squared gives you 16. 16 divided by 4 is just 4. So m and r have the same value. Okay, so that's how to find m and r, by using the fact that they told you that the roots were real and equal. So you have to use delta. Okay, so that concludes it for question 1. So we can go ahead and move on to the first question. We have question 1, 1.1.1. Okay, so this is the first question that we have. We have to solve for x, and we have 3x minus 6 multiplied by x plus 2 is equal to 0. You see that this is for 2 marks. Usually it's for 3 marks because there's a step where you have to factorize, but they factorized it for you. So all you have to do is, you see that you have your factors, you see that one hand side is already equal to 0. Just go ahead and equate your factors to 0. So we're just going to say that 3x minus 6 is equal to 0, or x plus 2 is equal to 0. And then we're going to take negative 6 over, and we have 3x is equal to 6. Divide both sides by 3 to solve for x, and therefore x is equal to 2. Over here, we're just taking that positive 2 over, and so we would just get that x is equal to negative 2. And so there are our solutions. Okay, moving on to the next question. Okay, and then the next question, 1.1.2, as you can see, we have another trinomial, but they tell us we need to correct to 2 decimal places. So that means you have to use the quadratic formula, because anything that has decimals, then you know that you don't have factors that are integers. Okay, so with this one, they've already put it in standard form, which is great. So you have on the right hand side a 0. So we're just going to establish what a, b, and c are. So this is in the form of ax squared, of course, plus bx plus c. So we can see this is a as 2, b is -6, and c is 1. So let's just put down the quadratic formula. Remember, this is in your formula sheet. So x is equal to negative, and then we open a bracket, b is -6 plus minus the square root of -6 all squared, and then minus 4, and we have a as 2, and c, as 1, all over 2 multiplied by a, which is 2. And then you can just nicely put this onto the calculator. I will start with the negative, just because it's usually the smaller factor, and then the positive. Okay, and when I put it onto the calculator, I started with a negative. I get a 0,177. So you're going to round off to 2 decimal places. So that is going to be 18. Or x is equal to, and we're just going to change that to a plus sign, and we have x is equal to 2.822, so that just stays 82. Okay, so those are our solution for this question. Moving on to the next question. Also, just remember, your mark allocations go here for your substitution, correct substitution, and for your 2 answers. Okay, they don't really give you a mark for this because you have a formula sheet. Likewise, with this one, your marks would really just go here and here because they factorized it for you already. Okay, 1.1.3, we have an inequality. We have x squared minus 90 is greater than x. And this is for 4 marks. Remember, in order to solve for the inequality, it's like an equation. So first of all, you need to get it in standard form. So I'm going to take this x to the left-hand side, and we have x squared. And I'm immediately going to put it here so that it is in its standard form. So that becomes minus x, and then minus 90 is now greater than, we have nothing here, and that's 0. Okay, this is what we have. We have 2 factors, and we just have to factorize this. Now, you can go ahead and start looking for the factors, or you could just use the quadratic formula to find your factors, okay? But you're going to pretend that you actually factorized it. So you create 2 brackets, then greater than 0. Then on your calculator, this is what you can do. Okay, we already have the quadratic formula, so I'm just going to substitute these values. So remember, we have negative b, so that's our b value. So here, our b value is -1. So I'm just going to put in -1. And then here, we should have b squared, so that's -1 squared. Then minus 4, and then the 2. So remember, that is 4ac, so that's a. As you can see here, a is 1. So we're going to put 1 in there. And c is -90. So I'm going to put -90 there. Then on the denominator, we should have 2a. So a is 1. So I'm going to change that to 1. So you see what I get? And look at how you're going to put the answer in. This is solving for x, okay? That's not just going to be the number here. Here you're going to have x multiplied by x. And then you're going to have your factors of -90. Here we got 10 because this is solving for x, meaning x is equal to 10. But you need to get the factor. So what I'm going to do, it's like taking 10 over. So it's like x minus 10. That is your factor. Okay, this was solving for x. But here is your factor by taking 10 over. So that's minus 10. And then for the other factor, you can just change the sign and you'd find it. So I change that to a minus now, and I get -9. Again, it's solving for x. It's saying x is equal to -9. So if you take that over, then that is actually x plus 9. So that's your factor, x plus 9. Just make sure you don't really show them this part, because then it's just going to defeat the whole purpose of you pretending to factorize. Okay, so there. That's what you're just going to have to do. So we have those now. And now we can go ahead and try and solve for x. Okay, so our critical values is really just like solving for x. X minus 10 is equal to 0. You take -10 over. Our critical values are +10 and -9. But instead of writing down the critical values, I'm not going to do that. I'm just going to put down x and then my critical value, which is positive 10. Or then I have x and my critical value, taking that over, is negative 9. And I'm just going to solve for the inequality so that I can just put the signs in straight away. Okay, so there are two ways for solving for inequalities. There is a grade 11 method, and then there's a method that is generally taught to grade 12s. I'm going to use the grade 12 method here. So all we're going to do is we're looking at the original inequality. Okay, this function is a parabola, and as you can see, the value of a is positive. So this is a concave up parabola. So this is what we have. We have a parabola like this, and all you're going to have to do now is draw an x-axis. And now that you've drawn the x-axis, you're going to put down your critical values in the places they're supposed to be. First critical value is negative 9. That is smaller than 10, so it should be on the left. So I put negative 9 here, and then I put 10 over here. And now we're going to just follow what the inequality is saying. So the inequality is saying that this function needs to be greater than 0. This graph, okay? We need to look for the places where it is greater than 0. So when it is greater than 0, this is referring to the y values. Now, you don't really need a y-axis for this, but I'm just going to put it just to explain this briefly. When we're saying greater than 0, we're referring to the y values of the graph that are greater than 0. As you can see, a y-axis has two parts. It has the part that is greater than 0 and the part that is less than 0. So we're looking for the part that is greater than 0. You're going to look at the graph and look at every part of the graph that has y values greater than 0. So if we're marking that out, you see that on the y-axis, these are the values greater than 0. Look at the graph. If I point it over there, you see that this point on the graph, it has a y value that is greater than 0. This point over here also has a y value greater than 0. All of these points have y values greater than 0. If you move downwards, you see that this point, it has a y value less than 0. So we're not going to include that. I'm not going to highlight that because that's not part of our solution. And all the way around here, I can't include any of these because they all have y values less than 0. I'm looking for y values greater than 0, like the inequality says. And if you look over here, you see that this point, it also has a y value greater than 0. Also has a y value greater than 0 all through. Okay, so this is really what we're going to highlight. I'm only going to be taking, and this is why I said I don't really need the y-axis. I'm going to just erase all of this. All I really am going to highlight is the part of the graph that has y values greater than 0, which would really just be this. Let me just get that out. Okay, so this is really the only thing. It would be over here and over here. So this is something that you can now make a note for yourself. Just remember, whenever they say greater than 0, you're just going to take all the parts of the graph that lie above the x-axis. Okay, so greater than 0 is for above the x-axis. And if they ask for less than 0, you look below the x-axis. So we're only taking these parts. And now we're going to have to find out. So this is just the part of the graph. We need to solve for x. What are the x values that belong to these highlighted parts? Well, to find those x values, I'm going to take each part of the graph and I will line it down to the x-axis and line that down to the x-axis. And now I see that the solution that I'm getting, if we look at that in terms of x, these are values that are, so this is negative 9 here, these are values that are less than negative 9. Okay, they're moving in this direction. And this will help you a lot when you see the direction that it's moving. So for x versus negative 9, I'm saying that x is less than negative 9. And here's where I say that inequality will help you. I want to say that x is less than negative 9. You will notice that the inequality and the arrow in which your solutions are facing is going to look exactly the same. So again, I'm going to line these highlighted parts of the graph down to the x-axis so I can understand their x values. And as you can see, the direction that it's going in the values that are greater than 10. Okay, this is 10 and the solutions are values moving towards the right. So I say x is greater than 10. And again, that inequality, the arrow helps you with the inequality. Okay, and that is how to solve for this. Lastly, just check if there is any relation. When I mean relation is, are these values related? Are they pointing towards each other? As you can see, this one is pointing to the left, that one is pointing to the right. They are pointing in complete opposite directions. They're not pointing towards each other, so we can leave the answer like that. We don't have to write it together like something like that, okay? This is not that case. So you leave the answer like that because they're not related. Okay, moving on to the next question. Okay, and now we are on question 1.1.4, and this is what we have. We have this equation with a surd in it. So whenever you see equations with surd, your one goal, especially if the surd has an x in it, you should try to isolate the surd. Now let's look at the best way to isolate this surd. Well, right now, as you can see, this surd, okay, it is negative. You always take the sign in front of it. It's a negative 7 square root of x. Because it's negative, we can make it positive. We're trying to isolate it, yes, but we can just take it over and leave it alone on this side so that it can also be positive. And then, because we want to leave the surd alone, we can take over the negative 12 to the left-hand side. So we're going to have x, and then the 12, that negative 12 comes over, plus 12 being equal to, that goes over and becomes positive 7 square root of x. Okay, now that it's in this format, you have isolated the surd, you get a mark for that. And then we're going to square both sides to get rid of that number over there. So we're going to square and square. Now when we square both sides here, you can go ahead and simplify this out if you like. You can go and do this method where you say x plus 12 multiply by x plus 12, but this takes too long. So I just work with a quicker method where I take the first term, I square that, that's x squared. And then I'm going to say the first term times the second term, which is 12x, but then you're going to multiply that by 2, which is positive 24x. And then to get the last term, you just square the last term, which will be positive 144. Okay, so that's how we expand that. It's equal to, we have 7 and the square root of x. When you are squaring this, this is what happens. So think about it like this. The 7 and the square root of x are next to each other because they're really being multiplied by each other. Just like if you had 2x all squared, the squared would apply to the 2 and the x. That's exactly what's going on here. It's going to apply to the 7 and the square root of x. So when it applies to the 7, if you have 7 squared, okay, that becomes 49. And here, if you square that root, the roots will cancel. And now you're left with just an x. Okay, and that's where we get that from. And so we can have x squared and then plus 24x. And you can already see this is going to be a trinomial. So let's take this over. So that becomes negative 49x. And then plus 144 is equal to 0. Then we have x squared plus 24. Okay, so we have to calculate this. So what is this going to give us? What is 24 minus 49? 24 minus 49 gives us, okay, negative 25. So minus 25x and then plus 144 is equal to 0. Okay, then we have to factorize this. So we can go ahead and open up 2 brackets. You can use that quadratic formula method to factorize this. So I'm going to put down x, and then 144. I need factors of 144 that can give me negative 25. But you have to remember that, you see, the middle term is the only negative one. When the last term is positive and the middle term is negative, then it means you're going to have a negative and a negative here. Because that's the only other way that you can get a positive here. Remember, you're saying this multiplied by this gives you the positive 144. Okay, the fact that it's positive, it means that these two were negative, and we know that because the middle term is negative. Okay, so the factors of 144 that can give you 25, negative 25, you can go ahead and try these. Okay, you can also use the quadratic formula method, but I'm just going to try it out. Okay, so when trying numbers, I could try 2, 3, 4, they were not working, okay, until I got to 9. So 144 divided by 9 gives you 16. And remember, they're both going to be negative. So you're saying that we have negative 9 and minus 16. And negative 9 minus 16 gives you negative 25. So that works out. So I'm going to use those factors. I have negative 9 minus 16. Okay, so this is just an equation. We have to just solve for x. So here, x is either equal to positive 9 or x is equal to positive 16. Okay, now that we have this, that's really how we solve. But there's one thing that I want you to actually always do, and this is usually for the case where you have 5 marks. I know it's 4 marks here, but do check if your answers are correct. So you can take your equation as it was. In place of x, I'm just going to put nothing. So x is going to go here, minus 7, the square root of x, and then is equal to negative 12. Okay, and I'm going to substitute these two values. Okay, first of all, 9 into this equation just to see if it balances out, if the right hand side really is equal to the left hand side. So if we put that in and I say 9 over here and 9 over here, let's see what we get. As you can see, we get negative 12. So that perfectly balances. So we know that x really is equal to 9. Then we can also try that with the 16. You see, there's no need to even write this down. You can just check on your calculator to make sure that both answers are actually your solutions. So if I try that with 16, then, try that with 16. You see, we also get negative 12. So in this situation, both answers are correct. This is why when you are checking for if your answers are valid, don't just try one and then when you see that one works, reject the other. Don't do that. Try both of them to make sure that they actually do either work out or maybe one doesn't. Because you see, you can have situations where both of them are your answers. You can also have situations where none of them are your answers. And then you can have those normal situations where one of it is your answer and the other is not. Okay, so that is it for 1.1.4. Moving on to the next question. And now 1.2 says solve for x and y simultaneously, and this is what we've been given. Two equations. Now, look at your equations. The first equation, as you can see, is a linear equation, okay? The other one is not really linear. This is more like a hyperbolic equation. Always spot the linear equation and you're going to start with that one. You can call that equation 1, and then the second one by default is equation 2. We're going to start with equation 1 and we're going to form equation 3 from this. So 2x minus y being equal to 2. And then we can take this y over, because it's negative, we can just take that over to make it positive and bring the 2 over to this side. So we're going to have y here, positive y, and 2x, and then that becomes a minus 2. Now this is your equation 3. Now in order to solve for x, we're going to go ahead and substitute equation 3 into equation 2, the equation that you did not use. Okay, so substituting equation 3 into equation 2, you're taking equation 2 and wherever you see y, you're going to replace it with 2x minus 2. So as you can see, we have x and then we have y. So in place of y, put a bracket because it's being multiplied. We put 2x minus 2 is equal to 4. And now we're just going to solve for x here. So you can distribute this x into the bracket because we just have a 4 here. So that's going to be 2x squared and negative 2x. And I can already see this is going to become a trinomial. So I'm going to take the 4 over to the left hand side and it becomes a minus 4 is equal to 0. In this trinomial, notice that 2 is common in every term. Okay, so we have a common factor of 2. So we can just divide both sides of the equation by 2. And so now we have x squared minus x and then minus 2 is equal to 0. Then we have to factorize this, and this is a simple one to factorize. Open up 2 brackets is equal to 0. And you can use the quadratic formula, but just don't show them so that if they are mark allocations for factors, you will get those marks. So x and x. And then I need factors of negative 2 that can give me a negative 1 in the middle. Okay, or negative x in the middle. So that is going to be negative 2 and plus 1. So negative 2 times positive 1 gives you negative 2, but negative 2 plus 1 gives me negative 1. Okay, so x is either equal to 2 or x is equal to negative 1. And so those are my solutions for x. Now remember, we're trying to solve for x and y. So I'm going to go ahead and just call this equation 3. And now in order to solve for y, we can substitute equation 3 into the equation that has, oh, okay, we already had an equation 3. I'm going to call this equation 4, sorry. And now we're going to substitute equation 4 into the equation that had y as a subject, which is equation 3. So substitute equation 4 into equation 3. Okay, so equation 4 is this, y is equal to 2x minus 2. So taking that y equals to 2x minus 2. And I'm substituting 2 in first. And so that will give me y is equal to, that is 4 minus 2, which is 2. Okay, so we got that answer. Or y is equal to 2, and now we substitute the negative 1 in, and minus 2. So y is equal to, and we have negative 1 here. 2 times negative 1 is negative 2, minus 2 is negative 4. And there we go. These are our solutions for x and y. Okay, make sure to always do the simultaneous equation. It's really a nice way to score marks. You can see it's 5 marks. Okay, moving on to the next question. Okay, and now we're on 1.3, and 1.3 says we need to show that 2 multiplied by 5 to the power of n and then minus all of this. As you can see, this is an exponential expression, is even for all positive integer values of n. Okay, so it has to be even. We have to prove to them that it's always going to be even for all positive integer values of n. Okay, so first of all, let's just think about that. They say that n, first of all, is going to be a positive integer. It's always going to be a positive integer. Okay, keep that in mind. Then it has to be, this expression has to be even. For you to prove that an expression is even, you have to show them that that expression can be divided by 2. Okay, so for example, to tell you, or to show you that 10 is actually an even number, I have to show you that 10 can be divided by 2. I don't necessarily have to divide it by 2, but I just have to show you that it actually can be divided by 2. So the best way to do that is to show that there is a factor of 2 in 10. So to show that 10 is an even number, I could rewrite it as, okay, this is 2 multiplied by 5. And this will show, okay, that this is an even number because it has a factor of 2. Okay, so let's try and use these premises to solve this one. With this, we have that. So let me just put this on the side. Okay. Now, when we have this, we have to show that this is going to be always even for all the positive integer values. Well, to show that this is always going to be even, right now, it's a bit messy as it looks. So how about we simplify it so that we can finally see what this expression sums up to? What does it simplify to? So I'm going to take this and I'm going to attempt to simplify the expression. Okay, so when simplifying expressions, you should be looking for things like what can be added, can I factorize, things like that. Looking all through this factorization, because we definitely cannot add these, they're not like terms at all. To factorize this, well, I see a repetition of 5 to the power of n. See, 5 to the power of n again, and 5 to the power of n. So that you can clearly see this, we can break up these exponential expressions, these single ones. Remember the law of exponent that says that if you're multiplying two bases that are the same, then you need to add the exponents. Meaning if I had 2 to the power of x multiplied by 2 to the power of y, this will become 2 to the power of x plus y. So I'm going to separate those using that rule of exponents. So here I just have 2 multiplied by 5 to the power of n. I can't really separate that, it's just an n. But I can do that here, minus 5, and now this is what I can do here. I can call this 5, remember this minus is really separate from the 5, okay? 5 to the power of n multiplied by 5 to the power of 1. That's what gave you 5 to the power of n plus 1. And that's how I'm separating those. I'll do the same to this one. I have plus 5. And that is to the power of n multiplied by 5 to the power of 2. That's what gave us 5 to the power of n plus 2. Okay, now like this, you'd be able to easily see that 5 to the power of n is common in each term, in each of these 3 terms in the expression. So I'm going to take 5 to the power of n out as a common factor. This is a method of factorizing. So 5 to the power of n out as a common factor, open a bracket. In the first term, what do you have left? We have 2, so we just have 2 there. In the second term, what do we have left? Well, we have a minus in front. We must not ignore that. So minus in front. And then we have 5 to the power of 1, which you can just write as 5. Then in the third term, what do we have left after taking this out? We have 5 to the power of 2, okay? But we have a plus in front, so that's positive 5 to the power of 2. Okay, this is looking good because we have numbers all through here. So you can just go ahead and simplify that. So 5 to the power of n multiplied by all of that. So what is 2 minus 5 plus 5 to the power of 2? That's 22. Okay, so it's multiplied by 22, and this already looks good. When you can see that you have an even number multiplied by this, okay, which of course n is going to be positive integer values, but then like this, we can already see that this is always going to be even. But remember the rule that for you to show that something is even, you have to show that it can be divided by 2. So in order to show it can be divided by 2, you need to show them that it has a factor of 2 in it. So we can take out a common factor of 2 here. Remember, this is one term on its own. So I'm taking out a common factor of 2 from this term. If I take out a common factor of 2, this is 2 multiplied by, and then it's been multiplied by this. We still have the 5 to the power of n. If you take out 2 from here, that gives you 11 times 11. Like this alone, this is you telling them that 2 is a factor in this expression. Therefore, this expression is even because it can be divided by 2. And so this would be showing them that this is even. Okay, so I know that the question with showing that a certain type of expression is even, it also shows up in patterns, sequences, and series. Sometimes they give you the formula of the pattern, and then they ask you, show that it's always going to be even for every maybe positive integer values and so on. So to show that expressions are even, you have to show them that it can be divided by 2. The best way to show them that is to show that it has a factor of 2. Okay, and then we move on to the last question in question 1. Okay, so we are on the last question of question 1, and you can see question 1 is a total of 25 marks. So question 1 is really a place where you can score marks, and you should try your best to score marks there. The last question says determine the values of x and y if we have been given this expression. Okay, let me rewrite the expression down and let's just look at what's going on here. Okay, so this is the expression that we have. First of all, we have to solve for x and y, and as you can see, x and y are on the exponents. So this is an exponential equation. With exponential equations, I'm already going to say this now. The goal is always going to be you need to try and to make the basis the same. Make the basis the same. I'll write that down. Okay, that is mostly your goal for exponential equations. So that's the same thing we're going to try to do here. Try to make the basis the same. Okay, to make the basis the same, this does look a bit messy. We have a square root, things like that. So because it's exponential, what we can try to do first of all, to make bases the same, you kind of need to have the numbers in an exponential format so that they have exponents. So this 32, I can change that 32 and put it in an exponential form. You can easily do this on your calculator by putting down 32, saying is equal to, then you're going to press shift, and then you'll see this button over here with the degrees and 3 commas, and has fact on top of that. And there it will factorize that for you. So we have 2 to the power of 5, that's 32. So I'm going to rewrite this as 3 to the power of y plus 1 over 2 to the power of 5. Okay, I'm trying to put them in exponential form. With this one, I mean, I can put the 96 in exponential form, but I feel like the square root is more of a problem right now, so we need to tackle that. So square root 96 to the power of x. The next thing, this 96, that root is a problem. Let's get rid of it. The only way to get rid of a square root is to square. And what you do on the one side, you must do on the other side. So I'm going to square both hand sides of this equation. And now we have this. Now remember the law of exponents. This is the third law of exponents. You learned this in grade 8. And this law, as you can see, this is an exponent, this is another exponent. It's been raised to another exponent. Okay, the exponents need to multiply into the exponents inside your bracket. So into those and into that exponent as well. So we're going to have 3 to the power of 2y plus 2 over 2 to the power of 5 times 2 is 10 is equal to, now over here, the root and that square cancel. So 96 to the power of x. Okay, now it seems like a good time to change that 96. So we can write 96 in an exponential format. So 3 to the power of 2y plus 2 all over 2 to the power of 10 is equal to, let's change 96. 96 equals, and we have shift fact. Okay, so it's 2 to the power of 5 times 3. So let's just be careful on how we write this. It's 2 to the power of 5 times 3. But then we still have the x, which the 96 is being raised to. Since this is now the 96, we are raising this to the x. Okay. So that x also has to apply to those exponents. On top of the 3, we have an exponent of 1, an invisible exponent of 1. The x is going to multiply to the 5 and the 1. So we have 3 to the power of 2y plus 2 over 2 to the power of 10 is equal to, and we're going to have 2 to the power of 5x multiplied by 3 to the power of x. Okay, this is what our equation looks like now. Not bad because you see a repetition of 3's and 2's. Okay, so how do we make the bases the same now that everything is in exponential form? Well, to make the bases the same here, you're going to have to try to, as long as the bases are the same, then it's fine. So I see 2 ways of doing this. You can either try to make this equation, say, 3 over 2 on both sides. So we could try and move this to the denominator, which would of course have an effect on that exponent. When you move something from where it originally was to another place, like a numerator or denominator, it will make its exponent negative. We could do that. Or we could take this to the numerator so that we can have a 3 multiplied by 2. Like here we have 2 multiplied by 3. That would be making the denominators the same. So I'm actually going to just take the 10 and move it to the top. So this is what I'm going to say. 3 to the power of 2y plus 2. And I'm going to bring this 2 to the power of 10 over to the numerator so that it can sit here with this 3. And when it moves there, it's being multiplied by 2 to the power of. Now that has an effect on the exponent because you moved it from the denominator to the numerator. The exponent becomes negative 10 now. It becomes negative is equal to, and I'm just going to rewrite this as it is. This is, okay, let me rewrite it in the same order. Since we started with 3 here, I'll start with 3 here. And we can't do that because with multiplication, any way that you put it will still mean the same thing. Okay, multiply by 2 to the power of 5x. Now, you see we have 3 and 3, and they're both being multiplied by a 2. That counts as the bases being the same. It's not like it's saying 3 to the power of this plus 2 and then 3 to the power of this multiplied by. No, they have the same operation. They're being multiplied. So this counts as the bases being the same. So what we're going to do is equate the exponents, okay, with the bases that are the same. So the 3 with the 3. The exponent here, that's really like saying that means that 3 to the power of 2y plus 2 really is equal to 3 to the power of x. Okay, because you're saying 3 times something multiplied by 2 times something is equal to 3 times something times 2 times something. So they're definitely going to be equated and equal. And then we can say 2 to the power of negative 10 is equal to 2 to the power of 5x. Okay. Okay, if you didn't understand that, it's kind of like saying 3 multiplied by 2 is equal to 3 multiplied by 2, right? So if I say 3 multiplied by x is equal to 3 multiplied by 5, and then here I said 2 multiplied by 1 is equal to 2 multiplied by 1, y, then it obviously means that, oh, okay, since they are equal, you're saying they're equal, and these two are being multiplied, it must mean that the x is actually a 5 for the equation to actually be equal. And that must mean that the 1 must also be equal to the y so that they can be equal. That's really what that is doing. Okay, so let's go ahead and equate the exponents. So it means that therefore 2y plus 2 is equal to x. And we have here that negative 10 is equal to 5x. So I'll go for this one because this one looks so much easier to solve. So negative 10 is equal to 5x. Divide both sides by 5. And so x is equal to negative 2. And now that we've solved for negative 4x, we could substitute x into this to solve for y. Okay, or you could just see that, oh, you have x, and you're just equating x and x. So I can just say, oh, okay, x is equal to x. So therefore, 2y plus 2, right, is equal to this negative 2, since they're both x. And now we have, okay, we can go ahead and just solve for y. I see there's a common factor of 2 all through. I could just get rid of it by dividing both sides by 2. So this is y plus 1 is equal to negative 1. Then I'm going to take the 1 over. So y is equal to negative 1 minus 1, which is negative 2. And there we go. We got x is equal to negative 2 and y is equal to negative 2. So question 1, this is what we have. So we are told to solve for x. In 1.1.1, you're given a trinomial and you have to just factorize this trinomial. Remember, you can use the quadratic formula, but you will lose 1 mark for your factors. So rather use the quadratic formula like this. But first, let me show you the right way to do it. So first, you're going to open up 2 brackets. And we're equating it to 0. Then you're looking at the first term, it's x squared. So what multiplied by what gives you x squared? That will be x multiplied by x. And then the second term is a 12. So what times what gives you 12? Well, a number of things would give you 12, like 6 times 2, 3 times 4. But you also have to think about the fact that this is a positive 12. The only way you could have gotten a positive is if you said positive number times a positive number. Then you get a positive. Or you could have said a negative number times a negative number, and then you'd also get a positive. And now, as you can see, between these two, which one can we pick? It's definitely going to be the negative times the negative, because you see that the middle term is negative. If it was the positive times the positive, then we shouldn't have any negative in here. Okay, so it must mean that 2 of these numbers must be negative. So think about it like this. If you had negative 6 minus 2, because they both need to be negative, and when we add them, they should give you the middle term. Negative 6 minus 2, that is negative 8, which is not the middle term. We need to have a negative 7. But if you said negative 3 minus 4, then we get negative 7. So these are our factors. Our factors are negative 3 and negative 4. So it's negative 3 and negative 4. Okay, and then you just solve for x after this. So we're just going to simply say that x is either equal to a positive 3, because remember it's like taking that over the equal to sign, or x is equal to positive 4. Okay, so that's the right way of doing this. But if you wanted to use the quadratic formula and still get marks for your factors, because they give you a mark for your factors, this is 3 marks. You get a mark here for your factors, and you get a mark for each answer. So if you wanted to use the quadratic formula in a way that you still get all your 3 marks, this is how you should use it. First of all, do not write down the quadratic formula. If they see it, then it's like, I didn't factorize. So what you're going to do is you're going to put it on your calculator instead. Remember, the quadratic formula is negative b plus minus the square root of b squared minus 4ac over 2a. So on the calculator, so even if you just write this in pencil, but then you can erase it after, then it's fine. So you can say negative, and then we'll open a bracket. The value of b is negative 7. So here, that's your b. And your a, because we had x squared here, then it means that a is just a 1, an invisible 1. So that's a. And then c is, of course, the 12. So we're just going to put that into the quadratic formula accordingly. So when I put this into the quadratic formula, just please notice that I use the minus first. So not the plus, I use the minus first, just because it's a smaller factor. Okay, so when we put minus, you get 3. Now you need to remember, 3 is your solution. That's when you're saying x is equal to 3. You still need to create 2 brackets. So I'm just saying, imagine you didn't have this. still have to create two brackets and say is equal to 0. And so if one of your solutions is 3, then it must mean that your factor must have been x minus 3. So that when you say x minus 3 is equal to 0, you take the negative 3 over and it gives you a positive 3. And then, of course, to find the other factor or the other solution for x, we're just going to change that negative to a positive. And then you see you get 4. So it's a positive 4 as your solution for x. So it must have meant that you must have said x minus 4 as your factor for that to be your solution. So that's the way to use the quadratic formula. Even if you didn't factorize, then you would still get a mark for your factors and for each answer. Okay, so that's it for 1.1.1. Moving on to the next question. And then 1.1.2, where we're actually supposed to use the quadratic formula. So we have this equation, and the minute they say correct the two decimal places, you know you have to use the quadratic formula. Okay, so there is something that you just have to do here. You have to simplify this a bit further. Because x is in front of this, and they are brackets, it means that they've been multiplied. So we're just going to FOIL this in. We're going to multiply that in. And so we have x times 3x, that is 3x squared, and x multiplied by positive 5, that is positive 5x. Then we have this equal to 1. But remember, we must always have one hand side equal to 0 in a quadratic equation so you can solve for x. Okay, so I'm going to take the 1 over, and we have minus 1 is equal to 0. Okay, so correct the two decimal places, just use the quadratic formula. And that's the quadratic formula, and let's just figure out what a, b, and c are. So as you can see, 3, that is the value of a. And then 5, positive 5 is the value of b, and the value of c is the constant without any variable, which is negative 1. So you're just going to substitute all of those values in. So we say negative, and we're putting in the 5 plus minus the square root of the 5 squared minus 4 times a, which is 3, times c, which is negative 1, all over 2 multiplied by a, which is 3. So put this onto the calculator and get your solutions for x. So we finally have here x is equal to negative 1 comma 8, and we have to round off to 2 decimals. So the 7 is going to round up, causing that 4 to become a 5. So it's going to be 8, 5. Or, and then just go ahead and change that minus to a plus, and we're going to have 0 comma 18 rounded off to 2 decimal places, so 0.18. Okay, now moving on to the next question. And 1.1.3, we have an inequality. We have x squared is less than negative 2x plus 15. Now, because x squared is positive, you can just go ahead and take these two terms over to the left hand side. So we're just going to have x squared, and then that will become a positive 2x, and that now comes over and becomes a minus 15 is less than 0. And then you have to factorize this. So we're going to open up two brackets and say less than 0. So we're going to have x and x, which gives you the x squared. And we need factors of 15. So think about factors of 15. It can be 1 and 15, but that's definitely never going to give you a 2. So we can even just leave that out. Then you can think about 3 and 5. Okay, so that can definitely give you a 2. Remember, the 15 is negative. The only way you can get a negative number from these two is if one of it was positive and one of it was negative. But you have to choose which one should be positive and which one should be negative so that you can get that middle term as a positive 2x. So imagine you have a 3, you have a 5. If you made this negative 3 and you made this positive 5, then this would definitely give you a positive 2 because positive 5 minus 3 is 2. Okay, so that's how it should be put. We're going to have negative 3 and positive 5. Okay, so those are your factors. You can also use the quadratic formula, but just don't show them that you did that. So like I did in the first question, you can also do that. Okay, now that we have the factors, this is what we can do. So in grade 11, in the past, in grade 11, they used to teach this method of having a number line and then, putting in the numbers and stuff like that. These days, I noticed that teachers don't really use that method anymore. They're using more of a grade 12 method. So you can use this method. Say that we have x squared plus 2x minus 15. This forms a parabola, specifically a concave up parabola. So a parabola that looks like that. So this is what we're going to do. And then you need an x-axis. That's all you need. You need the parabola and the x-axis. Then on the x-axis, we're going to have our critical values. And we get our critical values from these. It's like solving for x. So it's like when we say x minus the 3 is equal to 0, and then you take the 3 over. So you get x is equal to 3. But in this case, I'm not saying x is equal to 3 because this is not an equation, it's an inequality. So I'm going to have to solve for whatever that sign is going to be in the middle. Then I'll do the same to the second bracket. So the second bracket, we're going to do the same thing to that. We have x plus 5, so I'm going to put down x. And it's like taking the positive 5 over the equal to sign, so you have a negative 5. Okay, so we're going to just solve for x here, but it's not an equation. Now on your number line, your x-intercepts, these values over here, those will be your critical values. So the one that will go here, because this is more to the left, it will be the smaller one, which would be the negative 5 that will go here, and the 3 would go on this side. And now you have to focus on this. So you see that it's saying that this expression needs to be smaller than 0. Now what they mean when they say it's smaller than 0, this is referring to the y values of this graph. The question is basically asking you, find the x values where the y values of this graph is less than 0. So for the sake of understanding, usually we don't need a y-axis, but just for the sake of explanation, I'm going to draw a y-axis. So let's say we had a y-axis here, right? I know it may not be in the middle here, but I'm just saying. So if this is our y-axis, think about on this y-axis, let's think about the kind of values we can have. If you look here, these values over here, these are values that are greater than 0. So these are positive values. But they want where the y values are less than 0. So where they're less than 0, that will be here. So you're only going to look at the part of the parabola that has y values that are less than 0. So if you're looking at the parabola like this, on this part, you see all of these parts here, look at their y values. That's the y value of that point, and that's the y value of that point. These are all y values that are greater than 0. So we're not going to take any of this. But if you go down, you see now this point, look at its y value. This point, look at that y value. These are all y values smaller than 0. And then when you get to this point, we cannot take any part of this because these all have y values greater than 0. So you're going to highlight the one you're going to take. We're going to take everything here. So all of these y values. So this is the only part of the graph we're going to focus on. And now you're going to take these parts of the graph and line them up to the x-axis. We want to see, like for example, this point. What is the type of x value it has? Look at its x value. Its x value is here. Okay. And then this point over here, look at where its x value is. And this point, that's its x value. So it's kind of lining up the points to the x-axis so that we can see the type of x values they have. And now when we have done that, we're going to compare to the critical values. You see, we have negative 5. And the x values that belong to the shaded part of the graph, they are on the right-hand side of negative 5. So these values are what than negative 5. These values would be greater than negative 5. And that's really our solution when we're looking for x and negative 5. We are saying that x needs to be, the solution needs to be values that are greater than negative 5. So saying x is greater than negative 5. And also just notice, you see the inequality and look at the arrow of where your solutions are. You will notice that that arrow is going to help you to show you how your inequality is going to look. Okay, so it's the same sign. And then you're going to do the same thing to the 3. So we're looking at the 3 and we're saying, what are the values that we have? You see that these are the values we have here. They are on the left-hand side of the 3. And values on the left-hand side of the 3 are values that are less than 3. So when we're looking at x compared to 3 over here, we're saying that x needs to be smaller than 3. So x is less than 3. So as you can see again, the sign, okay, that arrow is helping you to see what your inequality is going to look like. Okay, so now that we have this, there's one more thing you need to do. So sometimes you can conclude further. You can actually write this together sometimes. And this is how to see it. So look at the graph. Look at the x values that we have. Notice that they are pointing towards each other. These arrows are pointing towards each other because they're speaking about a related set of values. Values that are greater than -3 but smaller than 3. And because these values are related, you see, they're not pointing in the opposite direction. We're not speaking about x values that are greater than 3 and x values that are smaller than -5. Then they wouldn't be related because they're just pointing in the complete opposite direction. But these ones are pointing towards each other, so they're speaking about the same set of numbers. So we can write them as a whole. So just remember, only ever do this when you see that the values are pointing towards each other. Okay, and now we can basically write this like this. You're going to put the x in the middle, and then on the left hand side you're going to put the smaller number, so that is the -5. On the right hand side you're going to put the bigger number, which is the 3. Then you're going to look at, when we have here -5 and x, you're going to also look at the x compared to the -5. The inequality. So this is an inequality. Just notice that that is the mouth. That's what I'm going to call the mouth of the inequality. So when you're looking at x versus the -3, where is the mouth facing? You see it's facing the x. So you have to write it like this. The inequality, when you're looking at x versus the -5, see the -5 and the x, the inequality needs to face the x. And do the same thing to the x and the 3. When you have the x and the 3, notice the inequality, the mouth is facing the 3. So we're going to say x is smaller than 3. Okay, so this is really saying that x is greater than -5, but smaller than 3. You read it from the middle to the left, then to the right. And that's our answer in 1.1.3. Then in 1.1.4, we have an equation with surds. Okay, so in this equation with surds, when you're solving equations with surds, the first thing to do is, you need to solve for x. And what is stopping you from solving for x is this square root that we have. So we need to get rid of that square root. And you basically do that by squaring both sides of the equation. So we're going to take that and square it, because what you do on the one side, you must do on the other side. And so that breaks open that surd because they're the inverse of each other. So we just have the 2 brackets 1 minus x is equal to, and of course we have that x minus 1 all squared. Okay, so this will just FOIL in, and so we have 2 minus 2x is equal to, when you are simplifying this, it takes long to just go x minus 1 and x minus 1 and start FOILing out. So something you can do is this. Take the first term, whatever that is, it's x, square the first term. So that will be x squared. Then to get the last term, you take the last term that we have here, -1, and square that. So -1 all squared is going to give you a +1. Then to get the middle term, you're going to take the first term, which is the x, multiplied by the second term, which is the -1. So you get -x. Then you multiply that by 2. So that will give you a -2x. So you can FOIL it out the normal way. You will see that you will get this answer at the end. Okay, so now that we have that, we can go ahead and say we have, since I have x squared on this side, I'm going to just take everything over to that side, because you can see this is going to become a trinomial. So we're going to be left with nothing here. 0 is equal to x squared, and we have the -2x. Then this -2x comes over and becomes a +2x. And then we have a +1. And then this +2 comes over and becomes a -2. So this is what we have. 0 is equal to x squared. The -2x and the +2x would cancel. And then we have a 1 minus 2, which is -1. Okay, so this is what we have. X squared minus 1 basically equal to 0. There's two ways of solving this. You can solve this the difference of two squares method, seeing that this is a case of difference of two squares that you have to use to factorize this. So we're going to say open up two brackets, and we have, first we have x minus 1, and then we have x plus 1. And then we'll just solve for x by saying x is either equal to, so we're taking this -1 over and we get a +1, or we're saying x is equal to taking that positive 1 over, and we get a negative 1. Okay, so that is one way of solving for it. Another way is you could have done this. So if you didn't want to use difference of two squares, you could have done this. So we can take this negative 1 over instead. And so we're going to have a 1, positive 1 is equal to x squared. And now to solve for x, you have to get rid of the square root, and the only way to get rid of it is to square root both sides. But this is an equation, and if you're saying that x squared is equal to 1, well, you have to remember that, yes, if you say 1 squared, you're going to get 1. But if you also say negative 1 squared, you're also going to get 1. So in front of this, you have to consider that you're going to have a positive and a negative answer, because we're square rooting both sides. So we're going to say plus and minus. Another way of looking at that is the fact that because we have a squared on top of the x, it means you have two possible solutions for x. So you have to consider the positive and the negative one. So it would mean that x is either equal to the positive or the negative square root of 1. So the square root of 1 is 1. So it means it's either equal to positive or negative 1, which of course you can write like this. X is equal to negative 1 or x is equal to positive 1. Okay, so we've solved for the surd. Now, there's one more thing you always have to do when you solve for surds. You have to check if your answer is correct. So you're looking at the two solutions that you have, and you're going to individually take them and substitute it into the original equation. So this was the original equation. It was the square root of, we had 2 bracket 1 minus that x, okay, which I'm going to leave it open, is equal to, and then the x minus 1. So we're going to try both answers. Let's try first the negative 1. That's our first solution for x. So we have 1 minus the negative 1, and then here we're going to have the negative 1 minus 1. So go ahead and see what you get. The equation needs to balance. We have to have the same thing on the left that we have on the right as well. So you see that on the left hand side, if you put that into the calculator, you're going to get a 2. But on the right hand side, negative 1 minus 1 is negative 2. So that's not true. The equation is not equal here. So because it doesn't make the left-hand side equal to the right-hand side, then x is equal to negative 1 is not a solution. You can go ahead and cancel and say x is not equal to negative 1. Okay, you can also try 1. It's probably going to work, but you can still try it as well. So in place of that empty spot, if we put 1 instead and 1 here, let's see what we get. So on the left-hand side, you see you're going to get 0. And here, 1 minus 1 really is 0. So you see that that works. So x is equal to 1 only. Okay, it's not equal to this one. So that's something you always have to check. Okay, so that is the final answer there. X is equal to 1 only. And then we move on to the next question. Okay, so moving on to 1.2, we have to solve for x and y simultaneously. And these are the two equations that we have. So I know that normally they give you a linear equation and then another equation, and you usually just make the linear equation equation 1. So if they give you this one that looks like an exponential equation, you make this one equation 1, because this one can actually form a linear equation. So we're going to call this equation 1, and we're going to call that equation 2. Then from equation 1, which is 3 to the power of x plus y is equal to 27, we're going to form equation 3 by making either x or y the subject. Now the way to do that, because we have 3 to the power of this, and then we have a 27. Okay, since this is an exponential equation right now, we can make their bases the same. So 27, we can rewrite 27 as 3 to the power of 3. And now that the bases are the same, we can equate the exponents. So that therefore means that x plus y is equal to 3. And now from this, you can make one of it the subject, either x or y. So I'm going to choose to make x the subject. X is equal to, and I'm saying 3, and taking the y over minus y. And so this is now equation 3. And then we're going to substitute equation 3 into equation 2. So the equation that we didn't use yet. And so wherever you see x, you're going to replace it with 3 minus y. So we have an x squared. So I'm just going to say 3 minus y all squared. Then plus we have y squared is equal to 17. And let's go ahead and solve for y here. So now we have this. Now this is a square binomial. You can of course go ahead and say 3 minus y multiplied by 3 minus y and then FOIL out everything. Or you could do this instead. So you take the first term and then we're going to square that. So it's like saying 3 all squared. That will give you a 9. Then you take the last term, or the second term, which is negative y. So it's like saying negative y all squared, which will give you a positive y squared. Then we're going to take the 3, the first term and the second term, and multiply them. So 3 times negative y is negative 3y. Then you're going to take that and multiply it by 2. So negative 3y times 2, that is negative 6y. Okay, remember that is positive y squared, so that's a plus there. And then we still have plus y squared is equal to 17. Okay, the y squared and the y squared, I'm going to start with those because I want to put it in the order of their exponents. So we're going to have 2y squared, and then we have the minus 6y. Then on this left-hand side, we still have a positive 9 here. And here we have a 17. The 17 can go ahead and come over. So when we take the 17 over, we're going to still have the positive 9, and the 17 comes over, becomes a negative 17 is equal to 0. So 2y squared minus 6y, and then 9 minus 17. Okay, so that's negative 8. So minus 8 is equal to 0. Okay, so we have a trinomial in terms of y. But if you look throughout this trinomial and look at all the terms, notice that everything can be divided by 2. So we're going to take both sides of the equation and divide it by 2. So we will have just a y squared and then negative 6y divided by 2, that is negative 3y. Negative 8 divided by 2, that is negative 4, is equal to 0. So here's your trinomial. You can use that quadratic formula, or you could factorize it. So open up 2 brackets and we're saying it's equal to 0. Y squared. What times what gives you y squared? That's y times y. And then negative 4. What times what gives you 4? That is 4 times 1. But because it's a negative, it means one of it needs to be negative, one needs to be positive. So if we say negative 4 and put that as positive 1, then negative 4 plus 1 will give you your negative 3 in the middle. So our factors is the negative 4 and we have the positive 1. And so we can go ahead and conclude that finally here y is finally equal to a positive 4 or y is equal to negative 1. So we have equations for y now, and we ended at equation 3. So this can be equation 4. And lastly, in order to get the x values, because we have the y values, you're just going to take equation 4 and you can substitute it into equation 3 because equation 3 has x as a subject. So we're going to substitute equation 4 into 3. And so this is our equation 3. And so in place of y, we're going to first put in 4. So that is our y value there. So x is equal to 3 minus 4. So therefore x will be equal to negative 1. And then we have also, or x is going to be equal to 3 minus, and then the y is negative 1. So bracket negative 1. So x is equal to 3. And then if you have a negative times a negative, it gives you a positive. So that is positive 1. X is therefore equal to 4. So those are solutions for x and y. So when x is equal to negative 1, your y value is equal to 4. And when x is equal to 4, the y value is negative 1. Okay, remember these just form graphs and you're just finding the points of intersection because those be the only places where these two equations are equal. Okay, so that is our solution. Moving on to the next question. So question 1.3, we have to determine without the use of a calculator the value of 1 over the square root of 1 plus the square root of 2 plus, and then this basically keeps going all the way to 1 over the square root of 99 plus the square root of 100. Okay, so I know this type of question in question 1 is really something that would scare most people because, you know, you're in a state of sort of panic. And that's why in your exam papers, you need to try your best to have a calm mind, no matter what. Because when you panic, you don't really think very well. You think better when you are calm than when you panic. So you need to walk into that exam room as if you wrote the syllabus. But again, for you to have that kind of confidence, you also have to have really studied and really practiced. Okay, now the thing about this question, it's using a grade 11 concept. When we have a surd on the denominator, for example, let's say we had something like this, 1 over the square root of 2. Notice that on your calculator, not really this calculator is kind of programmable. It's not going to really work on here. But on your calculator, if you write 1 over the square root of 2, you're going to notice it's going to simplify it for you. Okay, so you see, mine will not do that. But yours will simplify it to the square root of 2 over 2. So what it's doing, it's rationalizing the denominator. This is a concept that is actually taught in grade 11. And that's the thing about matric. It is a mix of grade 11 and grade 12. So when you rationalize the denominator, it's in the word rationalizing the denominator. You're making the denominator a rational number, because right now it's a surd and that's irrational. So you make it a rational number. And this is how we do this. So when we have 1 over the square root of 2, to make this a rational number, you would really just say multiply by the square root of 2 times the square root of 2. And really what we're doing is we're multiplying this fraction by 1. But in the form of the square root of 2 over the square root of 2. That's actually what we're doing, because that would give you 1. And so when we do that, you see that 1 times the square root of 2, that gives you the square root of 2 over square root of 2 times square root of 2, that is 2. And that's how we get that. Now, the thing about what we have here is this is not what the denominator looks like. The denominator is not just the square root of 2. It is the square root of 1 plus the square root of 2. And the next one is the square root of 2 plus the square root of 3. And this keeps going. So this is how to rationalize things with two terms that are surds on your denominator. So if we have 1 over the square root of 1 plus the square root of 2, what you can do to rationalize this is we're going to multiply it by 1 again, but this time in the form of the square root of 1 minus the square root of 2. Okay, over the square root of 1 minus the square root of 2. Now I know, looking at this, you would have thought maybe you have to multiply by 1 square root of 1 plus the square root of 2 over the same thing. The thing about this is if you multiply that denominator by this, okay, so you can just see it on the side. If you said square root of 1 plus the square root of 2 and you multiplied it by this, it will not become a rational number. Okay, when you're multiplying these two terms, they're really binomials, so they have to be FOILed out. So this would multiply and become 1. That would multiply and become positive square root of 2. So you can be checking these answers on your calculator. That will multiply and become positive square root of 2. That would multiply and become 2. You see, you have a 1, you have the 2, that becomes a 3. But then the square root of 2 plus square root of 2 is 2 square root 2. As you can see, this is not a rational number. This is irrational. It still has a surd. That's why we don't multiply it by this. We multiply it by the other thing instead. We multiply it by this. And the reason we're doing this is it's like you're trying to form difference of two squares using this. So if you look at the denominators, and the only reason I'm doing this is so that I won't have to do this for each and every term, you're going to see they're all going to simplify to similar things. So when we have the square root of 1 plus the square root of 2, and you're multiplying it by the square root of 1 minus the square root of 2, what is going to happen is this. Notice you have the exact same first and second term. The only difference is the signs. This should remind you of the difference of two squares. So because of this, even if you FOILed out, which you shouldn't, it's going to take so long. What's going to happen is the first two terms multiply and become a 1. The second two terms multiply and become negative square root of 2. That multiplies and becomes positive square root of 2. That multiplies and becomes negative 2. You can check this on your calculator as well. You will notice that the two middle terms, they have the inverse operations of each other. Positive square root of 2 and negative square root of 2, they will cancel and become 0. So you really just have a 1 minus 2, which is negative 1, which is a rational number. That's the whole point, to make the denominator become a rational number. So now, just so that you don't have to start FOILing out, this is what you can do instead. The minute you see that you have these two brackets multiplied, and you can see they're the same first and second term. Only difference is we have a plus and a minus here. Know that that is difference of two squares. All you have to do is multiply the two first terms, that gives you 1, multiply the two last terms, that gives you -2, and that gives you finally -1. Okay, so that's what we're going to do to those denominators. Okay, so we're multiplying it by 1 in the form of this so that we can simplify this and make the denominator a rational number. So on the top, we see 1 multiplied by the square root of 1 minus the square root of 2. 1 multiplied by anything really just stays the same thing. So we just have the square root of 1 minus the square root of 2. Over, remember these two are being multiplied. Remember we have difference of two squares because it's the first term and the second term being exactly the same, only you have a plus and a minus. So that just multiply the first terms, 1, multiply the second terms, that becomes -2, and you can see that that will become a -1 on the denominator. So square root of 1 minus the square root of 2 over -1. And now when we simplify this, you see the two numerators, the terms on the numerator, they have to divide by this single term on the denominator. Each of them need to divide by it. So we're saying the square root of 1 divided by -1, which will really just give you the negative square root of 1. And then the negative square root of 2 divided by -1. That negative and negative will become positive. So it's a positive square root of 2. I know this can simplify to -1, but I'm just going to leave it as a surd for now. So it really just means that this first term, all it is this. Okay, so since we found the first term, let's go ahead and find the second term as well. So here we have 1 over the square root of 2 plus the square root of 3. And we need to rationalize the denominator. And you will rationalize the denominator by multiplying it by its denominator, but instead of having a plus, we're going to have a minus in the middle. So we're multiplying it by 1 in the form of the square root of 2 minus the square root of 3 over the square root of 2 minus the square root of 3. So when we multiply the numerators, 1 times anything stays the same. So we still have the square root of 2 minus the square root of 3 over. Here you just multiply the square root of 2 times the square root of 2, which is 2. Positive square root of 3 times negative square root of 3, -3. Then we still have the same numerator, and over that will become -1. And when you divide both terms in the numerator by -1, we get this divided by -1 is negative square root 2. This divided by -1 becomes positive square root 3. Okay, so that's what this simplifies to. So you see, this is the first term. That is the second term. You're going to start noticing a pattern with the way these terms are going to look. So the first term became negative square root of 1 plus the square root of 2. So when you have this, you just focus on the denominator and you know that the first one is going to become negative, and we still have the same thing, square root of 1. And then the second one really just stays positive. Same thing here. The first term here became negative, the negative square root of 2. And then that still stayed the positive square root of 3. So that would mean that term 3 is going to become this. The first term in term 3 is going to be the negative of this. So negative square root of 3. And then the second term will just stay plus the square root of 4. And this will keep going up until the last term, and they gave us a last term. So this last term, the first term is going to be the negative square root of 99. And then the last term will stay plus the square root of 100. So this is the sequence that we now have. And in this sequence, notice what keeps happening. We have first the negative square root of 1. Then we have a positive square root of 2, then a minus square root of 2. Then in the next term, a positive square root of 3, and then a minus square root of 3. So you can see that each term will always have something from the previous term. It will always have that previous number. Okay, so because of that, what will happen is this positive square root of 2 will cancel with this negative square root of 2. They will become 0. The positive square root of 3 would cancel with the negative square root of 3. They also become 0. That also means that this positive square root of 4 would cancel with the next negative square root of 4, because that's what's going to come after. So if we have a positive square root of 4, we will have a negative square root of 4 after that. And then now looking at this, think about what the previous term before this one would have been. So if this is the last term, the previous term would have been the negative, it always starts with a negative, the negative square root of 98, then would have had a positive square root of 99. So you can see that this would cancel with this. And here, this negative square root of 98 would have cancelled with the previous term's positive square root of 98. So you see that everything is going to cancel in between, except for the first term and the last term, because they are the only ones of their kind. These are the only numbers that are not going to be repeated again. So we're going to have is equal to, we just have the negative square root of 1, and we have the positive square root of 100. And this will simplify to this. So negative and then square root of 1. The square root of 1 is 1. So this is just negative 1 plus the square root of 100 is 10. So you can read this as positive 10 minus 1, which is equal to 9. So that is our final answer for that. All of this just adds up to 9. Hey grade 12s, and welcome to this video. In this video, we are going to be working on Mathematics Paper 1, and this is a preparatory exam specifically from the Gauteng province. So we are on question 1, and 1.1.1 says we have to solve for x when we are given that 2x plus 1 all squared minus 4 is equal to 0. Okay, so there's actually two ways of solving this, but I'm going to try using a method that I feel is easier just because of the way they have structured this equation. So with this equation, what we can actually do here is, you see, you have a negative 4. We can actually take that over. So we would have the 2x plus 1 all squared, and then that negative 4 becomes a positive 4. Then at this point, just remember that the main goal is just to solve for x. So you just need to get to x. So what is actually stopping you from getting to the x? Well, that would be this squared. The squared is the first problem that we have. That is our first problem. So what we can do to get rid of the squared, the opposite of squaring something, is to square root it. So because this is an equation, what you do on one side, you must do on the other side. But here's the thing, you need to remember that when you square root this, the solution that you're going to have should be positive and negative, because the positive and negative solution works. Okay, if you say x squared is equal to 4 and you're trying to solve for x, if you square root both sides, you can't just say x is only equal to 2. That's not true. It's positive and negative 2. Because if you take negative 2, right, and you square that as well, it'll also give you a positive 4. Just like when we take 2 and we square that, it gives us a positive 4. So that is the reason you put plus and minus when it is an equation. So we square root both sides, and then we finally just say, remember, those will cancel because they're the inverse of each other, and you have 2x plus 1 is equal to positive or negative, and the square root of 4 is 2. Okay, so this is why I say this method seems easier in a way. So what we're going to do here at this point is we're still trying to solve for x. So what is the next thing we need to get rid of to get closer to the x? That would be the 1, okay? So you can take the 1 over, so you'll have 2x is equal to, and when that 1 comes over, it becomes a negative 1. Please put it in front of this plus minus. It's just easier like that. So you have plus minus a 2. Okay, now, so that we don't confuse ourselves, what we can do is now share this plus and minus. So this is what I mean by that. We're going to take our 2x is equal to, and we have our negative 1, and we're first going to put the plus. So we have plus 2, okay? Or the second equation that we'll have is, again, we have 2x is equal to, and we have negative 1. And this time we choose the minus, so minus 2. Okay, and this is what we have. So we just have to solve for these two equations. So 2x is equal to negative 1 plus 2 is like saying 2 minus 1, which is 1. So that's 2x is equal to 1. Then you divide both sides by 2, and therefore x is finally equal to 1 over 2. Then here we have 2x being equal to, that gives us negative 3. And then if you divide both sides by 2, x is equal to negative 3 over 2. And that is the method I would use here. I know that you could have distributed this, then subtract by 4, and then you end up with a trinomial that you have to factorize. But I just feel like that's so much longer because now you have to actually factorize a trinomial. And it's not the type of trinomials that, you have a common factor. It's going to be a trinomial with a coefficient other than 1 in front of the x squared. Okay, so that is the solution for that. It is 3 marks. So where you're going to get your marks really is here, first of all, for square rooting both sides, and they need to see that plus and minus. Okay, if it's only a plus, it's not true. It's not really, they can't really give you a mark for that. And then you're going to get a mark for simplifying the equations. And then, of course, you're going to get a mark for your solutions. Okay, so that's 3 marks. Moving on to the next question. Okay, 1.1.2, we have our usual quadratic equation, okay? The one that you have to actually use the quadratic formula. So in this one, as you can see, this should not be here. You should always have one hand side being equal to 0. So we're going to take that over. And so what we're going to have is 4x squared. Now, you see that it's the one with the x, so we can actually put it immediately after the 4x squared. It becomes a positive 12x. And then we still have the minus 11 is equal to 0. Okay, you don't have to try and factorize because they say correct to 2 decimal places. So we'll go ahead and use the quadratic formula. Remember, this is also in your formula sheet. Okay, and then we're going to substitute. So let's just go ahead and establish A, B, and C. So remember, your quadratic formula says ax squared plus bx plus c. So now you can see that the 4 is your A, the positive 12 is your B, and your C is, of course, the negative 11. So let's go ahead and substitute. So that means that x is finally equal to, we'll say negative, and we have 12. So 12, that's B, plus minus the square root of B squared, that is 12 squared, minus 4 times A, which is 4 again, and then multiply by C, which is negative 11. And then that goes all over 2A, and A is 4. So 2 times 4. And then you just put this onto your calculator and you get your answer for your positive and negative one. I'll go ahead and start with the positive one. Okay, and when I go ahead and start with the positive, what I get as a decimal, so I'm just going to press SD. So x is finally equal to, first of all, we have 0 point, and that is 736, which we round up, okay, because that rounds up because that's greater than 5. You're going to get 74. Or x is equal to, and we're just going to change that sign instead to a minus. So go ahead and change that to minus, and our solution there is x is equal to negative 3 point, and that rounds up to 74 as well. Okay, so those are our solutions. With this one, it's quite simple where your marks go. It's 3 marks, but where it's really just going to go is for your substitution, because they already have the formula there. They don't get a mark for putting the formula down. And then your solutions. Okay, moving on to the next question. Okay, 1.1.3, we have an inequality. So this is a quadratic inequality, as you can see, because the highest exponent of x is really 2. But they just put it in a really funny way. So there's 2 things that you can actually do to resolve what they've done here. The first thing we can do is, and I'll just do both just so that you can see what is going on here. So first of all, the x squared is over here. We can either move this over, or we can leave it there. So first one, let's leave it there. Let's go ahead and leave 9x squared on the right hand side and take everything else over to the right hand side. So that means you're going to have negative 15x and then a positive 4. Now over here, what you're going to have, the sign you'll have is still the same sign, but then because there's nothing here, we'll put 0. Okay, and then what you could do is just think about rewriting it properly. So you can rewrite it as 9x squared minus 15x plus 4. And you know that the 0 is also there. But now you're going to have to follow what the inequality says. Do you notice that the inequality, the open part, the mouth of the inequality is facing the 9x squared minus 15x plus 4. So we could also redraw it facing the 9x squared minus 15x plus 4. That's what you could do. Okay, the second way of doing this is probably a little more complicated, because what you're going to have to do here is see the fact that, okay, this is on the right hand side. We can bring it over to the left hand side, which would leave us with negative 9x squared. And then this is still on the left hand side, so that doesn't change. So it's still positive 15x minus 4. And then the inequality is saying less than, but there's nothing left on the right hand side, so we have 0. Okay, and now there's an issue. Your x squared, your coefficient of x squared is negative. So then you would have to divide both sides. okay, or multiply really. I don't have to divide. Then we can actually just multiply both sides by -1, okay? So instead of just dividing, you can just multiply. And when you do this, we're going to get positive 9x squared. Remember, we're doing this so that the coefficient of x squared is positive, and we can probably factorize that. And then that gives you -15x and positive 4, right? But now the result of you multiplying by a negative number or even dividing by a negative number in an inequality is the sign is going to change. So instead of it facing this way, it's going to face the opposite direction, and you have still 0, because 0 times -1 is still 0. So do you see now that your inequalities are exactly the same? But you could have just done that. Either ways, it's still fine, okay? So we have our inequality. We know what it looks like, and we just need to solve for x now, okay? This inequality, okay, because this has a coefficient other than 1 or -1, okay, because it has that, you have to check, do you have any common factors? No, we don't have any common factors, so there's no taking out a common factor. We just actually have to factorize this. Remember, there are two ways of factorizing. You can use the cross method. I have shown that previously in my videos, or you could use the factor method. Okay, so in this, I'll just use the factor method. What we're going to do is, we'll first of all take 9 and multiply it by 4. Okay, you multiply 9 and 4, you're going to get 36. And you're going to take the factors of 36, that can give you -15. That's really what we're doing here. Okay, so really, remember, it's positive 36, right? And it needs to give you negative. So, of course, for that to happen, your factors must both be negative. So we can think about factors like 1 and 36. That's definitely never going to work. You could think about 2 and 18. Okay, if they were both negative, they wouldn't work, because -2 minus 18 is -20, not -15. Okay, what about -3 and -12? Okay, so 3 and 12. 3 times 12 is 36. And you see that -3 and -12, when you subtract, you will get -15. So those are our factors. And so this is how we simplify this. We'll go ahead and say 9x squared. And what we're really doing to -15 is we're breaking -15 up, but we're breaking it up into this. Now, how you write this is important. It is better to actually write it like this. So the number that you're going to write next to the 9 should have a common factor with 9. And the number you write next to the 4 should have a common factor with the 4. And you know that 3 and 4 don't have anything in common. But 12 and 4 do. They do have a common factor. So what I'll write it as is, I'm going to have -3, but remember, this is -15x, so it needs to be in terms of x, and minus 12x, and then we have, of course, our plus 4 is greater than 0. Okay, and now that we have that, we can go ahead and group. So you're just going to group the first two together and the second two together. And that's why I try to put them in a way that they have common factors, so I don't have to overthink that. Okay, so now that we have that, we're grouping and we're just taking out the common factor in each group. So the common factor, highest common factor is 3x here. We open up a bracket. What do we have left? Well, 9 divided by 3 is 3. X squared divided by x is x. And then here, if you take this and divide it by this 3x, you see it's going to give you -1. Okay, that's what we have there. So now we have this. If this is negative and this is positive, it is better to actually just take the negative as a common factor. So what's common between -12x and 4? That would be -4 that we have in common. And that's all that's really common. And then -12x divided by 4 would give you +3x. And then +4 divided by -4 is -1. Okay, so we have is greater than 0. Do you see that we have how many terms here? You see there's a minus here, so this is 1 term and 2 terms. So in these 2 terms, do you see that we have a common factor in the form of a bracket? Okay, because those are common, we're going to take them out as a common factor. So we have 3x minus 1 coming out as a common factor. And what is left? In the first term, when you take this out as a common factor, the only thing left is the 3x. And then in the second term, when you take that out as a common factor, the only thing left is the -4. And then it is greater than 0. So these are our factors. Okay, so that's the factor method. In the past, I have used the cross method. but I actually find the factor method much easier. Okay, so this is what we have, and we just have to now find what we will call our critical values. So our critical values is just like making these equal to 0. So we're going to say it's either that we have 3x minus 1, and this part really doesn't matter. They just want to see that answer that you have. Okay, 3x minus 1 is equal to 0, or, because it's just our critical values, I'll call them crit values. So I remember it's not my answer yet. We have 3x minus 4 being equal to 0. And so this is 3x is equal to take the negative 1 over and divide both sides by 3 to solve for x, just so you get your critical value. So it's 1 over 3. And then here, or we have 3x being equal to 4. That goes over, divide both sides by 3, and x is equal to 4 over 3. So these are your critical values. That's what we're working with. So even if you work through this with a pencil and then you just erased all of that, you didn't even bother about that, and you just wrote your critical values down, they'll be fine with that. Okay, so let me erase the sign so that we can actually solve for this inequality. So ultimately what's going on here is we have a graph, right? If you look at this point where we made one hand side be equal to 0, do you see that this graph, because it has x squared, it will form a parabola? And specifically, what kind of parabola is this? Well, it will be a concave up parabola, because as you can see, the coefficient of x squared is greater than 0. So our graph is just going to be a concave up parabola that we'll have, and we can go ahead and draw an x-axis. So I have explained this in my past videos as well. If your inequality says that your expression needs to be greater than 0, you're only going to pick out the parts of the graph that lie above the x-axis, okay? That's for greater than 0. And if it says less than 0, you only pick out the parts of the graph that lie below the x-axis. And I have also explained those deeply. I will also link videos and show you where exactly they are, the timestamps of that as well, right here on the screen. So as you can see, our inequality says it needs to be greater than 0. So we're only going to look at parts of the graph that lie above the x-axis. Okay. Second thing we need to do is put down our values, our critical values. So you see 1 over 3 and 4 over 3. 1 over 3 would be the smaller one, so it will be here. And 4 over 3 is the bigger one, and that will be there. Remember, we're only taking parts of the graph that lie above the x-axis. So we'll take that and that. And we're really just trying to solve for x in these. So we're saying, what are the x values, okay, where this function is greater than 0, has a y value greater than 0. And what we can do is just line down these values just to find out where exactly they are. So this is the highlighted part of the graph. The x values that belong to them are these values. So this value here, and this value here, and that one. And it keeps going towards that direction, as you can see. And if you do the same for this one, line it down to the x-axis, you see, look at where these values are. These are values, these x values are going towards the right-hand side of the x-axis. So when we are answering them here, for this part, we're going to say that, as we can see, it's heading towards the left-hand side. And these values, because they're going towards the left, these are values that are less than 1 over 3. So we're saying that x is less than 1 over 3. Do you see that the inequality and the arrow towards where the answers are pointing, they are exactly the same. So the arrow helps you with the inequality. And then we're going to say the same thing here. We're going to think about that, use that same idea. So x here, as you can see, it's moving towards the right-hand side. These are values that are greater than 4 over 3. So x is greater than 4 over 3. Again, the inequality, or the arrow rather, really helps you with the inequality. Okay, so that is our solution there. Now, I know that you have seen situations where they are written as one single inequality. That only happens when your values, right, the values that you found, are pointing towards each other. So if the answers were like this, so it's pointing toward this side and then this side. Because they're speaking about the same set of values, you see they're pointing towards each other, the same x values. Okay, we will be able to write it as one single inequality. But in this case, they are just pointing in complete opposite directions. Because of that, they are not going to be related and we don't have to write them as one single inequality. Okay, so that is the inequality. It is for 4 marks, and we move on to the next question. Okay, so we are on 1.1.4 and we have equations with surds. But in this equation with surds, you see that you have 2 surds, okay, and they both have x in them as well. So what we're going to do here is we're still going to follow the simple steps of simplifying equations with surds. I want you to think about it like this. If you had a situation where you had maybe root x minus 3 and then minus the square root of maybe x plus 2 is equal to 0, what would you do in this situation? You would try to isolate the surd. That would be the first thing that you think about doing. So if we're thinking about we have to isolate the surd, you would take one of the surds over. And when you do this, you're able to at least, because that's negative, of course, when it comes over, it becomes positive. When you do this, you're able to get rid of the surds. Okay, now in this situation, you'll be able to get rid of both square roots. But in this situation, you would be able to get rid of at least one of it. Okay, so that would simplify the expression further. So when we look at this, what we're going to go ahead and do is take the surd over, isolate the surd. So I can leave this one here. I'm going to leave that as the square root of 2x minus 2. And when this comes over, because it's negative, it will become positive. So what I can just do there is say it's equal to the positive square root of 7 minus 2x. Then we still have our positive 1 on the right hand side, so that's just a plus 1. Okay, so now that we have this, it may not get rid of all the surds, but it is simplifying this expression. We have isolated the surds. So now that we still have surds, we have to get rid of them by squaring both sides. So square that side and we square this entire side. So what would happen here, because all of this is under the square root, they just cancel with the square and you have 2x minus 2 over there. But over here it's a bit different. You see that you have 2 separate terms here. This is one term on its own and that's another term inside the bracket. So it actually just works like this case, okay, when you square that. So what we're going to do is square the first term. If you take that square root of 7 minus 2x and you square this, that will just break open. The radical just breaks open. The square root just breaks open. So we have 7 minus 2x just like that. Then you're going to have to say the first term multiplied by the second term. Because this is 1, it's really just going to stay the same. The square root of 7 minus 2x. Then you double that by multiplying it by 2. So if you take that, multiply by 2, you get positive 2 square root 7 minus 2x. Then lastly, take the 1 and square that, and that will just give you positive 1. Okay, let's simplify so that we can actually work on this. So I'm going to try and leave this surd here. Because I see there's still a surd, I need to remove the surd. There should not be any surds. So I'm going to leave that over here and take everything else over. So here we just have our 2x and whatever has x, I'll just bring it over. So that's a negative 2x. When it comes over, it becomes a positive 2x. Then we still have a minus 2 here. And then we have our numbers. Let me actually simplify like this. You see on the right hand side, 7 plus 1 gives you 8. And I'm going to take that positive 8 and bring it over and it becomes a negative 8. Okay, and so this is what we have. That is already gone. It came over here. So we just have a positive 2 root 7 minus 2x here. And let me just leave space so that it doesn't get messy. And now that we have this, we're going to go ahead and simplify. So that gives you 4x. So we have 4x there. And then negative 2 minus 8 is negative 10 is equal to 2 root 7 minus 2x. Now, I would love to square root both sides at this point. But the thing is that I see there's a common factor of 2 all through. So what I'm going to do is divide both sides of the equation by 2 first. And so that's going to give us 4x divided by 2 is 2x. Negative 10 divided by 2 is negative 5 is equal to those 2's cancel. And you have the square root of 7 minus 2x. Now it is nice and safe to actually square both sides to get rid of that square. So we're going to square both sides of this equation. Same thing here. So you see the fast method is going to be very helpful. Quicker methods will limit the amount of mistakes you could make. So square the first term. That gives you 4x squared. first term multiplied by second term. 2 times negative 5 is negative 10, so that's negative 10x. Then times that by 2. So that gives you negative 20x. And then lastly, square the last term, which gives you positive 25. When that gets squared, the square root cancels with the squared, and you have equal to 7 minus 2x. Okay, then we can just bring these over here, and they form a trinomial. So we're going to have 4x squared minus 20x and plus, well, let's just put it in order. So that comes over and it becomes a positive 2x. This stays positive 25. That comes over and becomes a negative 7 is equal to 0. Okay, so this is what we have. Let's simplify 4x squared. Then we have these two. Okay, negative 20 plus 2 is negative 18x. And then we have our 25 minus 7. So 5 minus, well, the 5 is gone already, just the 7. So 20 minus 2 is 18. So we're going to have positive 18 is equal to 0. Okay, so at this point, you see that all through you have a common factor. Okay, it's not really 4 because 4 can't really go into 18, but it is 2. So we can divide all through by 2. So divide both sides by 2, and we're going to finally get 2x squared, and then that gives you negative 9x, and positive 9 is equal to 0. So this is the trinomial that we get, and we have to actually factorize this. Let me actually just use the cross method here because I haven't used it in a while. So what we're going to do to simplify this using the cross method is we look at the first term, okay, the one with x squared, and we're going to take the factors of that. So what times what gives you 2x squared? Well, that can be 2x times x. And then you look at the last term, what times what gives you 9. But we need to put it in a way that we can still get a negative 9x in the middle. So you could have tried it as 9 and 1, but I don't really think that's very helpful. So we could break 9 up into factors of 3. So 3 times 3 gives you 9. So 3 and 3. And how you know what sign is going to be here is if this is negative only, this is the only negative thing, then they will both be negative, because for them to actually multiply and give you a positive number, they must have both been negative. Negative 3 times negative 3 is positive 9. And for them to be added and give you a negative 9, they must have both been negative to kind of like stay like that, to stay negative. Okay, so let's just see if we can actually get that here. So 2 times 3 is negative 6x. And then if you multiply those, x times negative 3 is negative 3x. And that does indeed give you negative 9x. So we know that these are our factors. So our factors are 2x minus 3 multiplied by x minus 3 is equal to 0. So do you see why I say the factorization is actually easier than the cross method? The cross method just takes a little more thinking. It just looks faster though. Okay, so this is what we have. And now we just have to solve for x. So it means that either 2x minus 3 is equal to 0, or it means x minus 3 is equal to 0. Okay, remember I've explained why we say or before in past videos as well. So we have 2x is equal to, we take the negative 3 over, becomes positive, divide both sides by 2 to solve for x, and x is either equal to 3 over 2, or x is equal to positive 3. Now at this point, it looks like, oh, we're done. You see, with surds, with equations with surds. Once you see that you went ahead to square both sides of an equation, you're actually tampering with the amount of solutions that it has. So because of that, so that you can resolve that, okay, the extra solutions that it might have given you, what you can actually do is you're going to check whether your answer is correct. So you're going to substitute each of your x values into your original equation and ensure that the left-hand side really is equal to the right-hand side. So I'm going to take this equation and let's go ahead and substitute. So you see that we have this, right? This is our equation. I just didn't substitute x. So if we substituted 3 over 2 into this, we need to make sure that we actually do get 1. Let's see what we get here. And when I substitute 3 over 2, I get negative 1. So that is not 1. Okay, we needed to give us 1 because the answer that we had there was 1. So this is not our answer. X is not equal to 3 over 2. But if you substitute 3, so in place of that x, we substitute 3, then let's see what we actually get. We get 1. So it means that 3 actually works and x is equal to 3 only. You're going to get a mark for rejecting one answer and accepting one answer, okay? You can't just leave both of them like that. Okay, so that is it for 1.1.4. And then we move on to the next question. Okay, so 1.2, the next question says, solve the following equations simultaneously. So as you can see, the variables we have is a and b. That's what we need to solve for. Solve for a and b. So we are given this equation that has the highest exponent of a and b being a 2, right? So that is already hinting at this is equation 2. Not because it has a 2, just because it's not linear, okay? It's not a linear equation, or it's not an equation that can create a linear equation. Okay, so because of that, I'm already going to say that's probably going to be equation 2. But then the second equation has a log, and that will probably, when you look at that, it will probably make you panic. But the thing about it is, you see with log, a log equation, right? An equation with log can easily become an exponential equation. And I need you to realize that an exponential equation, for example, if I just wrote this down. So let's say I said 5 to the power of a is equal to 25. Okay, if this was one of the equations that they gave, it's not something to be afraid of, because this equation can easily become a linear equation when you simplify it. Okay, because if you made the bases the same, they'll both be 5, right? And to get 25, you must say 5 squared. Then do you see now, because the bases are the same, the exponents would be equal. This is a linear equation. In simultaneous equations, you need to spot the linear one, or the one that can become linear, and then the other one. That's why I said don't be afraid if you see log again, because a log equation can easily become an exponential equation, and an exponential equation can become a linear equation. So I'm going to go ahead and call this my equation 1, and I'll go ahead and call that equation 2. So let's go ahead and take that log. So we're saying log, we have a base of 2, we have a plus 5 is equal to 3. Let's go ahead and put this and rewrite it in exponential form. So in exponential form, you need to have a base. Remember, that's your base. That's why I said log with a base of 2. So we have 2 as our base. And then the exponent in equation with log, and equation with log is going to be this number that is equal to, okay? So that is your exponent. So 2 to the power of 3 is equal to, and then whatever is left here is what your exponential equation is equal to, a plus 5, like that. So 2 to the power of 3 is 8. So we can actually just simplify that. That is actually 8 is equal to a plus 5, but we can just take that 5 over. So take the 5 over, it becomes a minus 5 and is equal to a. And this equation is simply a is equal to 3. That's all that is. Okay, so that is our linear equation, and we've already solved for a now. Okay, so that was equation 1 that we just simplified. We can go ahead and call that, well, it's like making a the subject, really. So you can call that equation 3 if you want. And we're going to go ahead and substitute that into equation 2. I don't really see the need for that, because this is already saying a is equal to. So I'm going to substitute it into this to solve for a. So in place of a, we're going to put 3. So that is 3 squared times b squared minus 2. And we have ab, so 2 times a, which is 3, and then b minus 8 is equal to 0. Okay, so let's just simplify this. 3 squared is 9, so that's 9b squared. And then negative 2 times 3 is negative 6, and we have b. And minus 8 is equal to 0. And there we go. We have a quadratic equation that we just have to solve for, and then we'll get our answer. So in this quadratic equation, you can use, the reason I don't want to use the factor method here is because if I say 9 times 8, that's a really big number. I don't like working with big numbers like that. You can, it's still fine. I've also shown you an easy way to actually factorize equations by not actually factorizing them, but using the quadratic formula and not showing them that you used it. But I'm still going to work on factorizing, because I still believe that you should know how to factorize regardless of having an easy method. So to factorize this, I'm just going to go ahead and use the cross method. It may be complicated, but it's actually quick in some way, okay, if you think it through quickly. So let's go ahead and say we have 9b squared. We need the factors of 9b squared. Let's just start with it being 9b, right, and b, right? Those give you 9b squared. And then the factors of 8. Well, I know if I leave it as 8, it's definitely never going to give me a 6. So let me break it up into 4 and 2. Okay, I can see that it's not going to help like this, because if I say 9 times 2, I get 18, and then, 18 minus 4, because I can see this is negative, meaning one needs to be positive, one needs to be negative. So however I put it, 18 minus 4 is 14, not 16, not 6, okay? So either ways, it's not going to get me there. How about I just swap this, 2 and 4? Okay, so yeah, that's even worse. That's not going to work, because that's just going to become really big. So maybe the problem is not this part. Let's leave this as 4 and 2. Maybe the problem is this part. So let's break that 9 up into 3 times 3. Let's try it now. Okay, so if you say 3 times 2, you're going to get 6b. And if you say 3 times 4, you're going to get 12b. And this is good. This can actually form negative 6. If this is negative and this is positive, you see that positive 6b minus 12b is negative 6b. So how I know where the positive and the negative will go is like this. Because this is negative 12b, I'll ask myself, how did I get negative 12? I got that by saying 3b times 4. So that must be negative. So it's 3b times negative 4. That gave me negative 12b. And then this is positive because I said this times that. So that takes the positive. Okay, so that's a quick way of thinking about it instead of assigning the signs and then overthinking things. Okay, so those are our factors. They really do give us our middle term. So it means that we have 3b minus 4 multiplied by 3b plus 2 being equal to 0. Okay, let's go ahead and simplify. We're just solving for b. So 3b minus 4 is either equal to 0 or 3b plus 2 is equal to 0. 3b, we take negative 4 over, becomes a positive 4. Divide both sides by 3 to solve for b, and b is equal to 4 over 3. Or we have here b being 3b being equal to negative 2. Divide both sides by 3 to also solve for b, and therefore b is equal to negative 2 over 3. So you see here, we actually found our answers. A is equal to 3. A has one answer. And B is equal to 4 over 3 and negative 2 over 3. And that would be our solution for that question. Okay, so moving on to the next question. So the last question says, if P is equal to the square root of x plus 2 over the square root of 16 minus x squared, for which values of x will P be real? So for which values of x will P be real? Will this be a real number? Okay, so let's think about all the things that will make this not a real number. Okay, so what will make that not a real number? Well, you see they put surds, and that is a very big thing that we can really use here. If you take a surd and you find the square root of a number, okay, and you're square rooting that, it's not going to be real, okay, because we cannot actually do that. We can't square root a number. I know that we do assign a letter to this, okay, but it's not a real number. So that's something that we need to take into account. For this to be real, it should not be negative. Really, what I mean is what is under the square root should not be negative. So that would mean that this part, right, x plus 2, since it must not be negative, it means it must be positive first of all. So we need to make it greater than 0, but then you also have to consider, can it be equal to 0? Is it okay for it to be equal to 0? Well, yes, it's fine for it to be equal to 0. If it's equal to 0, it will still be considered a real number because your numerator is 0. So that's greater or equal to 0. Now we have to consider the denominator now. What should that be for it to be real? Well, we also have a square root there, so it should also not be negative first of all. So 16 minus x squared should be positive. It should be greater than 0. But let's consider, should it be equal to 0? Think about what happens if your denominator is equal to 0, because really we're saying this whole thing just becomes a big 0, right? So if you square root 0, it's 0. If your denominator is 0, you have a number that is undefined. the thing about undefined numbers, they're not real. They're not actually real numbers, because with a real number, it has basically some sort of a direction. It's either positive or it's negative. With undefined, that's not how it works. Undefined kind of does both. It's like heading towards positive and negative infinity. So because of that, it's not real. And so I'm going to leave that like that. I'm not going to say it's equal to 0 there because of undefined. And we just have to simplify this or solve for this inequality. Okay, the first inequality is easy because it's a linear inequality. You just have to solve for it by taking the 2 over. Nothing about it, nothing about critical value. So x is either going to be greater than or equal to, that goes over, -2. Done. Second one, on the other hand, that one is quadratic because you have x squared. So we need to actually factorize this. So you can go ahead and do that whole thing of taking that over, but I'm going to factorize this looking at it like this. This is a square number, that's a square variable. So this is difference of 2 squares. So open up 2 brackets and factorize this like that. So difference of 2 squares, you take the squares of that, which is 4. So it's 4 times 4. The squares of that, it's x times x. And then you just say plus and minus. So now we have to find our critical values. Our critical values here would be, you have, well, it's kind of like solving for x. So if you have 4 plus x being equal to 0, and you take x over, you see that the first critical value is where x is equal to -4. Or the second critical value, it's like having 4 minus x is equal to 0. You can just take the negative x over, and so you have 4 is equal to x. So x is equal to +4. So I can say x and +4. Those are our critical values. And then you just have to solve for this, just like we did with the graph, okay? This, because it is quadratic, it forms a parabola. But do you see that the coefficient of x squared here on this parabola, is negative? So it should be a concave down parabola. And so our critical values is -4 and +4. So remember that our expression, right, needs to be greater than 0. It needs to give us values greater than 0 when we substitute a value for x. Because of that, we are going to say, because we're saying greater than 0, you need to only highlight parts of the graph that lie above the x-axis. So that would be all of this, okay? And if you line these values down to the x-axis to find out what exactly they are, you see that, look at the values, and you're going to have to compare them to -4 and 4. So these values compared to -4, you see that these are values that are greater than -4. They're moving towards that side, okay? And then, so it's going this way. And then compared to the 4, these are values that are less than 4. So when we answer that here, we're really just saying x is either going to be greater than -4, as you can see, the inequality, the arrow helps you with the inequality, or x is less than 4. Okay, we don't have to think about any is equal to 0 because already not equal to 0 from here. Now, do you notice what's going on with these arrows? They're pointing towards each other because they're referring to the same x values, okay? Values that are greater than -4 but less than 4. The same group of numbers. That's really what is going on. So these are a related set of values. Because of that, we can actually rewrite this as one single inequality. So rewrite it as, you put the x in the middle, right? We're really saying x is greater than -4 but less than 4. So put your -4, because this smaller number on the left hand side, the bigger number goes on the right, and we're saying that x is greater than -4 but less than 4. Okay, so those would be our solutions. These two. It's either that x is greater or equal to -2, or x is greater than -4 but less than 4. Okay, so now that we have found the answers, I'm not really going to just say, okay, this is our final answer. You're going to also have to consider this expression and just ensure that they actually do work, like both solutions actually work. Because now looking at this, it looks as if this answer is kind of contradicting this. Let's actually understand these solutions on a number line. So if we're looking at it on a number line, you know that the lowest that it goes is -4. And we also had a -2, which would be on the right hand side. And then we had the highest being 4, right? The solution for this one is x is greater than -4 but less than 4. So it means that it's everything here, all of that. So let me actually just put this. So When it is just greater than or less than without an equal to, I put an open circle for that. And when it is equal to, then I'll put a closed circle. So by the -4, because it just says greater than, open circle. By the 4, I'll just put an open circle. But at the 2, we have x is greater than or equal to -2. So I'll put a closed circle here. And let's just look at the directions they go in. So x needs to be greater than -4. So these values go towards the side. And where x is greater than or equal to -2, these values go towards this side. Where x is less than 4, the values go towards this side. So in a nutshell, because values that are either equal to -2 but greater than -2, right, that they work, we will really just say this is our answer. The reason I don't want to just say that is because I also have to look at the expression and consider what the expression says, okay? It has to work for every part of the expression. The expression says we have x plus 2 over, and this is being divided by the square root of 16 minus x squared. So square root of 16 minus x squared. So let's actually look at that. You see, it doesn't say that x must be equal to -4. Rather, it says it needs to be greater than -4. Let's just take a number greater than -4, like -3. If you substitute this into your expression, it still needs to be real. If you substitute -3, look at what's going to happen. On the denominator, it seems fine because you have 16 minus -3 all squared. -3 all squared is 9. That's 16 minus 9. Okay, that actually works out fine. That's not a problem. So 16 minus 9 is 7 that we'll have there. That's fine. But it's only fine on the denominator. So if this is 7, but look what happens on the numerator. If this is -3, you're going to have -3 plus 2. -3 plus 2 is -1. You see the issue with that? That is still square root of -1. So there's a problem there. We can't actually accept answers that are necessarily greater. Not every single answer that is greater than -4 would work. Okay. And it's really just looking at this, and we can see now that as long as that negative value that we're speaking about here, when we say x needs to be greater than -4, right? As long as that value is something that is, or let me just say, has an absolute value greater than 2. So if it's a number like -3, it's not going to work. Even if it's -3.5, it's not going to work as well, okay? So it can be -2 though. That's still fine, because if that was -2 and you have +2, then that just gives you 0. So it means that I can't actually accept answers that are here, okay? I'm going to have to cut that off, meaning I can only accept answers that are greater than or equal to -2, but less than 4. And you can also check those ones to see if they work out. So when it's equal to -2, it gives you 0. When it's greater than -2, like -1, for example, -1 plus 2, that is 1. That's fine, okay? Because that will be positive, not negative. Okay, on the denominator is also fine because that's 16 minus -1 squared, which is just 16 minus 1, and that's 17. That will still give you a value that is not going to make this non-real. So the reason we could spot that is because of this one, the way it said x is greater than or equal to -2, but it didn't take values that were less than -2. So you see that there is a little bit of a disagreement there between those inequalities. Okay, so the answer, the final answer I would give for this, because everything else here would work, we know that because we were testing that with the inequality, and these values also have an absolute value that is less than that too, so they're not going to make that negative. Okay, so that's one thing that we see going on there. So in a nutshell, our answer is actually supposed to be, at the end of the day, x is greater than or equal to your -2, but less than the 4, and that would be the final answer. Okay, question 1.1.1, we have the usuals. So in this one, you have been given something that has not already been factorized. We have x squared plus x minus 12 is equal to 0. And so we have to factorize it. So we're going to open up two brackets, equate it to 0, and we're saying what times what gives us x squared, that's x times x. Now, what times what can give you -12, but in the middle will give you 1. So let's think about that. I can think of factors as 4 and 3. So 4 times 3 is 12, But then I can see that this is negative, so 1 should be negative. Which one should be negative so we can have a positive 1 in the middle? The 3 should be negative. So that's positive 4 minus 3, which gives you positive 1. So that's plus 4 and minus 3. And then we're just going to finally say that x is therefore equal to, we're taking the positive 4 over the equal to sign and becomes a negative 4. Or x is equal to, we're taking that over and it becomes a positive 3. So those are solutions. Okay, moving on to the next question. 1.1.2 says we have to find out, or basically solve for x, if we have 3x squared minus 2x is equal to 6, and you can already see correct to 2 decimal places, meaning use the quadratic formula. So let's look at that equation first. Is this okay to already start using the quadratic formula? No, it needs to be in standard form. So let's say 3x squared and we have minus 2x, then you need to bring the 6 over. So it's minus 6 is equal to 0. As we can see, our a value is 3, our b value is negative 2, and our c value is negative 6. So we're just going to put down the quadratic formula a. And so x is equal to negative, and what is our b? Is a negative 2 plus minus the square root of negative 2 all squared minus 4 times a, which is 3, and c, which is negative 6, and all over 2 times 3. Then you can just plug this onto the calculator and see what you get. I'm going to start with the plus first. Okay, so when I plug it in, my first answer when I put the plus, of course, is I get 1.786. If you round off to 2 decimal places, that's going to be 89. Or x is equal to, and you're just going to change that sign to say minus instead now. And so we get negative 1.12, rounded off to 2 decimal places because the 9 rounds up. Okay, so that would be our answer for this question. And then we move on to the next question, 1.1.3, which is on surds. So we have, first of all, the square root of 2x plus 1 is equal to x minus 1. Okay, and let me also just check. The mark allocation is 4 marks. So, okay. So as you can see, the surd has already been isolated for you. You don't have to isolate the surd. So that mark is probably what is missing there. So what I'm going to do is I'm just going to go ahead and get rid of this square root by squaring both sides. And then we're going to have 2x plus 1 is equal to, and then we're going to simplify this. Now you can go ahead and say this is x minus 1 multiplied by x minus 1 and FOIL that out. But I feel like that method takes quite long. So I deal with it like this. I say x all squared gives you x squared. And then I multiply the first and the second term together. So that's x times negative 1, which is negative x. And I take that and I multiply by 2. So negative x times 2 is negative 2x. And then I get a positive 1 when that gets squared, of course. So you see, square the first term, square the last term, multiply the 2, and multiply it by 2. Okay, so that's what we have. And then I'm just going to simplify this. So I have 2x plus 1 is equal to, and I have to take things over. 0 is equal to x squared minus 2x. And I'm going to take that over and becomes a minus 2x. Then we still have the plus 1 on the right-hand side. And then I'm taking this over and becomes a minus 1. So 0 is equal to x squared. And that gives us a negative 4x. And those cancel because positive 1 and negative 1 is 0. Now we have this equation. We need to solve for x. So in this equation, it's still quadratic because you have x squared. What you have to do is, in order to solve for x, do you see that x is common in the first and second term? Please be careful here. Do not divide by x ever because you don't know what x is. X could be 0. If you divide by 0, it just completely destroys your equation. It makes it undefined. Okay, so at this point, what we're just going to do is take x out as a common factor. And so then we're going to have x and minus 4, okay, remaining, because that's what's left here. That's an x. And what's left here is a negative 4, of course, if you take out the x. Okay, now that we have this, you see that x is being multiplied by x minus 4. Since they are multiplying, it's really just the same thing as when you saw in the first question. You see that these two were multiplying, and so we just made them equal to 0. We said x plus 4 is equal to 0, and this is equal to 0, and that's why we were able to end up with these answers. That's the exact same thing you're going to do here, because these two are multiplying by each other. You're going to equate them to 0. So if they're multiplying, it either means that x is equal to 0 or x minus 4 is equal to 0. And of course, if you take that negative 4 over, it becomes a positive 4. So x is either equal to 0 or x is equal to 4. Okay, so at this point, because of this, right, where you can see they already isolated the third for you, you didn't have to do that. I know that it is 4 marks, but then usually when we have to check whether our answers are correct or not, it's usually worth 5 marks. But the reason I'm now thinking we still have to check is because they already isolated the third for you. Okay, so even if you check in the 2022 paper, you'll see that you get a mark for isolating the root. Okay, so the mark is really, you get a mark for leaving the root on one side, isolating the root, and then you get a mark for squaring both sides. So this is where our mark is coming from. The root was already isolated, so we're not really getting a mark for isolating that root anymore. The thing about this is we have 1 mark here for squaring both sides. You also get a mark for putting it in standard form. So we put it in standard form, that's 1 mark. So long, this is only 2 marks. Then you get 1 mark for both answers. So in my head, I'm like, where's this 4th mark coming from? And I think it's going to come from actually checking your solutions, because this question is usually worth 5 marks. That's 3rd question. But this time is worth 4 marks, but you can see that they already isolated the third. Okay, so I'm just going to check whether the answers are right. So check for our solutions. Let's just see. Our first solution is x is equal to 0. We are just going to put it back into the original equation. Of course, that one before it was squared. So that is the square root of 2. And what I'm substituting in place of x is going to be 0, because I want to test if 0 is actually a solution. Then I'm saying plus 1 is equal to, and it needs to be equal to the right hand side. So I have x here, so I'm going to say 0, and I have minus 1, and I can already see this is not going to work out because this is going to be negative. So that's negative 1. If you square root 2 times 0 is 0, so that is 0 plus 1, which is 1. Square root of 1 is 1. You know that 1 is not equal to negative 1. So clearly this is not your answer. Okay, but still check that one. Don't just say, oh, okay, then that means 4 is my answer. Sometimes both of them are not even solutions. Sometimes both of them are, and sometimes one is not and one is. So I'm going to again say 2 bracket, and then I have the 4. Then plus 1 is equal to, again, 4 minus 1. Minus 1. Okay, so let me see if this works out. So 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. 4 minus 1 is 3. That works out perfectly. Left is equal to right. So it means that x is equal to 4 only. So that is probably where the 4th mark is coming from. Okay, moving on to the next question. We have now 1.1.4. We have an inequality. So with inequalities, we're just going to first of all make sure that it is in its standard form so that we can actually factorize this. So this is what we were given. It needs to be in the form of ax squared plus bx plus c. So clearly we have to take this 2x over. So we're going to have x squared, and remember it's bx, so it needs to come in between this. So minus 2x, then minus 3 is greater than 0. Then factorize. So open up 2 brackets. We're still saying greater than 0. We have x times x gives you x squared. Now what times what gives you 3? That can give you 2 in the middle. Specifically, what times what gives you negative 3? That can give you negative 2 in the middle. Well, 3 and 1 are factors of 3. So 3 times 1 gives you 3. Which one should be negative so that that middle will be negative? You have to give the negative to the 3, because negative 3 plus 1 is negative 2. So minus 3 and plus 1. Okay, so this is what we have. And now we're just going to solve for the inequalities. So I'm actually going to use a very simple method. I will not use a graph in this video. If you want to see how I use the graph interpretation, you can look at my previous videos. I also have a video on 2022's paper as well. So this is what I'm going to do. I'm just going to use a number line because I feel like it's quicker. I'm going to use a number line, and I need to first put down my critical values. My critical values are really just my x-intercept of this parabola that we have here. And that would be, you see, we have x minus 3. So it means that your critical value would be positive 3. It's kind of like taking this over the equal to sign. So I have a positive 3. And also looking at this x plus 1, the critical value would be negative 1 because you're going to take that over the equal to sign. And really what I'm doing is I'm going to put them on a number line in their correct order. So I know that negative 1 is smaller than positive 3, so it will go on the left and then the positive 3 on the right. And then all I'm going to do here is I'm going to write down one number that is smaller than negative 1, which is negative 2. Okay, that's smaller than negative 1. And then a number greater than negative 1, which is 0. And then with a 3, a number smaller than 3 is 2, and a number greater than 3 is 4. And all I'm going to do is I'm looking at these now because it says greater than 0, not greater or equal to 0. I'll just have an open circle on top of the critical values. Now, I'm just going to substitute these values into this inequality, and it needs to give me a value that is actually greater than 0. So let's go ahead and try negative 2. We can try negative 2 and substitute it into this, and let's see what we get. And when I substitute that, I get 5. So it means that negative 2 is working. It is going towards that direction. Okay. And so when I'm writing this down as an answer, you see that this is just the inequality. When I'm writing down my answers, I'm saying x and I'm putting my critical value down. My first critical value is the negative 1. So x and negative 1, or I also have x and my other critical value is 3, right? Let me actually just keep them in the same color just so that it's easier to look at. Okay, now that we have this, right? I found out that it's working for values that are smaller than negative 1 because negative 2 worked. I tried negative 2 and it works. So it means that x is less than negative 1 because it's working. This inequality is true for values that are less than negative 1. Okay, you can also just follow the arrow. You see that it worked for this. So you always have to substitute it in. When you get your answer, you check if it actually does satisfy that inequality. The inequality says your expression needs to be greater than 0. 5 is greater than 0, so it works. I'll do the same thing for 0. Okay, so for 3, sorry. I'll do the same thing for 3. So let's go ahead and substitute. Because the one going this way worked, by default, I'm going to try the one going this way. Okay, so let's try 4. I'm not even going to try 2. So go ahead and substitute 4 into there and let's see what we get. We get 5, okay? So it's a parabola, it's 5, we get 5. And so it means that yes, 5 is a value that is greater than 0. So this is also working for values that are greater than 3. So I'm saying that x has to be greater than 3. Again, the arrow really helps you with the inequality. You see, if you try 2, look what's going to happen. If you substitute 2 into that, you get a negative 3. That does not satisfy the inequality. The inequality says that this expression needs to be greater than 0, not less than 0. That's how you check whether it works or not. So this is the number line method. This is probably a method you would have learned in grade 11. It is quite helpful. I like to use it sometimes, but it is good to remember the graph method as well because you will be working with graph interpretation a lot. Okay, so this is your answer and here's my number line. So x is either less than negative 1 but greater than 3. And as you can see, they're not pointing towards each other. So the values are not related. I don't have to write them as one single inequality because they're pointing in different directions. Okay, moving on to the next question. Okay, 1.2 says in 1.2, you see that we have a simultaneous equation. In simultaneous equations, quite simple. All you have to do is first identify which one is going to be equation 1. Always take the simple linear one as equation 1. So that would be this. This is a linear equation and it's quite simple. So I'm going to take that as equation 1, also because it has x sitting nicely on its own. It doesn't have a 2 in front of it or anything, so I can make it a subject. And then by default, that is equation 2. So I'm going to take equation 1, and from equation 1, I will create equation 3 by taking 2 over. So x is equal to, we still have 2y, then 2 comes over, minus 2. This is now our equation 3. Then we're just going to go ahead and substitute equation 3 into the equation we didn't use, equation 2. And so every time I see x, I will replace it with 2y minus 2. So that is 1 over, and I have x, so I'm saying 2y minus 2 plus 1 over y is equal to 1. Okay, and so here it's really just arithmetic that you need to just work around and then you can find your answer. We need to solve for y. But you can see that we have a fraction here and a fraction here. So why don't we just see that, okay, we are adding. So if we are adding fractions, the denominators need to be the same. So how can we make these denominators the same? Well, you're going to have to think about what should the common denominator be? At the end of the day, when you make the denominators the same, what will that denominator be, that common denominator? And we call that the LCD. Now, because you have 2y minus 2 and you have a y, your LCD has to be y multiplied by 2y minus 2. And let me not even complicate it by saying LCD and all that. All you're just trying to do is make the denominators the same. And so to make the denominators the same, the common denominator must be this. And really, I'll just show you in slow motion what I'm really trying to do. To make the denominators the same, the only way is to get the denominator to become this. So when I have this fraction, how can I get this denominator to become like this? Well, it has the 2y minus 2, but it doesn't have the y. So I just have to multiply it by y. But what I do on the bottom, I must do on the top. That way, I'm not tampering with the value of this. I'm just tampering with the way it looks. Okay, then I have to do the same to this. Well, not the same thing, but I also have to multiply by something so that its denominator also looks like this. So we have the y. We don't have the 2y minus 2. So I just have to multiply this by 2y minus 2 on the bottom and on the top as well. And then this is 1. Okay, as a fraction, 1, you can write it as 1 over 1. And so if you also wanted to make sure that it has the same common denominator, as you can see, it just has a 1. So the only way to do that is to multiply it by y times 2y minus 2, so that its denominator is actually that. That's what the lowest common denominator is. It's what all the denominators of the fractions are going to become. Okay, so on top as well, I have to do the same thing. And then now this is what we have. So we just have 1 times y, which is y, and then plus we have 1 multiplied by 2y minus 2, which is just 2y minus 2 over, now they have the exact same denominator. Do you see that this multiplied together and this, they're exactly the same thing. They're the lowest common denominator. So that is y bracket 2y minus 2. I can put them together now, okay, because that got added to that. And then it's equal to this as well, y bracket 2y minus 2 over y bracket 2y minus 2. Now, because the denominators are the same and this is an equation, only in equations, not expressions, you can drop the denominators. You can let go of them and focus on the numerators, because the whole point is we have made them equivalent fractions. Now that they're equivalent fractions, we can just focus on solving for y. So we're just going to focus on the numerators now. So we're saying therefore y plus 2y minus 2 is equal to, and I have y bracket 2y minus 2. And I just have to simplify this. So this is going to be, I have y plus 2y, which is 3y minus 2 is equal to, and I'll just distribute that. So y times 2y is 2y squared, y times negative 2 is negative 2y. Then we have 0 is equal to 2y squared. I'm taking these over. And then I still have a minus 2y on this right-hand side. I'm taking that over, it becomes a minus 3y. Taking this over, it becomes a positive 2. So 0 is equal to, we have 2y squared, and negative 2y minus 3y is negative 5y. And then we have plus 2. Okay, so we have to factorize that. So when factorizing this, there is another method. It's called the cross method. But remember, you could use the quadratic formula and still get to the answer. Please make sure to check in my past videos on, you can even use the 2022's paper. I do explain these things. Okay, so what I'm just going to do here is I'm saying that I have 2y. What do I have to multiply to get 2y squared? 2y times y. That will give me 2y squared. And what do I have to multiply to get 2? Well, that's just 2 times 1. But it depends on how I put them. So I will put it as 1 and 2 so that that can create a 4. I also noticed that the 5, right, is negative. It's the only negative term in this trinomial. So it means that both of these are going to be negative. That's why that's positive, because you said a negative 1 times a negative 2. It became positive 2. And that's why the middle is negative. Okay. So I'm going to cross multiply, and that's why it's called the cross method, to check whether it's actually correct, whether it really does give me a negative 5 in the middle. So 2y times negative 2 is negative 4y, and y times negative 1 is negative y. Negative 4y minus y is negative 5y. So that works out perfectly, and I know these are my factors. So 0 is equal to 2y minus 1 bracket y minus 2. And then I just have to solve for y. So solving for y, I'm just going to say 2y, okay, minus 1, of course, is equal to 0, but you're going to take that negative 1 over, and it's going to become a positive 1. Or we have y minus 2, which is equal to 0. And you're just, of course, going to take that negative 2 over. So it becomes y is equal to 2. Here, divide both sides by 2. So y is equal to a half, or y is equal to 2. Those are our two solutions for y. Now, that's just y. That's not x yet. We need to solve for x and y simultaneously. So since we have y, how do we find x? Well, look at the 3 equations that we have. The third equation starts with x is equal to. So we're going to use that equation. So x is equal to 2y minus 2. If you like, you can go ahead and say, this is my equation 4. And in order to find that x, I'll just substitute equation 4 into equation 3. We're going to use that. So we know now that equation 3 says x is equal to 2y minus 2, right? So in place of y, we're just going to substitute our y value. And our y value, the first one is a half. So that is a half. Okay, so if you have, you can just substitute that into the calculator though. So 2 times a half is 1, because the 2's cancel. 1 minus 2 is negative 1. So that's negative 1. Or we have x is equal to 2 times, and the next one we have is 2. So that's 2, and then, sorry, supposed to be in color 2. And then we have minus 2. So 2 times 2 is 4 minus 2, which is 2. So there's our answers. It's either that x is equal to negative 1 and y is equal to a half, or that x is equal to 2 and y is equal to 2. Those are our point of intersection, really, because that's what a simultaneous equation is. It's 2 graphs that are intersecting, and you're finding the x and the y values of the points of intersection. Okay, so that is 1.2 done, and now we are on 1.3. So 1.3's question is, they say 2 to the power of m plus 1 plus 2 to the power of m is equal to 3 to the power of n plus 2 minus 3 to the power of n. Okay, given this, where m and n are integers, you need to determine the value of m plus n. So if you can just solve for m and n, you'll be able to find that. As you can see, this is an exponential. So let's write that down quickly. This is just an exponential expression. So we have 2 to the power of m plus 1 plus 2 to the power of m is equal to 3 to the power of n plus 2 and minus 3 to the power of n. Okay, so since this is just an exponential, let's go ahead and focus on the exponents. What we can do is to see what is going on here first, or to see what is maybe common. We can break up those exponents that are joined together. Remember how if you have the same base and you're multiplying something, you're just going to keep the base the same and add the exponents, right? That's how we're going to separate this. So it means 2 to the power of m plus 1 was created by saying 2 to the power of m multiplied by 2 to the power of 1. That's how we got that. And then we just have plus 2 to the power of m, right? And then that also means that 3 to the power of n plus 2 was created by saying 3 to the power of n multiplied by 3 to the power of 2. Then we have minus 3 to the power of n. Now, do you see that if you look across all of these, do you see something that is repeating? Okay, here. What is common between the first and the second term? That would be 2 to the power of m. So we're going to take that out as a common factor. Open a bracket and we have 2 to the power of 1, or just 2. Then, so that is the first term. And then what's left in the second term? Well, what do you multiply to 2 to the power of m to get back to 2 to the power of m? That would be 1. And that is equal to, we also have here, do you see that there's also a common factor between the two terms here? That is 3 to the power of n. That is common. So that's 3 to the power of n out as a common factor. What do you multiply to this to get back to this? Well, this is already there, so you must multiply by 3 to the power of 2. And what do you multiply to this to get back to this? Well, we'll have a negative this time. So it's a negative 1. Okay. So this is equal to, we have 2 to the power of m times 3, which is equal to 3 to the power of n. And this is going to be 9 minus 1, which is 8. And this is so funny because I remember I was prepping a matric student and I literally told her that I think this question is probably going to show up again, because I kept seeing a pattern of them bringing up this question and they literally put it in again. So you guys, you should try and get used to these questions, these exponential ones, this format specifically. Okay, so what I'm seeing here is a repetition of 3s and 2s, okay, as bases, which is great. So I can see a base of 2, a base of 3, base of 3, but that is not a base of 2, but we can write it as a base of 2. 8 can be written as 2 to the power of 3. So if you rewrite this, this is what we have, right? We have 3 to the power of n times 2 to the power of 3. And in here, we have 2 to the power of m multiplied by, and they're really just being multiplied by 3. And that's also being multiplied. Okay, so you see that the same operation is being used. So if we have 2 to the power of m, right, we will equate that with the 2 to the power of 3. I also explained this in that 2022 paper more deeply, but I don't want to waste too much time with these explanations. So you can also just check that video out. So this would mean that 2 to the power of m would be exactly the same thing as 2 to the power of 3. We're equating it like that. And this would mean that the 3's would also go together. The 3 to the power of an invisible one is equal to the 3 to the power of n. And by the law of exponential equations, when the bases are the same, you can make the exponents equal. So it means that m is actually equal to 3 and n is equal to an invisible exponent of 1. So there we go. But remember, the question says you need to determine the value of m plus n. So therefore, m plus n is finally equal to 3. That's m plus 1, which is equal to 4. And that is our answer. Okay, let's get into the video. So question 1, we are told to solve for x, and we've been given 3x squared plus 5x is equal to 0. Okay, so as you can see, it's not a trinomial. In fact, it's a binomial. You have two terms. And this is not difference of two squares because this is not a square number and there's no minus. So what other type of factorization can you actually use here? Well, you can actually use common factors. So take out a highest common factor. Between the first term and the second term, what's the highest common factor? That would just be x. That's the only thing that is common. So we'll open up a bracket and what is left? In the first term, if you say 3x squared divided by x, you get 3x. And in the second term, if you say the positive 5x divided by x, you get positive 5. And then is equal to 0. Now, when you're at this point, you see you have something multiplied by another thing gives you 0. It's the same thing as having something like this, and that's equal to 0. And then you would make this bracket equal to 0, or say that that bracket is equal to 0, because we're really just saying that two things are multiplying, and the only way they can actually multiply and give you 0 is if one of it is equal to 0 or the other one is equal to 0. So we're saying it's either x is equal to 0 or your 3x plus 5 is equal to 0. And so that means 3x is equal to, we take the 5 over, negative 5. And then to solve for x, divide both sides by 3. And therefore x is equal to negative 5 over 3. So these are our solutions. X is either equal to 0 or x is equal to negative 5 over 3. Okay, moving on to the next question. The next question, we have 1.1.2, and we are given a trinomial, quadratic trinomial, but they tell us that the answers have to be correct to 2 decimal places. So this tells you that you need to use the quadratic formula. Okay, so we have our quadratic formula, and what we're going to do with this is, let's just find what A, B, and C are. So remember that the quadratic equation, okay, the standard form is ax squared plus bx plus c, and so we can see now that 4 is your A value, and then 3 is your B value, and c is negative 5. Okay, so let's go ahead and substitute. We're going to just say x is equal to, we have a minus outside there, our B value is 3, so it's just 3, plus minus the square root of our 3 squared minus 4, and then A is 4, and C is negative 5. And then, of course, that goes all over to A, and A is 4. Okay, so there you get a mark for substitution, and then now you just have to find your answers. So I'm going to go ahead and start with the plus first. Okay, when I put that on the calculator in decimal form, it gives me, so x is equal to, and you just have to round off to 2 decimal places. X is equal to 0.80. Okay, rounded off to 2 decimals. If you change the plus to a minus, then we have all x is equal to negative 1.55, rounded off to 2 decimal places. Okay, and that is our answer there. That is for 3 marks. Moving on to the next question. Okay, the next question, solve for x in this inequality. So this inequality looks a little more different than the other ones. And I'm seeing that there are actually 2 ways that you can simplify it, solve for it. You can either go ahead and distribute that, because you have an x squared. You know that if you have a squared on top of a binomial, it's really just saying that these 2 binomials are being multiplied, okay? Those are square binomials. But I'm not going to do that because that's going to take long. I'm seeing an easier way to simplify this. Do you remember that if you have something like this, let's say you had, and I'll use a different letter, let's say k squared minus 9, right? You had to factorize that. That would give you k minus 3 times k plus 3, right? That's difference of 2 squares that we have here. You can actually use difference of 2 squares on this. Treat this as if it's your k. Treat the x minus 1 as if it's your k, because that thing is being squared. So if we were factorizing this, we could just open up 2, well, big brackets because of that, and then factorize that part by saying we're going to find the square root of that, just like here, k squared, the square root is k. The square root of that would just be the x minus 1. Now, the truth is I actually don't need brackets. I can just say x minus 1 since it's the first term. Okay, if it was here, then I would have to put those brackets. X minus 1 and x minus 1. Okay, that's the square root of that part. And then the square root of 9 would be 3 and 3. And then because it's a minus, it's difference of 2 squares, you just say plus minus. Okay, so that's another way that you could have easily just factorized that. Again, then we can continue and just say it is greater than or equal to 0. And let's simplify. So negative 1 plus 3 is 2. So we have x plus 2. And then negative 1 minus 3 is negative 4. So x minus 4 is greater or equal to 0. Then you just have to simplify this and solve for x because one hand side is already equal to 0. So I'm going to go ahead and look at this and say, what kind of graph does that form? You see, if you had to distribute that out, like FOIL or distribute really, you're saying x times x and you get x squared, then of course you get your negative 4x, but ultimately you have x squared as, and 2 is your highest exponent, so you know that this is going to form a parabola, and it's specifically going to be a concave up parabola because that gave you x squared. The coefficient of x squared is 1. Okay, so we know that. Then we can draw our x-axis. And now that we have the x-axis, let's follow what the inequality is saying and also just our critical values. Since you have a factor of x plus 2, your critical value there, right, is going to be x is equal to, you take that over negative 2. And then the critical value here is x is equal to positive 4. So now we know where they will go. So the 2 will go here, the 4 will go, the negative 2, sorry, and then the 4 will go here. Okay, now you see that your inequality says that this needs to be greater or equal to 0. It's referring to the y values, okay? So the y values that are greater than 0 are here. These are all the y values that are positive. And the y values that are less than 0 are here. So what you can do is when you see they say greater than 0, it says greater or equal to 0, we'll consider that. But when you see greater than 0, what you can do is tell yourself, okay, I must only pick parts of the graph that are above the x-axis. And if it says less than 0, you take parts of the graph that are below the x-axis. Okay, so now I'm only going to focus on parts that are above the x-axis. Let's go ahead and highlight those parts. So that will be here, that's above the x-axis, and here, that's above the x-axis. And now I'm just going to find out what exactly these values are. Where are they? And how you find out that is you just line it to the x-axis. So these are all points, they're little points there. Line it down to the x-axis, and we can see now where they're going. Compared to negative 2, they're moving towards that direction. Okay, and this is how we're going to write our answer. So you're going to put down x and your critical value, which is negative 2, or and then x and your other critical value, which is 4. And now we're solving for this one. As you can see, these are values that are going towards the left of negative 2. These are values that are less than negative 2. So I'm saying that x is less than negative 2, but because it also said greater or equal to, I have to consider that. If I take negative 2 and I substitute it into this equation, it will give me 0. And so I know I have to say less than or equal to negative 2. Okay, so you see the inequality and the arrow, they look the same. So that helps you with that. I have to do the same thing on this side. So line this down to the x-axis. And I see that, oh, it's going that way. So these are values that are what than 4. These are values that are greater than, or I also have to say, or equal to 4 because of that. And that is our inequality. And that is our answer there. As you can see, they're not pointing towards each other. So they are not related values. And we can just leave the answer like that. Okay, so that is it for 1.1.3. And we move on to the next question. Now we are on 1.1.4 and it says we have to solve for x if 5 to the power of 2x minus 5 to the power of x is equal to 0. Okay, so again, it's a binomial. You only have two terms and one side is equal to 0. I want you to look at the first and the second term. And what do you notice that you have in common there? You have 5 to the power of x. So I'm not going to deal with the k method here. It's really not necessary. You can just go ahead and take out your common factor. So I'll take out my common factor of 5 to the power of x. That's what's common in both terms. Open up a bracket. What is left? If you say 5 to the power of 2x divided by 5 to the power of x, what do you get? Or you can also ask yourself, what do you multiply to 5 to the power of x? To get back to 5 to the power of 2x, you have to multiply by 5 to the power of x, not 2. Okay, if you say 5 to the power of x times 5 to the power of 2, if the bases are the same and you're multiplying, you need to add the exponents. And so you would have 5 to the power of x plus 2. Okay, so be very careful with that. I've seen students do that as well. Okay, but if you said 5 to the power of x times 5 to the power of x, the bases are the same. You're multiplying, so you would add the exponents. X plus x is 2x. Okay, and then how do we get the what's left in the next term? That will be negative 5 to the power of x divided by 5 to the power of x. As you can see, it's the same thing. So the negative will be there and you just have negative 1, okay? So what do you multiply to that? To get back to that, you'd multiply by negative 1. Is equal to 0. Same principle as the first question. All we're going to do is this is multiplied by this and they give you 0. So it means that either the first one is equal to 0 or the second one that has been multiplied is equal to 0. Okay, let's work on this. Well, let's actually talk about this now. You see, this is 5 to the power of x is equal to 0. Please take note that 5 is a positive number, right? It's a positive base, and you're raising it to an exponent and it gives you 0. Is that actually possible? No, because if you take a positive base and you raise it to any number, it's always going to give you a value that is greater than 0. It will never be negative and it will never be 0, because this is already a 5. Even if you raise it to -1, guess what? It's going to give you 1/5. Still a positive number, okay? It can never give you 0. Even 5 to the power of 0 is 1. Okay, so just keep that in mind. That one is not possible. And now we go here. So we're going to take the -1 over. So we have 5 to the power of x is equal to 1. And now how do we solve for x? Well, you've got a base and an exponent and then a number. So make the bases the same. 1, how can we make 1 a base of 5? We can call it 5 to the power of 0. And so we have 5 to the power of x is equal to 5 to the power of 0. Our bases are the same, and therefore we can now make our exponents equal. X is therefore equal to 0. And that is our answer there. Okay, moving on to the next question. And now we're on 1.1.5, and this is for 5 marks. So take notes. It's a third question that is for 5 marks. There's a reason why, but we'll talk about that. So we have x over the square root of 20 minus x is equal to 1. Okay, you have thirds, and this is in a fraction. Don't get afraid when you see it as a fraction. All you can do is this. First of all, you see this 1, it can also be made a fraction simply by putting it over 1. That's how you make any whole number a fraction. Put it over 1. And then what we can do is just cross multiply. So the numerator multiply by that denominator, and then this denominator times that numerator. Okay, so square root of 20 minus x times 1 is square root 20 minus x. And x times 1 is x. Okay, so now we have this. Now, what is our next problem? Our next problem is the third. We have to get rid of the third, and we can only do that by squaring it. But this is an equation. What you do on one side, you must on the other side. And so what happens is, because they're the inverse of each other, they cancel. And you have 20 minus x is equal to x squared. And as you can see, this is going to become a trinomial. Let's go ahead and move everything here over to that side, since this is already x squared. So we have 0 is equal to x squared. That comes over and becomes a positive x. That comes over and becomes a negative 20. Okay, so factorize your trinomial. 0 is equal to, open up 2 brackets, x squared. We get that by saying x times x. And how do we get 20? Factors of 20 that can give you a positive coefficient of 1 in the middle. So let's think about that. 20 divided by 4 is 5. So we could say 4 times 5 is 20. But how do we add them so that they give us positive 1? And we know that this is a negative 20, meaning 1 must be negative, 1 must be positive. Well, you can make the 4 negative and the 5 positive. So positive 5 times negative 4 is negative 20, but 4 minus 5 is positive 1. Okay, so we have minus 4 and plus 5. Okay, and then let's solve. So therefore, it means that x is equal to, you take the negative 4 over, it becomes a positive 4, or x is equal to negative 5. Okay, now are we done? Not really. This is 5 marks. So you need to make sure you check whether your answers are actually correct or not. So what we're going to do is we're going to test whether these answers are correct. You're going to use the original equation, okay, that we had, and you're just going to substitute in place of x each of these numbers to see if they really do give you 1. So let's go ahead and try 4. So if I put 4 here and 4 here, okay, let's just quickly rush through that. So 20 minus 4 is 16. 16, square root of 16 is 4. That's 4 over 4, which is 1. That's true. So that does work out. This works. Okay, so now let's go ahead and try a negative 5. So negative 5, if we substitute that in, that is minus 5 and 20 minus negative 5. Okay, so that is going to be, our negative 5 is still on top. Well, you can already see this is going to be negative, but it's fine. Square root of 20 minus minus 5. That's 20 plus 5, which is 25. The square root of 25 is 5. Negative 5 divided by 5 is negative 1. As you can see, 1 and negative 1, they're not the same number. So we can see that that one doesn't work out. So what you can do is show them that you know that now. You're going to put a cross here, tell them that's not my answer, and then this is your answer. So if you like, you can also say x is equal to 4 only, and that is our answer there. Okay, so that is it for 1.1.5, and we move on to the next question. Question 1.2, we have a simultaneous equation. So we have to solve for x and y simultaneously, and you've been given two equations. First and foremost, always put the linear equation as equation 1. So we're going to call that equation 1, and this one equation 2. So from equation 1, we're going to make a subject. In this one, it's quite easy because they're both just sitting on their own. They don't have anything like 2 or 3 or any number other than 1. So I'm going to go ahead and make x the subject. X is equal to, and I still have 9 here. And I'm going to go ahead and take the y over and becomes a negative y. And this is now our equation 3. Then, in order to go ahead and solve for y, we're going to substitute equation 3 into the equation you have not touched yet, which is equation 2. Okay, so let's go ahead and rewrite that. We have 2x squared. So we have 2x squared, and so every time you see x, replace it with 9 minus y. So we're going to say 2, and we have 9 minus y squared minus y squared is equal to 7. Okay, simplify. As you can see, you have a squared here. So you need to actually fix that first. You have to first of all simplify that. So we still have the 2. Now, when you distribute that, you can do it that traditional method of doing this and then distributing, which takes long. But what I'm just going to do is I'm going to go ahead and square the first term. 9 squared gives you 81. And then I say the first term times the second term, which is going to give me a negative 9y. And then you multiply that by 2, which gives you a negative 18y. Then lastly, you square the last term. Negative y all squared is going to give you positive y squared. Okay, then we have minus y squared is equal to 7. So just be very careful here. Then we're going to distribute. So we're going to say the 2 times the 81, which is going to give us 162. And then the 2 multiplied by the negative 18y, which is negative 36y. And then the 2 multiplied by the y squared, which is positive 2y squared. Then minus y squared is equal to 7. Okay, we can bring that 7 over. So minus 7 equals 0. Okay, so as you can see, I'm going to put this in the order of the exponents. So let's start off with the 2y squared minus y squared, which is going to give us a y squared. We're done with that one now. And then you see that this is the only thing with a y. So minus 36y. And then we have 162 minus 7, which is going to be 155 because the 7 is made of 5 and 2. So 160 minus 5 is 155. So positive 155 is equal to 0. And you have to factorize. Okay, now I know it's exams. When you're in the exam room, you're trying to save as much time. So I will actually just show you a quicker method. What we can do here, instead of looking for our factors, is you can go ahead and use the quadratic formula. Just don't show them that you've used it. So what I'm going to do is I'm going to use the quadratic formula here. It is negative b, and my b here is negative 36. So I say minus and then negative 36 plus minus. Let's start with the plus. And we have the square root of b squared, which is our negative 36 all squared. Also, if you're hearing sounds in the background, please just try to ignore it. They're doing some work outside. And then minus 4 AC. So 4, and then A is, as we can see, A is 1 and C is 155. Okay, all over 2A. And we have that. So as you can see, the first factor we get, or the first solution we get, is 31. So here is what we're going to do. We're going to open up two brackets, of course, and say is equal to 0. But then what we're going to do here is we're already solving for y. So it's either that y is equal to 31. So think about it. If y is equal to 31, what is the factor that you had that helped you to get 31? It must have been y minus 31, okay? Because you'd have said y minus 31 equals 0 and taken the negative 31 over. To find the second factor, I'm just going to change that, and then I get 5. So I know that the solution that I get is y equals 5. So the factor must have been y minus 5. Okay. Okay, so that's how that first part is solved. And as you can see, we have the solutions for y, or the equations for y. And I'm just going to go ahead and call that equation number 4. Now, to finally solve for x, you can substitute your equations of y, equation 4, into the equation for x. That's equation 3. So substitute equation 4 into equation 3. Okay, so let's go to equation 4. And this is what equation 3 is. X is equal to 9 minus y. So we're saying x is equal to 9 minus, and the first y value we have is 31. Okay, so therefore x is equal to, and we get negative 22. Okay, and then you can say, or x is equal to, and then that is 9 minus your second value, which is 5, and x is therefore equal to 4. So those are our solutions. When x is equal to negative 22, y is equal to 31. X is equal to 4, y is equal to 5. Okay, moving on to the next question. And then we have the last question in question 1, which is 1.3, and it says, given p is equal to 1 minus a and t is equal to 1 plus a times 1 plus a squared times 1 plus a to the power of 4, and this goes on until 1 plus a to the power of 512. We need to determine the value of p times t in terms of a. Okay, them already saying in terms of a just means that when you finally multiply the equation of p with the equation of t, you're going to just get your answer, and it's going to be in terms of a. Okay, so how are we going to work this out? Let's look at this. This equation, or these equations that they gave us, the first one is just 1 minus a, but then the second one is what we need to really look into and figure out. So let's actually just try to understand this equation quickly. You see that we have 1 plus a, and then 1 plus a squared, and then 1 plus a to the power of 4, and then 1 plus a to the power of 512. The only thing that is changing is that exponent on the a. So let's just see what they did. Here the exponent on a is a 1, and then we have the exponent being a 2. How do we get from 1 to 2? Well, we could say 1 times 2, and then that gives us 2. And then we have a to the power of 4. So how do we get from 2 to 4? You could also say 2 times 2, and that will give you 4. And so if that is really the pattern, then we should have it like this. And I can't just assume it is the pattern. I'm going to test whether it is the pattern or not. So I'm saying that our t, and I'm just going to say t equals, so I don't have to keep writing t is equal to, and let me just rewrite what is there first. So I'm saying the next term, because it seems like these exponents, they're just being multiplied by 2. So 1, and then 1 times 2 is 2. Then 2 times 2 is 4. Then 4 times 2 is 8. So the next term should be 1 plus a to the power of 8. And then 1 plus a to the power of 16. And this should keep going all the way to 1 plus a to the power of 512. Now, this is what I was saying, where I said I can't just assume that that is the pattern. I have to find out whether it is or not. If truly it is the pattern, then when I go from this 8 to the power of 4, right? Or let's just focus on that 4. When we go from that 4, we should be able to keep multiplying that number or the previous number by 2, and we should be able to get to 512. If we can do that, then this is really our pattern. So let's think about that. So we could say 4 times 2 and we get 8. We really do have 8. 8 times 2, we get 16. 16 times 2, we get 32. 32 times 2, we get 64, right? And we'll keep going, and it's going to take long. So I don't really have to do that, honestly speaking. I wanted to continue multiplying, but that's very unnecessary. That's going to take really long. All you have to do for you to know whether this is true or not is to find out if 512 can actually be divided by 2. And then that would be true, because these are all just factors of, well, not factors of 2, because 1 is not a factor of 2, but we are counting in 2's. We're multiplying by 2. So the only way that that could really end there is if it is divisible by 2. Okay, you can on your own go ahead and multiply, but I actually did try, and let me just test it quickly. I'll just check it out and see if it works. And let me actually just show you a quick way of doing that on your calculator. If you have a calculator, this shouldn't be difficult to do. All you're going to do is say 1 times 2 equals 2. Then say times 2 equals. Then the calculator starts to realize what you're doing. Like, oh, okay, so we're just multiplying by 2 the whole time. Then if you say equals, it will say 8. And then equals, and just do that. And if you see 512, then you know it's true. So there we go. You don't have to do that. So that is the pattern for real. Okay, so it ends at 512. Great. Now we know what our pattern looks like. We even know how to draw it out completely. That's a good thing. Now we just have to answer what they told us. Well, what they want us to do is take P and multiply it by T, and we need to express that expression in terms of A. So let's go ahead and multiply P times T. So we're saying P multiplied by T equals, and I'm just going to rewrite this again. Okay, P first of all. P is this. It's completely different. Let me write it in red. P is 1 minus A. And then we're going to multiply that by that. Okay, let's go ahead and multiply. So let's see what happens when we multiply it first. Do you see that these two terms, well, they're not terms, but these two brackets that we're multiplying, right? They are going to form difference of two squares, or they're really just the expansion of difference of two squares. So it's 1 and 1, A and A, minus and plus. So if you multiply them, they would become 1 minus A squared. And that is going to get multiplied to everything else that is still left. And now you see another 1 plus A squared, which is going to be difference of two squares with that one again. So when we multiply there again, we get this situation. And I'll just continue writing that just so that they can see, okay, that you are actually simplifying. Now, I'm not going to simplify all the way because you can already see what's going on at this point. When you multiply these two together, you're going to get 1 minus A to the power of 4. Which is going to multiply with that one to give you 1 minus A to the power of 8, which is going to multiply with that one to give you 1 minus A to the power of 16, and as you can see where we're going. So let me actually just figure out what the one before this would be. That one would be, so I'll just rewrite everything. Let me paste it in. So as you can see, the way the pattern keeps going, you keep having these two being the same, and so they form difference of two squares, and then they become the next one, right? And as you can see, the next one has an 8, but the previous one had a 4. So it's always going to be that divided by that. So to figure out what was before the 512, you could say 512 divided by 2. Okay, so if you said 512 divided by 2, you're going to get 256. So I know now the previous one before this must have been 1 plus A to the power of 256. Okay. And so again, in a nutshell, what's going to happen is you multiply this one with this one. Then that would become 1 minus A to the power of 8. It would multiply with this one and become 1 minus A to the power of 16. It will multiply with that one, and then it keep on going. Okay. And then you're going to get to a point where you will literally just have 1 minus A to the power of 256, which would multiply with this 1 plus A to the power of 256. And of course, you still have that 1 plus A to the power of 512. Then when they multiply, they will become 1 minus A to the power of, remember the bases are the same. When you're multiplying, you need to add the exponents. That's actually what's going on there. When you add the 256 and the 256, they give you 512. And then you're going to multiply that 1 plus A to the power of 512. And then we're just going to have to find this answer. And then that is going to give us, again, it's difference of two squares. So it's going to be 1 minus, base the same, multiplying, add the exponents. It's going to be A to the power of 500, and 500 is 1000. 12 times 12 plus 12 is 24. So 1024. That is what P multiplied by T is. It is 1 minus A to the power of 1024. 24. And that is our answer there. So we start off with the first question in question 1, which tells us to solve for x if we are given this equation. So as you can already see, one hand side is equal to 0. So we can go ahead and say the first factor, so the first value that is being multiplied, is either equal to 0 or the second value, which is the x minus 3, is equal to 0. And of course, if you take your negative 3 over, it means that x is equal to 3. And those will be our answers. And that's why it's just 2 marks, because they factorized it for you. Moving on to the next question. The next question, 1.1.2, says we need to solve for x again, but this time correct to 2 decimal places. And you know that when they say that, they're really just hinting at use the quadratic formula. So first of all, notice that it's not in its standard form. So we need to take that 4x over. So we have 2x squared and then minus 4x to put it in the order of its exponents. And then plus 1 is equal to 0. Okay, so our quadratic formula looks like this. And now all we have to do is substitute. So x is equal to negative, and you see that the b value, okay, the number in front of x is negative 4. So negative bracket negative 4 plus minus the square root of, and then we have negative 4 squared because that's b, minus 4, and then our a value is 2, and our c value, as you can see, is positive 1. So times 1 all over 2a, and a is 2. So there we go. So just punch that into your calculator, and then we're going to get our 2 solutions for x. Okay, so the answer will be in third form, but in decimal form, that is 1 point. So round up to 2 decimal places, that is going to round up to 71. And then to get the second solution, we're going to change that to a minus, and now we get 0 points, and that is just going to say 29, okay, because the 2 falls away since it rounds down. So those are our answers, and we move on to the next question. The next question, 1.1.3, we have a trinomial and an inequality that we have. So let's go ahead and factorize since one hand side is already equal to 0. So we have x times x gives you x squared. Now we need factors of negative 3 that can give us negative 2. So 3 is a very easy number to find factors because it's a prime number. It only has 2 factors, 3 and 1. So because this is negative, 1 needs to be negative, 1 needs to be positive. If you make the 3 negative and you make the 1 positive, you know that negative 3 plus 1 is negative 2, and that is the coefficient of the middle term we have. So we know that that is indeed the factors that we have there. Solve. Now we have to go ahead and find the values in this inequality. You can choose to use the table method like I did in this video, or you can use the graph method, which I recommend because, you know, for grade 12s, it really just works better. So we're going to put down our x-axis, and you see that our graph is a concave up parabola because the a value is 1, it's greater than 0. So we have a concave up parabola. Then we need to put down our critical values. The critical values is kind of like just solving for x. So solving for x there, you would really just take the positive 1 over and you get a negative 1. And here you'd get a positive 3. So it's negative 1 and 3. The smaller one is negative 1, so it goes on the left. The bigger one is 3. So they want us to solve for x where the graph is greater than 0. Remember that when they're referring to greater than 0, they're referring to the values on the y-axis. Values that are greater than 0 are here. So you only take parts of the graph that has values greater than 0, which would be the top part of the graph. See, if you line these to the y-axis, do you see that all these parts of the graph have values greater than 0? Okay, so that's what we're going to look at. It's this part and that. Now we have to determine the values of x for which these parts of the graph exist. And you see that if you line it down to the x-axis to find out where exactly are these x values, these values are over here on the left-hand side of negative 1. So they're moving towards that direction. Okay, so you can actually say that these are values that are what? Than negative 1. These are values that are less than negative 1. So therefore here, x is less than negative 1. And you see how the arrow, the direction helps you with the inequality. Okay, and then we're going to do the same thing for 3. So 3, we know that these are the parts of the graph we're looking at. If you line those parts down to the x-axis, you see that it's moving towards the right-hand side of 3. So these are values that are greater than 3. So, or this is where x is greater than 3. Again, the arrow helps you with the inequality. Okay, so these values are not related. They're not pointing towards each other. So you don't have to write them as one single inequality. So that is your answer there. Moving on to the next question. The next question is an exponential equation, 1.1.4, and we need to solve for x. So do you see that in this exponential equation, look at what we have. We have 2 to the power of 2x, 2 to the power of x plus 2, and then of course a minus 32. One thing you should always look for in exponential equations is repetition. Do you see that there is something being repeated in this equation? And that is actually 2 to the power of x, okay? Do you have a 2 to the power of x here? Yes, there's a 2 next to it, but it's still 2 to the power of x. You also have a 2 to the power of x here. So what we can do is really just break it up first, break that up, just so that you can see what that is. So let's rewrite this as 2 to the power of 2x minus, and we have 2 to the power of x multiplied by 2 to the power of 2. That's what you would multiply together to get 2 to the power of x plus 2, because the exponents get added since the bases are the same. So minus 32, and really 2 to the power of 2 is really 4. Okay, so it's multiplied by 4 is equal to 0. And then now, because you see that you have something repeating, but you have this scenario where you have 2 to the power of 2x, this is an exponential equation that can be expressed as a quadratic equation. And it's really that one where you have to use the k method. Okay, so what we're going to do is take the thing that is being repeated, right? That 2 to the power of x. And we're going to say, let k be equal to that thing that's being repeated, 2 to the power of x. So wherever we see that, we replace it with k. So we have 2 to the power of 2x here. So technically what that's going to be is, because you have your 2 to the power of x there, right? That stands for your k. And then you still have an exponent of 2. So that's k squared. And then you have minus 2 to the power of x, and you know that is k. So that's really minus k multiplied by 4, which is minus 4k. That's what we have there. And then minus 32 is equal to 0. So we have a trinomial now. Okay, let's go ahead and factorize this. So k times k is what gives you k squared, so k and k. And then we need factors of 32 that can give us a negative 4 in the middle. Okay, let's take big factors. So I wanted to take 16, but that's a bad idea because 16 times 2 is 32. How about we take 8? 8 times 4 gives you 32. So we need one of it to be negative, clearly, because your factor is negative here. So to make sure that the middle stays negative, give the negative to the bigger factor. So negative 8 plus 4. Negative 8 plus 4 gives you negative 4. So that works out perfectly. So our factors here are negative 8 and positive 4. That's what we have there. And we can go ahead and solve for k first. So it will mean that k is equal to positive 8 or k is equal to negative 4. Now, the question is not to solve for k. The question is to solve for x. So to solve for x, we're going to get what we assigned to k at first, right? Which was that 2 to the power of x. So since we said k was equal to 2 to the power of x, let's replace that now with k, okay? So 2 to the power of x is equal to 8, or 2 to the power of x is equal to negative 4. And now we can finally solve for x. So here, to solve, it's an exponential, so the goal is to make the bases the same. So 2 to the power of x is equal to 8 as a base of 2 is 2 to the power of 3. And so now that the bases are the same, we can therefore equate the exponents. So x is equal to 3 there. And then here, 2 to the power of x is equal to negative 4. Unfortunately, it's not positive 4. If it was positive 4, we could make the bases the same. But here we can't make the bases the same because the only base you can get here is negative 2, which is not 2. So this is not possible. And that's not really the reason it's not possible. The reason it's not possible is because you have a positive base raised to an exponent and it gives you a negative number. That's impossible. Okay, even if you took a positive base and you raised it to a negative number like negative 1, that's going to give you a half. If you raised it to negative 2, it's going to give you a quarter. So you see that it's always going to give you a positive number. So there's no way it can give you a negative number. And that's why that part doesn't have any real solutions. And this is our answer. Okay, so that is it for 1.1.4. Moving on to the next question. The next question, 1.1.5, is an equation with surds. Okay, you guys know the drill with equations with surds. Always isolate the surd. So we need to leave the surd alone. Let's just leave it here on this side. And then we can go ahead and take our negative x over. Because it becomes a positive x, I'm just going to put it in front and say this is x plus 2. Okay, we've isolated the surd, and now we need to get rid of that surd so that we can solve for x. So we would get rid of a square root by squaring both sides. That's the opposite of square root. So that's going to break open that root, and we have negative 2x plus 4 is equal to, and then you have to distribute there. So you can choose to do this as x plus 2 times x plus 2, but I try to always take short methods so that I can avoid making mistakes. So here's a quick method. You're going to go ahead and square the first term, and that gives you x squared. And then square the last term, and that gives you positive 4. Then first term multiplied by second term gives you 2x, and then just multiply that by 2, which gives you positive 4x. And there we go. Okay, so that is distributed. And now you see that it's going to form a trinomial. So take everything here over to the right hand side. So 0 is equal to, and we're going to have x squared plus 4x. And then that comes over and becomes a positive 2x. So 4x plus 2x gives you 6x. So positive 6x. And then you have, let's see, there's a positive 4 here. And then this positive 4 comes over. So they will both cancel. Okay, we could even have canceled that already because they were both the same thing. So now we have a binomial, and the only way we can actually factorize this is by taking out a common factor. So x is out as a common factor because that's exactly what is common. And then open a bracket. What do you have left in the first term if you take out x? You'll be left with x. Okay, you can say x squared divided by x. And then in the second term, what do you have left when you take out x? So 6x divided by x, you're just going to have 6. Okay, so that's what we have there. And then let's solve for x. Something times something gives you 0. It means that the first thing is either equal to 0 or the second thing is equal to 0. And of course, if you take the positive 6 over, it becomes negative. Okay, so these are our two solutions. Now, I mean, this is for 4 marks, so it doesn't even look like they're trying to tell you to still check, but I will still check whether it's correct or not, which ones are correct. So we can do that by saying we're going to use the original equation. It's just easier to start from the original. So minus 2, and in place of x, we will substitute a value for x to find out whether the left-hand side really is equal to the right-hand side. So in this case, it must give us 2. So we're going to say negative 2 times x plus 4 and then minus whatever x is. And it should give us 2. So let's go ahead and try the 0. If you substitute 0 into this, what do we get? Well, negative 2 times 0 is 0 plus 4 is 4. Square root of 4 is 2. And then you have 2 minus 0, which is 2. So this works out. That is definitely a solution. Then we can go ahead and try this with this negative 6. So minus 6 and minus 6. So that will become a positive 12 plus 4 is 16. Square root of 16 is 4. And now you have these multiplying. You can use a calculator, okay? And so that's going to give you a positive 6, and that's 10. 10 is not equal to 2, okay? 10 and 2 are not the same number. So because the left and the right hand side does not balance, it means that x is not equal to negative 6, but x is equal to 0. Okay, so that is it for 1.1.5. X is equal to 0 is our answer. Moving on to the next question. The next question, 1.2, is a simultaneous equation. We have to solve for x and y when we are given these. Okay, they gave you a linear one. Great, that's like the easiest one they can give you. So when we look at these, let's go ahead and name the equations. You can always just call your linear equation equation 1. And then the other one that they give you equation 2. So we have 2x plus y is equal to 3. And from equation 1, we form equation 3. You see that y is nicely on its own, doesn't have any coefficient other than 1 in front of it. So we're going to make that the subject. And we have 3. Take 2x over, it becomes minus 2x. So this is our equation 3. right? And we can go ahead and say substitute equation 3 into the equation you didn't use, equation 2. Okay, so let's go ahead and substitute 3 into 2. So wherever you see y, you're going to replace it with 3 minus 2x. So we have a y squared there. We'll just say 3 minus 2x squared, okay, because that's y squared. Then we have plus, and we have x first, and then y again. So 3 minus 2x is equal to 2. So that is our equation 2. And we can go ahead and solve for x now. Okay, so we have that whole thing where we have a binomial squared. So the quick method, we take the first term and square it, and it gives you 9. Take the second term and square it, you're saying negative 2x squared. Okay, if you say negative 2x squared, it's going to give you positive 4x squared. Then you say the first term multiplied by the second term. 3 times negative 2x is negative 6x. And then you multiply that by 2. So that gives you negative 12x. Okay. And then we have this. We can just distribute here. So it's actually foiling out there. So plus, we have 3x. And then positive x times negative 2x. That gives you negative 2x squared. Might as well just take this over since everything here is going to just be a trinomial or binomial. But we're going to have minus 2 is equal to 0. And let's go ahead and simplify. So we're going to start with the x squareds because it's better to put them in the order of the exponents. So that's going to be 2x squared. That's what it simplifies to. And then the things with x. So we have a negative 12x and a 3x. That's like saying positive 3 minus 12. Positive 3 minus 12 gives you negative 9x. And then lastly, the numbers. We have a positive 9 minus 2, and that gives you positive 7 is equal to 0. Okay, so we have this type of equation where you see that's not actually a common factor, but we can still work on this. So to factorize, you can use the method that you use. The method, I use 2 methods, the factor method and the cross method. Here's this video to show you how to work with the cross method. So I'm just going to use the cross method here. So we're going to look for the factors of 2x squared, which is 2x and x. So 2x times x gives you 2x squared. And then the factors of 7. So that is 7 and 1. You could write it as 1 and 7, but that's not a good idea because when you're multiplying across, and that's why it's called the cross method, because we multiply across. So 2x times 7 is going to be 14x. So you don't want that to be too big. So we're going to write it as 7 and 1 instead. Okay. Also notice now in your trinomial that only the middle is negative, meaning both factors need to be negative. We're really just saying negative 7 times negative 1 gives you positive 7. And only them being added like that would give you negative 9. Okay, so just check if it works. So 2x times negative 1 is negative 2x. And x times negative 7 is negative 7x. That, if you subtract negative 2x minus 7, is negative 9x. Okay, so that does work out. And so we know what our factors are. This is a factor and this is the other factor. So it means we have 2x minus 7 and x minus 1 is equal to 0. Okay, so that's what we have. And now we have to solve for x. So this is 2x minus 7 is equal to 0, or x, well, just take the 1 over, is equal to positive 1. Okay, then here we're going to say, I might as well just take it over here. So it's positive 7 when you take it over, and then divide both sides by 2. Therefore, x is equal to 7 over 2. So these are our values for x. X is equal to 7 over 2, or x is equal to 1. So we've just solved for x, and now we need to find y. You can call this equation number 4. And then lastly, to solve for y, substitute equation 4 into equation 3, because that's the equation where y is the subject. Okay, so that is y is equal to, and this is 3 minus 2x, so 3 minus 2x. And our first x value is 7 over 2, so 7 over 2. Or, and let me just rewrite so I don't forget what that is. So 3 minus 2, and then in place of x, you're going to put your second x value, which is 1. Okay, so simplify, you can just use a calculator. But here, you see that there's 2 and 2. So on the denominator and the numerator, and they cancel. So that's 3 minus 7, which is actually negative 4. Or y is equal to negative 2 times 1 is negative 2. So 3 minus 2 is 1. So these are our solutions. So we have -4 and +1. Okay, so that is it for the simultaneous equation. And then we move on to question 1.3. Okay, question 1.3 says, consider the product, and we have the product. So consider the product, and we have 1 plus 1 over 2, 1 plus 1 over 3, 1 plus 1 over 4. So you can see how the pattern is going, 1 plus 1 over 5, and it just keeps going. And they tell us that each factor in the product is of the form 1 plus 1 over n. Each factor. So because they're being multiplied, each of it will be called a factor. So each of these have this form. That's what they really say. And they say it's for where n is greater or equal to 2. And we can see that is true because, see, this is n. And you see that it starts where n is equal to 2. And then it's all values that are greater than 2. Okay, so they're just stating what we have there. Then they say determine all the values of n. So solve for n. Determine all the values of n for which the product will be an integer value. Interesting question. Now, the thing about this one is I feel like I've seen this before, honestly speaking. Like, this doesn't seem like a new thing they brought in. I will still check which paper exactly I saw it in. If I don't find it, sorry about that, but I really feel like I've seen this before. Okay, but let's just focus on their question. Their question is you need to find all the values of n for which the product will be an integer value. Let's focus on what the product means. Remember how I said these things that we have here? These are factors. And when you multiply these factors, they give you the product. Like they said, consider the product. So the question is you need to find all the values of n for which this is going to be an integer value. So once we find the product, once we multiply these out, we need to solve for n where this is going to be an integer. Okay, let's go ahead and work on this. So with the way this looks, let me just rewrite what we have first. So with the way this looks, to start multiplying it out like this is going to be it's not going to be easy to do that. How do we multiply these two? So why don't we just find out what they would be if you added it individually, added each of these factors. So if you added this one, first of all, so this is the product we're working on. And let's add 1 plus a half. You can use your calculator. That will be 3 over 2. Okay, you can use a calculator. So that one will be 1 times 3, which is 3, plus 1, which is 4, and the denominator stays the same. And this one, 1 times 4 plus 1 is 5, and the denominator stays the same. So this is what it looks like. And what we're going to have to do is find the product. So that's what they said. Consider the product, then tell them the values of n for which the product will be an integer value. So we have to find the product of this. Okay, now with the way this is going, because it's just continuing, we need to know where it ends. We may not have an actual value because it just continues to infinity, but we can actually give it an ending point by using its formula, really. Okay, you see that all of these terms, regardless of what they are, it's always going to be in this form. It's going to be 1 plus 1 over n, meaning 1 plus whatever n is, as long as n is greater than or equal to 2. So the last number could be a big number, but we can't just start giving it a number. We can't say, oh, okay, maybe it's 100, because it doesn't end at 100. So we can't say that. So what we can say it ends at is the last term should be 1 plus 1 over n, okay, because that is the nth term. I say term, but these are factors. They're not really being added together. So with that, and because we already know that n is greater or equal to 2, when we're looking at it here, like when you have to simplify it, when you multiply this out, so we can actually just add this up to find out what exactly the last term is, but we can kind of see what it is already, because here the denominator is 2. So it means the last term that you can get here, right, because it's the last term, would be n, and then the numerator, just follow the way these numerators look. Do you notice that here the denominator here starts at 2? So it's whatever this value n is. And then it just progresses from there. It's a number bigger than that, and then a number bigger than that. But do you notice that the numerator right, is always one number more than the denominator. You see, 4 is one more than 3, 5 is one more than 4, and so on. So the numerator would be n plus 1, meaning whatever your last term was, and then plus 1. That's what keeps happening. You could have also added these together and you would have seen that it actually would work. If you said 1 over 1 plus 1 over n, and then make the denominators the same, so you have to multiply that by n, so n over n, and that's going to be n plus 1 over n. See? Okay. But we could also just use logic to get it as well. Okay, so now that we know, okay, we have some sort of an end, it's probably an infinite number, but we have some sort of end. We can actually look at what these factors are doing. Now, these factors, remember, they're being multiplied. What happens when you have a common factor on the numerator and then on the denominator of another fraction? They would cancel. So that's what's going on here. You see that if you start from the 3 over 2 and you look at the 4 over 3, the 3 and the 3 would cancel. And then here, the 4 and this 4 would cancel. Here, this 5 and the next 5 would cancel. And with that being said, it's best to actually find the second last term so that we can just see where exactly what cancels, what's going to leave completely. But so long we can see everything is gone here except for the 2. Okay, so let's see what the second last term is. Because it's the previous term, how you're just going to look at it is, if this was n plus 1, then the term before this would just be one number less than what it was. So if this is n plus 1, the previous term would be n plus 1 minus 1, which is n. Okay, over, and then if this is n, it's just going to be exactly what this is, and then minus 1. So it's just a number less than what this was. So that would be n minus 1. Okay, and now looking at this and just seeing what exactly cancels, do you see here that n would cancel with n? That means that you would have had an n minus 1 here cancelling with this n minus 1. And now we're looking at our product and seeing, what does our product give us? Well, our product, we have a denominator of 2 here. Remember, when things cancel, they really just become 1. It's like, it's common with that one, and so it just divides and really just gives you 1. So all three, you can kind of see this as 1s, okay? And they multiply and they will stay 1. And they multiply with this last numerator that did not cancel. This will not cancel, it can't, because it would have only cancelled had you have another term here. Then that one would cancel with the denominator of the next one. But there was no such thing, so it's not cancelling, it's going to stay. So we have n plus 1 there, over, and now what's our denominator? The only denominator that didn't cancel was the 2. So over 2. So this that we have here, we just found the product. Okay, let's make sense of this now. The question is, determine all the values of n for which the product will be an integer value. What would be all the values of n for which this is going to be an integer value? Well, it's n plus 1 over 2. The only way that this can be an integer value, remember that they already told us what n should be. They said n is greater or equal to 2. So let's keep that in mind. So for this to be an integer, because the denominator is 2, the only way it can be an integer is if the top is a number divisible by 2. And numbers divisible by 2 are called even numbers. So n plus 1 will have to be even. Let me first state that. N plus 1 will be even. Okay, must be even, really, for all values of n. Okay, values of n. And we know that this is specifically where n is greater or equal to 2. Okay, but here's the thing. They didn't ask us to solve for n plus 1. They said solve for n. Tell us what n should be so that this will stay an integer. Okay. The only way we can do that is, let's look at what n should be. If n plus 1 must be even, then what should n be? N needs to be an odd number. N must be odd for all values of n, so it's really just the same thing, where n is greater than or equal to 2. Okay, so because if this is even, right, n is definitely odd, because odd number plus 1 gives you an even number. Okay, so that's actually what it should be. And we can test it out. Since I'm saying that n needs to just be an odd number that is, of course, greater than or equal to 2, then what I'm really saying is n can be numbers like 3, for example, or 5. And let's test this out and see if we plug it into this product that we found, n plus 1 over 2, will it forever give us an integer value? See, if you try 3, 3 plus 1 over 2 gives you 2. Okay, try 5. 5 plus 1 over 2 gives you 3. These are integer values. So that is true. N just has to be odd for all the values of n, of course, where n is greater or equal to 2. And I just noticed that with the n, it doesn't make sense to say n is greater than or equal to 2, because you see, if we are saying that n must be odd, then n can't be 2, because 2 is an even number. N has to be odd. So where n is greater than 2. Okay, so there. N must be odd for all values of n where n is greater than 2. And of course, that will also apply here as well, because if n plus 1 must be even, then this needs to be even. If it's equal to 2, 2 plus 1 is 3, which is odd. Okay, so it needs to stay even, therefore n must just be greater than 2, not equal to 2. Okay, so that would be the answer there. And that is it for this question 1. I wish you guys all the best for paper 2, and I'll see you guys in the next video. Bye.